risks or warming because they're paid either way. So there's a moral hazard issue there. Crop models, when we look at the issue of CO2 fertilization, which is actually missing from a lot of econometric studies on this, generally the picture is that crop models will say warming's bad, CO2 is good, precipitation doesn't really matter one way or the other. There are a couple of studies using the same data set beginning in 2014, 2017. The 2017 version of that analysis said that there will be huge negative effects globally from climate change, CO2-driven climate change, and that was influential in the Biden administration's decision to hike the social cost of carbon. I couldn't figure out, though, why the 2017 study had analyzed the same data as the 2014 study, but got completely different results, because the 2014 study said, no, the two effects roughly cancel each other out. So I got the data and reanalyzed it myself and found that the data set was missing most of the CO2 measures. And so when I went to the underlying sources and added them back in, reran the 2017 model, then the losses roughly disappear. So the outcome changed from the blue line sloping down. So again, it's warming on the horizontal axis, yield change on the vertical axis. And you can see the original study, there are losses at every temperature level. But then once I put the CO2 data back in, it moves up to the green line, which shows either no change or slight gains, even as far out as 5 degrees of warming. So that was a case where the data set was incomplete, and that affected the results. We look at managing the risks of extreme weather. Here, the story, it's well established in the literature, but cold is deadlier than heat. And so we cite a few studies on this, global studies, there's US studies. It's not really a controversial point, although, you know, we could have said there are 7 days in a week, and we'd have been flooded with criticism, given how people lost their minds over this report. But cold much deadlier than heat, which means that if you shift the temperature distribution up, yes, you will have more mortality at the warm end, but you will have a loss of mortality at the cold end. And so that was really one of our points, because there are lots of studies out there, and I'm sure you'll switch on CNN any night of the week, and it'll tell you that some new study has come out that says there'll be more deaths due to warming because there is a mortality effect during heat waves and during hot weather episodes, but they always leave out the other end of it, which is, okay, but if you're going to shift the distribution, tell us about all these cold weather deaths that will be prevented. So now on this subject, though, the key either way, whether cold weather or hot weather deaths, the key to resiliency is keeping energy costs down. And so we discuss about the studies that have shown that when energy costs go up, yes, the wealthy, they don't care, but poor households have to cut back on cooling and heating in their homes. And so these mortality effects are hitting the poor households. And so key to preventing that is keeping energy costs down. Okay, on to the social cost of carbon. Now, there are some people that just don't want to talk about it at all, and I can understand the complaints. I think of it as it's just a big if-then statement, okay? You've got a model, a bit of a black box, but you put a bunch of assumptions in one side, and a number pops out the other side. And so if all this list of assumptions hold, then the model says the magic number is 50. Sort of like Hitchhiker's Guide to the Universe, you know, the answer is 41. And so all those assumptions that you put in one side, they're not validated one way or the other by the number that pops out the other side. You have to discuss the validity of those assumptions. So that's where our attention is. If you choose a very low discount rate, so future damages count heavily towards the present, then you'll get a higher social cost of carbon. If you assume a high climate sensitivity, you get a high social cost of carbon. And on down the list. Now, in the original version of the report, I hadn't gone into some of these in as much detail as I should have. I have actually revised the chapter but due to the wisdom of the court, I'm not allowed to share this with you. But anyway, we can go through the list and basically make out the case why the most secure assumptions to put in on the left side of the model will typically give you a fairly low social cost of carbon. Not zero, but it's low enough that we're right back to the quote I said at the beginning, which is even if you fully priced this supposed social cost, it doesn't affect the economic growth path because no one's going to eliminate fossil fuels due to a calculation of the social cost of carbon. Okay, so, and this has been the story from day one. I've been about 30 years working in climate economics, and this just keeps coming up as the story. If you want to go the social cost of carbon route, you use reasonable assumptions, you get a social cost of carbon that raises the price of fossil fuels slightly, but not enough to seriously change the use patterns of fossil fuels. Okay, so to summarize, the data we have comes over the past 100 years or so. And while the world warmed, you can see the top left chart, those are the yields of important staple crops around the world, just marching up year after year. On the right, those are climate-related disaster deaths, which have collapsed to extremely low rates. And the bottom left, that's real income per capita around the world. Some parts of the world has just grown remarkably over the entire 20th century. Some of them, it's more recent. The growth pattern has kicked in. But while the world warmed, a lot of things improved and got better and continue to do so. So I would say that that quote from the IPCC in 2015 holds up very well. There will be impacts, but they will be small relative to everything else. So that is the economic content of the DOE report. Thank you.
Thank you, Dr. McKitrick. Would you please hold your questions until the end after all the speakers have had their chance, and then we'll have Q&A then. So it's my pleasure to introduce Dr. Judith Curry, who will be our next speaker, who's coming to us by live stream. Hopefully we get her up on the screen here shortly. And
Can we move these chairs out from in front of blocking the screen? You can't see the screen.
thank you, Dr. Klauser.
When I get up there, you won't want to see the screen.
Ben, do you guys want to sit here? It'll keep the whole thing. Oh, yeah.
That's a better arrangement. Thank you.
Okay, so we have Dr. Curry's presentation up, and without further ado, let's roll it. Right now, we should be playing the Jeopardy theme, I think. I could hum it if it helps. Do, 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 do. Anyway, they're working on it. We've had some trouble here at the hotel with the internet, and so it's kind of thrown a monkey wrench into the works. So I appreciate your patience while we get this all together. And if not, if we can't get that internet solved right now, we'll bring up our next speaker. I'll know in about 30 seconds or so. In the meantime, in case no one knows, I'm Anthony Watts. I run the biggest website in the world on climate. Thank you. There we are, Dr. Judith Curry. Thank you for being with us. And without further ado, please begin your presentation. She may not hear me. Can someone text her to say, go ahead? There we go. Hi,
Okay,
Judy.
hi, I'm here. I can't see anything on the screen, but I'm sorry I can't join you all. Hello, everyone. Today I'll provide some reflections on the recent report published by the Department of Energy, which I co-authored. Okay, next slide. You're all familiar with the apocalyptic climate narrative that is promoted both politically and scientifically. It can be summarized in this way. The Earth's climate is warming. A warming climate is dangerous. We're causing the warming by emitting CO2 from burning fossil fuels. So therefore, we need to prevent dangerous climate change by eliminating CO2 emissions. Now, in spite of the monolithic consensus that is presented to the world, most people attending this conference understand that there is substantial disagreement and uncertainty about the most consequential issues. How much of the recent warming has been caused by humans? How much the planet will warm in the 21st century? Whether warming is dangerous, and whether urgently eliminating the use of fossil fuels will improve human well-being. Unfortunately, for the past 2 decades, there haven't been any major players in the national or international policy world paying attention to these areas of disagreement and the associated uncertainties. Next slide. In the US, this rapidly changed when President Trump withdrew the US from the Paris Agreement and the UN Framework Convention on Climate Change. In evaluating US policy options, Secretary of Energy Chris Wright wanted a critical reassessment of climate science. Here is Secretary Wright's statement. What I found is that media coverage often distorts the science. Many people, even well-meaning ones, walk away with a view of climate change that is exaggerated or incomplete. To provide clarity, I asked a diverse team of independent experts to summarize the current state of climate science with a focus on how it relates to the United States. The report commissioned by Secretary Wright was published last summer, entitled A Critical Review of the Impacts of Greenhouse Gas Emissions on the U.S. Climate. The report was authored by a 5-member climate working group, which included myself, John Christie, Steve Koonin, Ross McKitrick, and Roy Spencer. Our report was submitted to the DOE on July 23rd of last year. Next slide. Our report to the DOE is relatively short by the standards of climate assessment reports, notably the IPCC reports and the U.S. National Climate Assessments. The DOE report critically evaluates key topics in the IPCC reports that have received inadequate attention. The assessment is data-driven and considers natural climate variability as well as human causes. Uncertainties and areas of disagreement are clearly described. This is not a consensus-seeking document. And finally, the report seeks some sane middle ground that realistically and apolitically assesses climate risk. Next slide. The report is organized into 3 parts, and I'll present some of the key findings. Part 1 describes direct human influences on ecosystems and the climate. The report documents global greening that has been observed from satellite over the past 4 decades. On this map, green, blue, and purple indicate regions where the leaf area index from satellite is increasing, indicating greening. This greening includes both natural vegetation and agriculture. Only a few regions in yellow indicate browning. Most of this greening is caused by increasing atmospheric carbon dioxide, with some help also from warmer temperatures and more rainfall. Now, if you're surprised by this finding, it's because the UN climate assessment reports barely mention this benefit of increasing carbon dioxide. Next slide. Another key point made in part 1 relates to the amount of carbon dioxide emissions. This figure shows scenarios of future emissions that are used in the UN climate assessment reports. There's growing acceptance that the extreme emission scenarios shown in red are implausible, if not impossible. These extreme emission scenarios have been abandoned since 2021 by the UN climate negotiators. The medium emissions scenario, shown by the green line, has been adopted as the current business as usual scenario. The medium emissions scenario, excuse me, is in agreement with the analyses by the Energy Information Administration, shown by the dotted lines. Nevertheless, scientific research and the UN climate assessment reports continue to emphasize the extreme emissions scenario in their projections, which produce unrealistically high temperatures. Climate scientists seem addicted to the extreme emissions scenario. Apparently, that is the only way that they can produce worrying impacts from human-caused emissions. Next slide. Part 2 of the report is on the climate response to emissions. Here are some summary points from this section. Strong recent evidence indicates lower values of climate sensitivity to increasing CO2. The report challenges climate models with observations, finding that global climate model simulations are not fit for policy-relevant purposes. The report challenges methods that are used to determine the cause or attribution of global warming and extreme weather events. Problems with the statistical analysis methods that are used are identified, and the report concludes that these attribution analyses inadequately assess natural climate variability. Next slide. The report provides a comprehensive analysis of U.S. extreme weather events back to 1900. Most types of extreme weather exhibit no statistically significant long-term trends. The figure on the left shows the frequency and magnitude of extreme heat events back to 1900. The worst U.S. heat events, by a large margin, occurred during the 1930s. During the 1930s, the U.S. saw not only the worst heat waves, but also the worst droughts, extensive wildfires, and the most intense landfalling hurricanes. These extremes during the 1930s were caused by natural climate variability, not by carbon dioxide emissions. Next slide. Since the catastrophic landfall of Hurricane Katrina in 2005, hurricanes have been one of the most prominent focal points for climate catastrophe. There have been many theoretical and modeling studies that suggest a worsening of hurricanes and their landfall impacts. However, the detection and attribution of any change in hurricanes is confounded by incomplete observations in the historical record, and also by multi-decadal natural variability. The longest and most complete data record is for Atlantic hurricanes. This diagram shows the number of hurricanes for each year back to 1920, with red indicating the number of major hurricanes that reach Category 3 or higher. Prior to the satellite era that began in 1965, hurricanes were underreported, with increasingly large underreported prior to 1944, when aircraft reconnaissance began. If you look at the trend since 1970, you definitely see it, excuse me, a trend in increasing numbers of hurricanes, and particularly major hurricanes. However, much of this trend is associated with a shift in 1995 to the warm phase of the multi-decadal oscillation. Prior to the 1970s, during the previous warm phase, you can see that there were comparable numbers of major hurricanes as in recent decades, even with undercounting. So if there is a signal from warming that is worsening hurricanes, this signal is too small to be detected against the background of multi-decadal natural variability. Next slide. Sea level is the one impact that is unambiguously associated with warming. Many convoluted analyses have purported to have identified a recent acceleration that is attributed to fossil-fueled warming. So let's take a look at the actual data. Here I show an example from the Battery in New York with a tide gauge record that goes back to the 1850s. After the Little Ice Age, global sea levels started rising in the mid-19th century, which is also reflected in the New York data. The amount of sea level rise in New York over the past century is 8 inches. The current rate of sea level rise is 3 millimeters per year, about the height of 2 stacked pennies. These numbers are similar to the global averages. You can see that the sea level rise at the Battery has mostly been linear, with periods of both lower and faster rates. The bottom figure shows the time series of the rate of sea level rise. You can see high rates of sea level rise in the 1930s and 1940s, with low values in the 1960s and 1970s. Values in the most recent 2 decades are comparable to the values seen in the 1930s and 1940s. Yes, if you only consider the data since 1970, you do see an acceleration. But if you consider the entire data record, there's nothing unusual about current rates or acceleration of sea level rise. It's difficult to get very alarmed over 8 inches of sea level rise over the last century. The alarm surrounding sea level rise is associated with future projections. In the lower diagram, the colored bars between 2020 and 2050 reflect 5 scenarios used by NOAA for the rate of sea level rise over the next 3 decades. Even the low scenario is almost twice as high as the observed rate over the last 2 decades. The high scenario is 4 times as high as the average rate observed over the last 100 years. NOAA purports to include the full range of plausible future scenarios. Apparently, NOAA regards as implausible near-term scenarios that would match the currently observed rate or would actually decrease to values observed in the 1960s. A reminder, this is for the period 2020 to 2050, and 5 of those years have already occurred. This simple analysis challenges projections of large accelerating rates of sea level rise. Well, we shall see in a few decades how this plays out. Next slide. Well, part 3 of the DO report is impacts on ecosystems and society. And Ross McKitrick has already presented a very interesting and illuminating description of what we wrote in that part. Next slide. If I can speak for the 5 authors of the report, here are our hoped-for outcomes in writing this report. We're seeking to promote open, respectful, and informed debate on climate science and its uncertainties. We hope to redirect climate science away from alarmism and advocacy and towards better understanding of the fundamentals of climate dynamics and better data analysis practices. We hope to motivate future climate assessment reports to address important issues raised by the DOE report that have previously been ignored or inadequately assessed. Next slide. It won't surprise you to learn that this report caused certain heads to explode. There was predictable outrage in the media with ad hominem attacks on the authors and criticisms of the process. Predictably, a lawsuit was filed against the Department of Energy. 2 advocacy groups, the Environmental Defense Fund and Union of Concerned Scientists, sued the U.S. Department of Energy, alleging that the Climate Working Group was assembled in violation of Federal Advisory Committee Act, or FACA. The court agreed, although it did not grant injunction against use of the report. The DOE dissolved the Climate Working Group, on September 3rd in response. The 5 climate working group authors are committed to responding to the comments. We are currently working independently on revisions and are preparing a revised report. Next slide. The 5 authors are in the process of responding to technical comments. More than 1 million comments were submitted online to the Department of Energy portal. It is no small challenge to evaluate those. Some scientists emailed us directly with their comments, and there were 3 comprehensive response documents. One coordinated by Dessler and Kopp with comments from 86 scientists. The Carbon Brief organized comments from 56 scientists, and the Competitive Enterprise Institute also provided a comprehensive review. Many comments were strongly positive, praising the document and the Department of Energy for undertaking this report. Those weren't the comments that you saw in the media, though. There were also many critical comments. From our reading of the critiques, they did identify a few genuine flaws and errors. They provided some useful suggestions that strengthen our report. But most of the comments merely doubled down on consensus enforcement without addressing our critiques. In the end, none of the submitted comments supported changing our major conclusions. Next slide. The objectives of the DOE report were to assess the science and not to make any policy recommendations, although we did focus on policy-relevant aspects of climate science. So with this more objective and less alarming climate assessment report from the Department of Energy, I would like to close with some personal reflections on climate risk and policies. Risks from climate change and extreme weather are fundamentally local. The risks are entwined with natural climate variability, land use, and social vulnerabilities. Blaming weather catastrophes on fossil fuel emissions deflects from the real causes of our vulnerabilities, which include poor risk management and bad governance. And finally, many people fear a future without cheap, abundant fuel and continued economic expansion, far more than they fear climate change. The main inconvenient truth about the UN climate and energy policies is that they propose an unworkable global solution to what are local problems. The urgency of meeting net zero targets is causing us to make bad choices about future energy systems, particularly with regards to restricting natural gas and nuclear power and promoting wind and solar power. And finally, if we somehow reach net zero by 2050, we will notice little, if any, change in the climate before 2100 relative to natural climate variability. Thank you. And stay tuned for the revised report from the Climate Working Group that we plan to publish one way or another before the end of 2026.
Thank you, Dr. Curry. It was a pleasure to have you here and address those concerns. Remember, hold your questions until the end of the segment. Our next speaker is Dr. Benjamin Zycher, and he is going to talk about some other aspects of the report, and I'm sure he will be enlightening. Here you go, sir. Here's your clicker.
Well, thank you very much. It's a real pleasure and honor to be here today. I'm especially honored by the fact the audience is much better dressed than either me or Ross. So Heartland asked me to talk about the 2009 endangerment finding in the context of the DOE critical review that Judith just summarized. I will lay my cards on the table immediately. The 2009 endangerment finding is not the most dishonest exercise in political analysis that I've ever seen in the Beltway, and I'm older than most of you, trust me. But it's down there, or up there, however you want to. Let's see, how do I advance this? There we go. So what I want to talk about today is, what did the EPA assert in 2009 in support of their finding that greenhouse gas emissions reasonably can be anticipated to endanger human health and welfare, the public health and welfare. And then what does the evidence, both before and after 2009, tell us? And I'm going to talk in summary fashion about the general evidence and also the evidence presented in the critical review, almost all of which is quite consistent. I want to talk about the de minimis problem. What can we say about the impacts of U.S. Greenhouse gas emissions in the context of the endangerment finding? It turns out that if you think about it the right way, which is to say, if you think about it the way that I do, then the argument that even total U.S. greenhouse gas emissions, let alone emissions from vehicles or emissions from Section 202A vehicles, and I'll explain what that means in a few minutes, endanger public health and welfare is preposterous. I want to talk about the greenhouse gas emission scenarios that the EPA applied in 2009, because they're interesting in their own way, and then offer a few conclusions. So what did they assert in 2009? They said that because of increasing atmospheric concentrations of greenhouse gases, there would be an increase in smog, ambient ground ozone. There would be an increase in the numbers and intensities of hurricanes, and they claimed, EPA in 2009, that there was some evidence of increasing intensities of Atlantic hurricanes. I'll get back to that in a minute. There would be an increase in flooding. There would be an increased likelihood of heat waves. The heat wave argument in particular, I think, is very, very strange in the context of standard textbook atmospheric physics. And I'll get to that in a few minutes. There would be an adverse net impact on mortality from heat and cold. This is, again, what EPA argued in 2009. There would be more wildfires, more droughts. There would be adverse effects on both U.S. and global food production. There would be adverse effects on U.S. water quality. There would be an acceleration in sea level rise. That's basically what they argued. So what did the data tell us? That, well, EPA reports beginning in 1980, in other words, long before 2009 and thereafter, there's been almost a monotonic decline in smog and ground ozone over the entire period, 1980 to 2025. EPA obviously knew this in 2009 and simply ignored it. With respect to hurricanes, Ryan Maui in 2011, I guess, published a paper summarizing the satellite evidence on hurricane numbers and intensities from the satellite record that began in 1973, and then he updates that every month. And the same data are cited in the DOE critical review, and as a crude generalization, there's no trend beginning in 1973 in the numbers of global cyclones and in the intensities of global cyclones, a metric called accumulated cyclone energy, which is basically a wind speed index measuring the destructiveness of any given hurricane or any given hurricane season. The same data are cited in the Energy Department critical review. NOAA, in its data set, the National Oceanographic and Atmospheric Administration, publishes the Atlantic hurricane intensity trend beginning in 1967. And that intensity trend is basically driven by three outliers, 2005, 2010, and 2020. And so, as Judith mentioned during her presentation, the critical review notes a substantial undercounting problem before 1965. So the EPA assertion in 2009 that there is some evidence of increasing intensities of the Atlantic hurricane record is based upon 1 year, 2005, which tells you everything you need to know about the quality of the statistical analysis that EPA applied in terms of arriving at its conclusions in the 2009 endangerment finding. IPIC in the most recent assessment report in terms of flooding said, quote, they have low confidence for observed changes in the magnitude or frequency of floods at the global scale. The critical review offers the same citation. Hirsch and Ryberg in a paper, I guess in 2011 in Geophysical Research Letters, I think that was the journal, found no statistical correlation between atmospheric greenhouse gas concentrations and US flooding. The critical review argues that there is no, quote, robust evidence that these trends are attributable to human influences. EPA in its data shows no trend in the heat wave index beginning in 1895, except for the 1930s, as Judith noted, and the U.S. Climate Reference Network, which is a system of meticulously maintained temperature stations across the U.S. and in Hawaii and Alaska, shows no temperature trend for the 20-year period, 2005 to 2025. I'd be a little careful about drawing conclusions from that. 20 years is not very much, and we need to wait. But nonetheless, those data I think are interesting. I wouldn't draw too many conclusions from it, but they're interesting nonetheless. The critical review in figure 6.3.3 in the period beginning in 1898, there's no trend in record highs and fewer record lows. Now, I mentioned that the heat wave argument from the alarmist community is very strange because my understanding of standard textbook atmospheric physics, and I'm but a lowly economist, so maybe I'm getting this wrong, is that the effects of increasing atmospheric concentrations of greenhouse gases are predicted, again, in standard textbook atmospheric physics to be observed for the most part in the northern hemisphere, in the coldest, driest air masses, in other words, Eastern Asia and Western North America, in the winter. And so you shouldn't really be seeing increases in average high temperatures. What you should be seeing are increases in average low temperatures, and those are two very different phenomena. That's what the critical review reports, and Steve Koonin, one of the authors in his really excellent book, Unsettled, I recommend it highly, points out that since 1900, average high temperatures have barely changed at all. It's average low temperatures that have increased. And so what the alarmists have resorted to is a statistical trick. They claim that the ratio of average highs to average lows has increased, which is true, but that's only because average lows have increased. Average highs have not increased at all. And so that is a statistic that is fundamentally misleading. With respect to the effect on net mortality, the Lancet has published 3 major international studies reporting cold-related deaths at least an order of magnitude higher than heat-related deaths. The critical review offers those same citations plus others in its figure 10.2. You know, Bjorn Lomborg, who's a very, very smart guy, he drives me nuts every time, because everything he writes, he starts out by saying that global warming is an important problem and we need to do something. And then he proceeds to show why it's not an important problem and why anything we do wouldn't matter anyway. And so, I mean, I've told this to Bjorn any number of times, and he just won't listen to me. He's a lot like my wife. He points out that for the US, annual heat and cold-related deaths are respectively about 9,000 and 144,000. The critical review reports sharp declines in US heat-related mortality for various periods and with various citations. With respect to wildfires, the National Interagency Fire Center reports about a 75% decline in the number of US wildfires since 1926 and no trend since 1985. They stopped publishing the data before 1985 on the purported grounds that the data are different. There's been a change in definitions, which is sort of true, but I think not really relevant. I think they should not have stopped publishing those data. You can still find them, and I have them. They also reported about an 85% decline in US acreage, a slight increase since 1985, and that is obviously due to government forest mismanagement. You know, I was on one of the NPR radio stations, I don't know, 5 years ago or so, debating climate issues with some robot from the Sierra Club. And this young lady was absolutely adamant that the wildfire problem was the result of climate change, increasing atmospheric concentrations of greenhouse gases. And so this was on the air. I asked her to explain to the audience why increasing atmospheric concentrations of greenhouse gases should be predicted to have adverse wildfire effects vastly greater in government forests than private forests. And when I asked that question, there was a silence on the radio for what seemed to go on for an hour, obviously didn't. It was a few seconds, at which point the moderator, the NPR moderator, jumped in and tried to save her. And being the chivalrous sort that I am, I said, no, let's give Ms. Smith, or whatever her name was, all the time she needs to answer that question. And they cut to a commercial, and I never, anyway. It's always fun debating those people. With respect to global wildfires, NASA reports a 25% decline in global wildfire acreage for the period beginning in 1998 and ending in 2015. The critical review in its figure 6.8.1 shows no global trends since 2001. Are we really going to enforce the time limit? I don't have to shut up. So the EPA, with respect to drought, the EPA reports no trend in the US Palmer Drought Severity Index since 1985. And the critical review reports a very similar data set. It's not the Palmer Drought Severity Index, it's a different data set, but it shows the same trend since 1895 in its figures 6.7.1. Vicente and Serrano and a bunch of other co-authors show in a paper in the Transactions of the Royal Society an approximate decline in the surface area global drought since 1950 of about 0.5% per decade. The critical review reviews what the IPCC says in the 6th assessment report. A few AR6 regions show observed increases in meteorological drought. The UN Food and Agriculture Organization reports an increase of global food production per capita, per person, of about 39% since 1980. The US, about 15%. There's no direct discussion of food production in the critical review that I saw. If I'm wrong, Ross, I need to hear that, but I didn't find anything in the critical review on food production. The GAO, with respect to US water quality, basically says there's general improvement, but threats remain. And what those threats are supposed to be, no one knows. With respect to sea level rise, there's really no clear answer in my reading of the literature. The alarmists tried to take the earlier tidal gauge data and tack on the satellite altimeter data and claim there's been an acceleration because the tidal gauge data show an annual increase, an annual rise in sea levels of about 1.9 millimeters per year. The satellite data show about 3.3 millimeters per year. And so they claim there's been an acceleration. Well, the two data sets are not comparable, and so they really can't mash them together. The critical review points out, I think appropriately, that the largest US increases are driven by land subsidence, not increasing atmospheric concentrations of greenhouse gases. Is the further matter that the extreme projections for sea levels are driven by implausible extreme emission scenarios, representative concentration path 8.5, which I'll get to in a minute. Voortman and DeVos in a recent paper show that there's no statistically significant acceleration globally in sea level rise. I'd be a little careful. Too many of our allies have jumped on that paper and endorsed it. The authors are quite careful to point out that the data are lousy. And so I'd be a little careful about endorsing that paper or its findings. And the larger problem is that sea levels are driven by both natural and anthropogenic or man-made causes. What's the mix? Nobody knows. The implicit or explicit assumption on the part of the alarmists is that everything that happens is caused by man. That's just silly. There are lots of things that happen naturally. So the data largely refute the assertions made by the EPA in 2009, both in the years leading to 2009 and subsequently. And so I think the Trump administration is quite right to rescind the 2009 endangerment finding because it is, just in terms of its data analysis, it is arbitrary and capricious and should be rescinded. There's also the de minimis issue. How much, the argument that US greenhouse gas emissions can be seen to threaten public health and welfare is just silly. If you use the EPA climate model, the model for the assessment of greenhouse gas impacts of climate change, version 7, which I run all the time, eliminating all US greenhouse gas emissions by 2050 would reduce global temperatures in the year 2100 by something on the order of 14/100ths of a degree. And that's under really quite assumptions that exaggerate the effects of greenhouse gas emissions. If you use an assumption much more consistent with the peer-reviewed literature, you wind up with about 1/10 of a degree. That would be not measurable because that's about the same as the normal variability or the standard deviation of the service temperature record. If you eliminate the endangerment finding refers to new vehicles, which means not pre-owned, basically, is what that means. You get 24/1000ths of a degree. And so even though EPA in 2009 admitted explicitly that trivial effects might not be subject to regulation, they went ahead and did it anyway, even though their own model says that the effects are not measurable. For that reason, the argument that US greenhouse gas emissions may reasonably be anticipated to endanger public health is just preposterous. And that's why EPA lied. I mean, that's the way to put it, about conflating global US vehicle and Clean Air Act Section 202A vehicle emissions. They lied when they said in their Table 1 that Section 202A greenhouse gas emissions were about 23.5% of all. That figure applies to all US vehicles, not Section 202A vehicles. So again, on that basis alone, the endangerment findings should be deemed arbitrary and capricious and rescinded. I guess I'm running out of time here, and I want to leave enough for Q&A. The emission scenarios that EPA used in 2009 as a crude generalization were even more preposterous than representative concentration 8.5, which IPIC itself admits is unrealistic. It's worse than merely unrealistic. It is literally impossible. So anyway, the endangerment findings driven by models that overstate the tropospheric temperature record by a factor of over 2.5, emission scenarios that are essentially impossible. The endangerment finding is not supported by the evidence on climate phenomena. US emissions are too small to reasonably be anticipated to endanger public health and welfare. In general, the analysis underlying the endangerment finding is very poor. It should be rescinded. Thank you very much.
Thank you, Dr. Zycher. That was very informative. I'd like to point out that the facts that were presented here in these three presentations, many of them are available in our book, my book, Climate at a Glance. Climate at a Glance is available on the table out here. You can take a copy home, or you can also visit climateataglance.com and get a lot of these same facts. And so you're welcome to visit or pick up a copy of the book. I'd like to mention to everyone that as soon as we finish the Q&A, we have to clear the room out really quick because they got to set up for lunch. So I'll make that announcement again right as we finish the Q&A. One other thing I want to point out for those of you that might be confused about which ballroom has which sessions and so forth, this one here always has the A sessions, and the one upstairs, the Bill Gray room, has the B sessions. And I'll be speaking at one of the sessions this afternoon at about 2:20 in the ballroom upstairs, as well as tonight during the dinner. Okay, so let's open it up for Q&A, and we'll go from there. Yeah, we'll have a microphone going around to people, and there we are, some in the back.
You want to move around? I don't want to block you. That's because you're so much better looking.
Oh, you're first.
Please mention who the question's for, and then state your question, please.
Dr. McKitrick, why do the warming land prices diverge from the warming rent prices?
The quick answer would be that the land sale values are affected by the nearby growth of cities and other uses of the land besides agriculture, whereas the agricultural land rents are confined to area that's strictly used for agriculture. Now, I think that's probably enough for our purposes. To explain more, I'd have to go into more detail about the papers itself, but that was the premise of the author's investigation, that land resale values can be driven by things other than agricultural productivity.
This is also for Dr. McKitrick. You talk about the low level of economic impact of warming over that period of time. But there's also a cost to mitigation, right? And it's considerable. I mean, these things inconvenient things we like to refer to as trade-offs, they're significant here. So did any of the work take into account what the what mitigation costs would be relative to costs of doing nothing.
Yes, and I didn't discuss that literature much here, but there is discussion in the report. Obviously, mitigation is very costly for CO2 particularly, because we can't decouple it from fossil fuel use the way you can decouple sulfur and particulates from fossil fuel use. And so when you plug those costs into the integrated assessment models, that's where this result comes back that you can justify removing some of the fossil fuel use that has very little social value attached to it. You can justify eliminating that. But for the most part, what those models have told us is you just live with the warming because trying to stop it is way too costly.
Hi, Ronan Connolly here. This is for any of the panelists who feels to do it. One of the things is the urban heat island. If you're looking at heat waves, then the urbanization itself leads to a considerable increase in heat waves, but that's a localized effect, which doesn't affect the country or the globe as a whole, but it does affect where the majority of the population lives. And so and it's nothing to do with carbon dioxide or greenhouse gas emissions. So I'm wondering, was this discussed, and do you have, does it have relevance for the DOE and various assessments like that? So.
Could you bring the microphone up here as soon as he's done? We have,
Maybe
come on now. Yeah, we have a couple questions right up front here.
Should we address that?
Dr. Klauser right here, our Nobel Prize winner, has a question.
Anthony, should we address that?
Oh, okay.
After this one.
All right.
Go ahead.
Maybe Judy could answer that question.
Can you repeat the question, please? The urban heat island?
So in terms of heat waves, the urban heat island can lead to an increase in heat waves where in urban areas where the majority of people live. Can you hear? Sorry?
Yeah, I can hear you.
Yeah.
Absolutely, that's going on.
Yeah. So, but this hasn't anything to do with greenhouse gas emissions, and so, but it does affect where the majority of the people live, both in the U.S. and worldwide. And so, has that been considered in, say, the
Well,
DOE?
it's been, okay, it's by blaming everything on CO2 emissions, we're ignoring the real causes of our problems, which is covering our cities with cement, no trees, these kind of things. So once you blame everything on CO2 emissions, it gives you, a get out of jail free card for, dealing with the real problems, which relates to how you manage and construct your built environment. So, there's lots of ways that this is being managed with green roofs and planting more trees and painting things white to reflect solar radiation. There's lots of simple things that many cities are trying. But again, it's local, sensible risk management, trying to manage your local problems and not trying to put all your faith in this top-down solution from the UN of eliminating fossil fuels to solve all your weather and climate-related problems, because it's just a very bad solution. It makes us ignore the real causes of our problems and simple, meaningful solutions that we could employ.
I have two questions. First one for Dr. McKitrick is, okay, you were talking about the social costs to agriculture, but totally left out, and I think Professor Happer will mention this in the next session, is this huge cost of this banning of nitrate fertilizers. I mean, it is totally wiping out agricultural economies with an enormous social cost. Second question is for Dr. Zycher. one of the important questions that has never been, doesn't seem to have ever been addressed regarding the sea level rise. There is a very easy experimental way of checking this, which has been totally ignored. The world has two clocks for many years now. One is an atomic clock held by the various bureaus of standards, and the other one is the astronomical clock. We base our civil time on the atomic clocks, and the Earth's rotation rate changes with time. And so we occasionally keep them in sync by every few years adding or subtracting a leap second. Now, the important thing to notice is if we really, well, first off, you can't have sea level rise differently in different cities. This violates Archimedes' principle. This is totally ridiculous. More importantly, if you have sea level rise, you got to conserve the amount of water on the face of the Earth. The water will migrate from the northern climate, or the polar areas, to the equatorial areas. That will increase the diameter of the Earth at the equator, and that will be like a skater, figure skater letting her arms out. That will slow the rotation rate down. Now, it turns out in the last 30 or so years, the Earth's rotation rate has been speeding up, not slowing down. So, which is totally impossible if we had sea level rise. You can see straightforward to calculate those numbers, and it goes the wrong way. So, first nitrate.
We didn't discuss the nitrate fertilizer issue. You're absolutely right, though, that the Haber-Bosch process is really central to global agriculture. And I guess there was one country, I think it was Sri Lanka, that in the name of saving the environment decided to ban artificial fertilizers, and that policy lasted for precisely one growing season. And then when famine and crop failures hit, they decided to rethink that issue. But that is one of many topics we didn't cover in the report.
Well, your question to me presupposes a level of sophistication on sea level rise that I do not have and can really not aspire to, frankly. The only really work I've done on this is on the statistical problems presented by the conflation of the tidal gauge data, which doesn't really measure sea level anyway. It measures the difference between sea levels and some point on land that's supposedly fixed, even though it's not fixed because of seismic activity and all the rest, versus the altimeter, satellite altimeter data. Just as a footnote, I guess, I am really rather dubious that we can actually measure sea levels down to 1/10 of a millimeter from the satellites. Huh?
It can be done with the clock.
Well, I'm just dubious about that. But in any event, I really cannot address your question, as I just don't know enough about it in terms of Earth's rotation. Here.
So, my question or remark regarding the economical factor of climate change. So, we as humans are extremely successful on Earth, not because we've learned how to control climate or other phenomena, because we haven't. It's time to admit it. Well, but we are successful because we learned how to adapt. And it was always the major factor of progress, actually. And if I may give an example of what we are doing in Poland, I'm from Poland. Well, we've just started producing extremely sophisticated, innovative biofertilizers, which help plants to absorb, retain up to 30% more water. And we are introducing it now in African countries with extreme success. So it opens quite new perspective for agriculture. So, and my presumption is that climate alarmists, they want to stop climate change just to do business as usual with artificial fertilizers, with chemical as we use them so far, and so on, so on. But it's good to show the better way, which is adapting to phenomena on which we don't have impact as humans, really, as we always did as humanity.
Yeah, and I think you're making a similar point to what Judy talked about as far as adapting the urban environment, doing a better job that way, and that would apply to flood management as well. But with regard to agriculture, it's not an area that I knew a whole lot about, but then in the aftermath of the report, having a chance to talk to people in the agricultural field who've made similar points, that there are just huge advances not only have already been made, but are foreseeable in the near future in terms of crop breeding and agricultural management that just go to this point that we can thrive in all kinds of climate settings and take advantage of the weather as it stands rather than ridiculous ideas that we can change the weather over time.
Yeah, I'm sorry,
Okay.
did I interrupt you?
No.
We have one more.
There's
time
a
for
larger...
One more.
Oh.
Go ahead.
Do you mind? There's a larger philosophical truth in your observation, which is that the climate alarmist stance at a philosophical level is fundamentally anti-human, in the sense that the adaptation and other technological processes or advances that you summarize are driven by human ingenuity and inventiveness and the alarmist view is that humans are little more than environmentally destructive mouths to feed, without moral standing, without the inventiveness, ingenuity, and intelligence to solve problems. That is the basic philosophical stance, which is inconsistent with the adaptation model. You know, the Nazi term was useless eaters, and that is literally how the environmental leftists view humanity. And so I think that your point is really both true and too narrow. And you really ought to, I think, if you make that point again in other audiences, I would expand it.
Okay, we have one more question over here. We're running short on
this has to do with Dr. Zycher, the wildfire data, which was erased in 2021 from the Forest Service website. Does anyone show any shame for doing that? I mean, I guess the question was, it was just erased, and they picked 1983 as being the date they would do. But it seems like in most scientific things, you would at least say, yes, we erased the data, and here's what it showed. Because it was I think it was 50 million acres in the 30s, and now it's 5 to 10 million acres.
Asking for shame on the part of government bureaucrats is, I think a bridge too far. Their argument is that the definitions have changed, and therefore the data are not comparable, and we shouldn't be appending the data. It is true the definitions have changed, fine. That does not mean you stop publishing the data. That means that you have a footnote to the effect that the data for 1926 are somewhat different than the data for 1990, and you need to keep that in mind. But here are the data, and interpret it as you will, but keep all the caveats in mind. And then you publish papers explaining why the change in what the implications of the change in the definitions implies, right? They've not done that. So they should be ashamed of themselves, but getting them to admit that, I think, is.
And then the corollary is, with the Trump administration, is there any likelihood that that will be done, just as you described it?
Is the National Interagency Fire Center, is that a federal? Yes. Huh? Yes. It is? I don't know. It may be an issue too small for the Trump administration to deal with, to pay attention to. I don't know.
Okay, so we're running out of time. So I want to ask you, who can give me a question in 30 seconds or less? And that person will get the next and final question. 30 seconds or less to asking the question.
Make it succinct. Okay.
Yeah, that's a random number generator down there. Huh? That's a random number generator.
In your opinion, what is the best argument that the other side has that we are wrong?
Well, I can say what came up at a debate that John Christie and I and Steve Koonin were in with Andrew Dessler at the University of Texas. And I think Dessler's overall point, it was a bit hard to follow at points, but he said something to the effect of, you're just willing to risk it all on your theory that you're right. And it was kind of a boogeyman about the terrible future that might be a worst case scenario. And now I could go into why that's still not a very good argument, but I think that's ultimately all the talk about tipping points and nonlinearities. It's kind of, what if there's some unforeseen change that happens that makes this 10 times worse than we imagine? What if that? I think that's where they end up at as far as their retreat position.
Right.
Dr. Curry, if you want to speak on.
You know, I went through this at great length in my book, Climate Uncertainty and Risk. The climate scientists have a very naive understanding of risk and risk management, which leads them to come up with all these implausible, crazy scenarios and think that we need to drop everything and deal with these scenarios rather than putting in place a sensible risk assessment and risk management protocol. So it's just, you know, alarmism for whatever purposes I don't quite understand, but it's just a complete naivete about risk assessment and risk management.
Okay.
Well, it's actually worse than that. I can think of, off the top of my head, probably a dozen low probability catastrophes: a meteor strike, mass volcanic eruptions, bioterrorism, mass earthquakes and tsunamis. I mean, the list goes on. Should we spend 3 or 4 or 5% of GDP on each of them in order to try and, quote, do something? No, of course not, because we would all die, which is actually, from the viewpoint of the climate left, not all that bad an outcome. But yeah, that is their major argument. There is some probability greater than zero that we're really headed toward a catastrophe and we need to do something. And the fact that we really can't do anything at any cost that makes any sense at all is really irrelevant in that analytic framework.
Okay, thank you very much. All right, so at 11:50, we will have lunch in here, and I get to say something now that I've always wanted to say, like a judge gets to do. Clear the room.
everybody, they are starting to reset this room for lunch. So if you would like to eat on time, please exit the room now and take all of your things with you. Thank you.
Ladies and gentlemen, please welcome to the stage, Gregory Wrightstone.
Hello. Oh, it's my distinct pleasure and honor to introduce our luncheon keynote speaker, Dr. William Happer, but he's better known to everyone here in this room simply as Will. He received his PhD in physics from Princeton University, is now professor emeritus at the Department of Physics at Princeton. He began his academic career in 1964 at Columbia University as a member of the research and teaching staff of the physics department, and in 1980 joined the faculty at Princeton University from 2000 until his retirement in 2014. He held the Cyrus Fogg Brackett Chair of Physics at Princeton. He's published over 200 peer-reviewed scientific papers. He's a fellow of the American Physical Society, American Association for the Advancement of Sciences, National Academy of Sciences. He was awarded an Alfred P. Sloan Fellowship in 1966 and a number of others. And he's asked me not to belabor this. I could go 20 more minutes, as you know, if you know anything about Will Happer, talking about his notable achievements. But I would advise you to go to the booklet you have to describe more fully his achievements and throughout his lifetime. He founded the CO2 Coalition in 2015. We celebrated our 10th anniversary last year, and he's now serves as its chair. And it's been a great honor to work closely with him over the last 5 years to build the CO2 Coalition into the preeminent scientific organization in the world that's fighting back against the climate nonsense. And I just have to tell you, the more I learned about this man and his unique life story, I became convinced that his life story needed telling, and it was a lot of arm twisting to get him to agree to it, but we're in the final stages of completing a biography of this man's life story. It should be, it goes from his birth and early life in India to Scotland to Carolina, and then his achievements throughout. It's really a compelling story that we'll have that hopefully by late May be available. So what descriptions do I use to describe our keynote speaker? He is likely the wisest, most humble, and brilliant person I have ever or will meet. So I give you our keynote speaker, my mentor, colleague, and trusted advisor, Will Happer.
Well, I'm supposed to be wired up for a mic. Can everyone hear me? Yes, good. Well, my poor wife, Barbara, will have to live with me after that introduction, Greg. You should apologize to her. But thank you, very kind. And I'm going to talk to you today about a visit that Barbara and I made to New Zealand a couple months ago. And it was probably in part due to Tom Sheehan, who's here somewhere. I don't see Tom, but there he is. So Tom had made a similar trip to New Zealand and had met many friends, and they invited Barbara and me to come, and we certainly enjoyed it. Thank you, Tom, for your help. And the issue was that New Zealand is a huge agricultural country. It grows lamb to feed the world. It grows butter, milk, wool, and they're under tremendous political pressure from the virtue signaling local elite, you know, to stop their cows from burping and their sheep, you know, methane. And so, I know how methane works. You know, I've spent my career working with how methane absorbs radiation, and so I knew a lot about it. And I decided to go and try and help them argue with their local politicians that this is really a waste of time, waste of resources. So if I could, let's see, let me get the next slide if I can. So here's a summary of the talk. It's true that cattle emit methane. They have to emit methane. You know, we'll say more about why that's so. But it really almost doesn't matter to the climate. For example, New Zealand has set a target to reduce methane emissions by 14% over the next decade or so. The effect of that would be to lower the temperature of the whole Earth by 0.00001 C. So you have to ask yourself, why are we doing this? You know, is there any reason the Earth cares whether the temperature is, 0.001 lower or higher? Of course it doesn't. It's a complete madness. And you can ask the next question, and that is, suppose you go the whole way. Why this puny 14%? Let's kill every cow in the world. We'll kill every sheep in the world. Kill all the ruminants. They're all burping methane, that evil gas. And how much will that affect the temperature of the Earth? Well, it would only lower the temperature of the Earth by 0.05 C. You can't measure that. So in spite of what you hear about methane, it's all nonsense. It's not true. So this is not, of course, the first fanatical attack on cattle. Cattle have been our friends for, millennia, and thank God for cattle. But here's a cautionary, well, let's see, a cautionary tale here. I first learned about this incident, by the way, from a little pamphlet that was published by the Heartland Institute due to Joe Bast. It was called Roosters of the Apocalypse. And it turns, it's a terrific thing. I think you can probably still find it on the internet. But in 1856, this young woman, Gwasi, who was a member of the Xhosa tribe in South Africa, had a vision that if her people killed all the cattle, that it would cure every possible ill that was affecting her tribe. You know, the white settlers would be driven into the sea, the cattle diseases would stop, they would have new cattle coming back from the dead. And people believed her, especially the elite. And so they forced everyone to slaughter their cows. They slaughtered hundreds of thousands. The result was hardly surprising. 80,000 people starved to death the next year. They didn't have enough to eat. And it resulted in the political collapse of the Xhosa society. Made it very easy for everyone else in South Africa to take advantage of them. I should point out that she made these predictions when she was about the same age as Greta Thunberg. Okay. Well, let me just summarize the results of this talk. We wrote a little paper after the trip that Barbara and I took, and the authors included a Spanish speaker, Albrecht Glatzley, who some of you probably know. And Albrecht has translated the basic results of our paper into Spanish. And so this is for our friend Doug Pollock and anyone else who speaks Spanish in the audience. But it summarizes these ridiculously small changes of temperature that you get from killing all the ruminants in the world. It really doesn't make any difference. The co-authors were Deborah Alexander, who was my host in New Zealand, Jim Ferguson, who's a veterinary nutrition specialist from University of Pennsylvania, Albert Glatzley from Paraguay, myself, and William Van Weingarten, Canadian. So it's an international team. So here are the poor cows who are under threat. Okay, so I'll try and keep this not too long. It's after all a lunchtime talk, but I will say a little bit about biochemistry. Quite interesting, why you have to emit methane if you're a cow. A little bit about radiation transfer physics, which is what determines how the methane affects the temperature. Answer is almost not at all. And then if there's time, we'll have some questions. So here is a Princeton physicist cow, and it's a cartoon. But the main thing about a cow, if you look at a cow, he's got this huge belly. And the belly is to make room for the rumen, this enormous stomach, which is where the forage first goes. And the stomach is anoxic. There's really no oxygen in here. And so after the cow has eaten this fill in the pasture, it sits down, or she sits down, and she ruminates. She burps up cud from the rumen, chews it, and as she chews it, methane bubbles out of the cud into the air. So it's true that cows are producing methane, yet they can't avoid it. And all sorts of other things are going on in here, but I would point out that the reason the cow emits methane is that the last step in digestion in the rumen here is combining hydrogen and CO2, which are produced by this zoo of microorganisms, to make methane and get a little topping energy out of here. The cow gets energy from making methane. If you stop it from making methane, then it doesn't get as much food value from its forage. And the reason for that is that, unlike us, cows can digest fibers, cellulose, so let's talk a little bit about why there's cellulose in the world. Cellulose is actually made of sugar. It's the same thing we were having for lunch here, glucose. So for example, I can eat all this paper. I like it. Doesn't give me much nourishment. But a cow, if it eats this, gets some nourishment, right? So both the paper is made of glucose, just like my dessert. But I can't get food value. So let's remember, how does photosynthesis work? Well, sunlight comes in and is used by the plant, by the chloroplast in the plant, in a little factory that takes hydrogen from water. It has to take some energy to do that, so the energy comes from the sunlight, takes off the hydrogen atoms, and it attaches them to NADP to provide hydrogen to make sugar later on in a second factory. And at the same time, this little chloroplast factory makes energy, which is transmitted as ATP, down here. So this is the output of the factory, the input, which is water and sunlight. Then there's a second factory in the cell, and this factory uses the hydrogen that's been produced by sunlight and the energy produced by sunlight to combine carbon dioxide and water to make sugar, to make glucose. So that's the basic step. So the basic product of photosynthesis is always glucose, a 6-carbon sugar here, down here. You can think of it as a polymer of a carbohydrate. It looks like it's a carbon attached to a water molecule, but actually a slightly different arrangement. Now, glucose can be a linear molecule like this, but most of the time it folds back on itself to make a ring. So the great majority of the glucose in your dessert is in one of these forms, this form or this form. A percent or so is linear. And there are actually 2 ways that it can form a chain. In one way, where the chain closes, an OH is on the bottom, a hydroxyl on the bottom. The other, it's on the top. So this is called alpha glucose. This is beta glucose. Both of these are fine. We can eat either of them. This is about 60%. This is about 30%. Polymers of this are starch. So bread is a polymer of glucose. It's easy to digest starch. If you chew on a piece of bread, which is starch, then it starts tasting sweet. That's because just the saliva in your mouth is breaking apart this polymer to make sweet glucose. But you can also make a polymer out of beta glucose, which is 60%. It's the most abundant one in life. And that makes cellulose, that makes paper, or wood, which you can't digest. But the cow can. So that's the magic of ruminants, that they can digest this chemical, which is the largest part of primary production. It's not sugar and starch, it's actually cellulose. So, but in doing that, unfortunately, the final step is this demon gas methane, which is destroying the world. And so that's why cows are under attack, because in the process of breaking down the cellulose, which they do with the aid of various microorganisms in the belly, in the rumen, they have to end this process by making methane. Okay, so now let's say a little bit more about that. You have to wonder, though, about why are we concerned? Because ruminants have been around the world forever. When the Europeans settled America, it was enormous herds of buffalo, which are sort of the quintessential ruminant, and the buffalo probably emitted a lot more methane per buffalo than a Hereford cow per cow, because the forage of a buffalo is mostly fiber. So they get less quality food and have to produce more methane than a cow. So people have done studies to see what is the difference between methane emitted in the year 2015 by beef cattle and what was emitted by bison. These are numbers I'm quite sure have all been pushed down for political reasons, but it's almost certain that the bison emitted a lot more methane in the year 1500 than cattle do today in the year 2026, at least in America. So the whole thing, you have to scratch yourself, why are we doing this? All right, now that's your course in biochemistry. So now we're going to talk a little bit about radiation physics transfer. And so the rap on cattle is that the methane will cause intolerable warming of the earth. I've just told you the warming you can't even measure. But the basic physics behind that is qualitatively right. The trouble is it's quantitatively wrong. And let me remind you, if you go outside today and you send up a balloon to measure the temperature will drop rapidly as the balloon goes up. It's typically somewhere between 6 and 10 centigrade per kilometer. And this is the lower atmosphere, the troposphere. Then the temperature starts rising again if you go way up. Jet planes like to fly here at the top of the troposphere where the air is a little bit quieter and you don't get so much turbulence. So they're designed to operate there. And then there's a stratosphere. The difference between these two parts of the atmosphere is in the troposphere here, as the name implies, air is always rising and falling, rising and falling. You feel that when the plane comes in for a landing, you typically get a lot more turbulence from this. Above the tropopause, the air is quite stable. That's why it's in strata and layers. So all of that plays into the way methane warms the Earth. And so it warms the Earth through the greenhouse effect, which we all keep hearing about. And here's how the greenhouse effect works. The temperature of the Earth is determined by the sun. We get a little bit of heat coming up from the interior of the Earth, but it's 1,000 times less than the sun, more than 1,000 times less. So we're dominated by sunlight. And if there were no greenhouse gases over on this right panel, the warm Earth that's been warmed by the sun would radiate long-wave radiation back to space, and this radiation would increase until it exactly balances the heating from sunlight. So cooling from infrared balances heating from sunlight. But it doesn't have a straight shot. in the infrared because even without clouds and clear air, there's water vapor, there's CO2, and this scatters the infrared that's trying to get to space. It makes it a little bit harder for the Earth to cool than it would if there were no greenhouse gases. And so that's the warming from greenhouse gases. So there really is a greenhouse effect. It really does warm the Earth. It's a good thing that it does. Makes it possible for us to live here. Okay, but the effects are very small. So this is an important thing because now this is beyond just so stories, and this is quantitative physics. Okay, so the quantitative physics is if you look down from space, what you will see coming up from the Earth at different frequencies of radiation. So this is infrared radiation at different frequencies, low frequencies, high frequencies, is a jagged curve here. This is called the Schwarzschild curve in honor of Karl Schwarzschild, who was a terrific German physicist back in the early 1900s. He died during World War I on the Russian front, not from Russian bullets, but from a horrible autoimmune disease that got worse because of the trench warfare conditions. And anyway, he showed us how to predict this curve, and as I'll show you what he predicts and what you measure, you can't tell the difference. They're really close. But now the important point about this curve is this is radiation that's cooling the space. It's the area under this jagged curve. If you were to double CO2 concentrations, that jagged red curve would be replaced by this red, that jagged black curve would be replaced by this jagged red curve, which is almost identical. So the effect of doubling CO2 is only a 1% change of radiation to space, only 1%. It's the tiny difference between this black and red curve. So, it's really hard to get alarmed about 1% in radiation, but it's even more discouraging for the alarmists if you think about the next step. And so the next step is, let me just, before going to the next step, this is one of my heroes. This is Max Planck. Max was the one who figured out how radiation really works and invented quantum mechanics as a result of that. But Planck's curve is this blue curve. So you'll often see papers which mention the Planck curve here. Yeah, that's almost never observed. I've never seen an experimental Planck curve, but I've seen lots of Schwarzschild curves, and they agree with what you predict. Planck's son was shot by the Nazis for being involved in a plot to supposedly overthrow Hitler. So he had a hard life. But I mentioned that you can hardly tell the difference between models and calculations. So if you use the Schwarzschild curve and you calculate what radiation coming up to space should be from the Earth, and you look what's observed from a satellite, here's calculated, here's observed. The dashed red curve is the Planck curve. Here's over the Sahara Desert where it's hot. Notice that the scales are different here, so this is more radiation on the top two panels. Here's over the Mediterranean where it's cooler. Again, you can hardly tell the difference between calculation and observation. This is interesting. This is over Antarctica, where there's very little radiation. You see the scale top here is only 60 versus 200 over the Sahara. But this is carbon dioxide, and over the Antarctic, carbon dioxide is an anti-greenhouse gas. It makes Antarctica cool faster than it would without CO2. So there's lots of complexity here, and you have to get it right. And when you get it right, there's nothing alarming. So I won't try to give equations, but this is a pretty good analogy to why greenhouse gases are so ineffective. Yeah, they do cause warming, but the warming is very, very small. And so, the current amount of CO2 and methane we have in the air is like a coat of red paint on the barn. If it's a good coat of red paint, the barn will look nice and red. And now you might say, well, I want my barn to really look red, so I'm going to put another coat of red paint on it, and you're wasting your money because when you put the second coat on it, it will look just the same. if the first coat is good, the second coat is also, it doesn't make any difference because you only take one coat. And that's the way CO2 is today. CO2 has really saturated the color of the Earth in the infrared part of the spectrum. So there is some warming, but it's very small warming. It's less than 1 degree if you double CO2. It's a very small effect. And one of the reasons for that is associated with two other interesting guys here. This is Joseph Stefan, who was he's the only famous Slovenian physicist I know, but Stefan worked in Vienna in the 1800s and 1850, 1860, and he discovered this famous law. It's now called the Stefan-Boltzmann law. But it says that the flux that a warm body emits out into space goes as the fourth power of the temperature. There have been many attempts to figure that out long before. The French had worked on it. Nobody got it right, and he was such an experimental genius that he designed an apparatus that he was absolutely certain there was a fourth power. Laws like this are not very common in physics. Most laws are more complicated. This is a simple one. But the point about that is because of that fourth power, just a little increase in temperature compensates for a big change in flux. So if you reduce flux by 1% by doubling CO2, the temperature to compensate only has to be 1/4%. So because of that famous fourth power here. Okay, so there's a greenhouse effect from both carbon dioxide and methane, and of course from the most important gas of all, water vapor. But none of them are anything to worry about, and none of them are going to change very much. The warming that we're observing for the last 2 centuries, which began around 1800, is almost certainly mostly a natural recovery from the Little Ice Age. You know, the Little Ice Age was clearly ending around 1800 because that's when glaciers in Alaska started melting and in other parts of the world. And that warming was quite substantial before there was any increase in CO2 in the atmosphere. So this is like many previous warmings. It's not an unusual thing, and it's not due to evil SUVs. Well, here's how methane is changing with time. It's slowly going up. When you look at a graph like this, if you learn nothing else from this talk, remember to always look at the scale. You know, on the left-hand side, people like to fool you, you know, by flashing this off. You notice this change is 189 to 194, it's 2%. It looks big, doesn't it? It's only 2%, yeah. And so methane is increasing. Nobody's quite sure why. There was a period of decrease a decade or two again, but it's hovering around 1,900 parts per billion. Okay. And here's a similar Schwarzschild curve for methane. Black is the current amount of methane. Red is if you double methane, and you're not talking about anything like doubling methane from killing all the cattle. You know, it's, and I'll show you how much we get, but it's a very tiny effect. Just so you can defend yourself, people will often say, yeah, yes, but isn't methane 30 times more potent than CO2? And you can answer, yes, it is. Per methane molecule, you get 30 times more warming than per added CO2 molecule. But then they never take the next step and say that there's 1,000 times more CO2 increase than methane increase. And so it really doesn't matter because if you've got a little effect, but there's not much of you, nothing to worry about. So here's a summary of measured methane from 1985 to 2025. It is increasing not very dramatically, much slower than CO2. Nobody's quite sure the cause of this increase. It probably is connected to the warming, but has nothing to do with people. And you can also calculate how much of this has to come from ruminants, because it's really true that ruminants burp a lot of methane. And so it turns out that if you do a simple calculation, there are 1.6 billion cows in the world. Each cow emits about 70 kilograms of methane per year. You can measure this. It's a well-known number. And methane hangs around by a little less than 10 years in the atmosphere. And so that gives cattle a contribution of about 17%. This is a straightforward calculation. I won't publicly do it, but so cattle are significant. I wouldn't say terribly important for the methane balance. So if you kill all the cattle, as I mentioned, you get a saving of 0.04 degrees centigrade from killing 1.6 million cattle. If you double CO2, you get 0.71 centigrade. We may double CO2 in a century. Neither of these, especially this one from methane, is very worrisome. And so it doesn't justify a climate emergency. You keep reading about the climate emergency, and is this really a climate emergency? You know, come on, man. So what do you do? Well, the alarmist establishment has invoked enormous positive feedbacks from water vapor, clouds, whatever seems plausible to increase these predicted warmings, these predicted temperature changes from increasing CO2 or increasing methane. And so I like to sometimes call it affirmative action for greenhouse gases. I've seen lots of affirmative action students in teaching at Princeton, and it doesn't really work very well. So the problem with positive feedbacks is that most natural feedbacks in nature are negative. You know, positive feedback is very unusual. There are some, but they're usually not natural. For example, dynamite has positive feedback. If you tickle dynamite too much, you know, that little heating all of a sudden turns into an explosive. So most systems with positive feedbacks are explosive. And so if the Earth really were a positive feedback system, it would have exploded a long time ago with a tipping point. And yet the geological record is very clear. The Earth has been stable for 4 billion years. You know, it's like other natural systems. Whatever feedbacks it has in climate, they're either small or most likely negative. So let me conclude with just a few words about agriculture, because this particular talk and our trip to New Zealand was driven by agriculture and farmers. And when I go to academic meetings and I show this picture and I ask my academic friends, what is this plant? Nobody knows. They, you know, people say, is it marijuana? And well, I'm sure everyone here knows this is soybeans. And another interesting thing about this is clearly genetically engineered soybeans. How do you know that? How do you know this is genetically engineered? No weeds. No weeds, exactly, no weeds. So this field has been sprayed a few times with Roundup to kill all the weeds. The soybeans don't care. They're resistant to that. And so soybean yields have gone through the roof. You know, it's been bad for the prices, actually. So there are two reasons that CO2 helps plants, and now I'm speaking for the CO2 Coalition, where we firmly believe that CO2 is really a benefit to the world. And the first main reason is plants need less water if there's more CO2, and plants aren't dumb. You know, they have to get CO2 through holes in their leaves, and the holes that the CO2 comes in, they leak water the other way. So the plant, not being dumb, if it sees more CO2 in the air, it just makes fewer holes in the next leaf that it grows, and so it's more resistant to drought. And you see all over the world that desert areas are shrinking at their edges because of the increased amounts of CO2 plants can grow in previously too dry areas. Okay, and then there's another one that's more interesting academically, and that's there's a plant photosynthesized with this factory I mentioned. That it's an enzyme called rubisco, which was invented probably 4 billion years, 3.5, 4 billion years ago. Very, very ancient enzyme. And it's the enzyme that takes carbon dioxide and combines it with water to make sugar and all the rest of the molecules of life. It's the key enzyme of life, rubisco. And when this was designed, the chief engineer for designing rubisco made a mistake. The mistake was this stupid enzyme is sensitive to oxygen. It didn't matter 4 billion years ago because there wasn't any oxygen in the air, but now there's lots of oxygen in the air. And so rubisco molecules, maybe I have a picture of one. Yeah, here's a rubisco molecule. Every now and then it makes a mistake. If it can't find a CO2 when CO2 levels are low, and they are low now, it uses an oxygen instead, and it makes nasty substances which it later has to clean up. They don't help it at all, they hurt it. And so for soybeans, for example, about 30% of the potential yield of soybeans has been lost because of this photooxidation, the fact that the leaf has mistaken an oxygen molecule for a CO2 molecule. So one of the reasons that soybeans do a lot better now as CO2 is increasing is it makes fewer and fewer mistakes because there's more CO2 and less a chance for it to pick up an oxygen by mistake. So the suppression of photorespiration is the second important advantage of more CO2. Yeah, I think you know there are two main types of crop plants that we use. The great majority of crop plants and all trees use the C3 photosynthetic system that Calvin worked out at Berkeley, back in the 40s and 50s. But there are important plants, corn being one of them, sugarcane being another, which are adapted to very low carbon dioxide levels. And so these plants are not affected by photorespiration, but they are affected by drought. So both plants are doing much better, both types. But we expect this type to do even better because it gets this additional benefit from the suppression of photorespiration. Here you can see the greening of the earth. I think you've seen many pictures. This keeps reproducing. At first, people thought it was a mistake, but now it's been again and again reproduced. So the earth is definitely greening, especially arid regions. Here's the Sahel. Here's the western US, Canada, Western Australia. And that's because of the increased water efficiency from more CO2. In fact, that's the only thing you can point to that is clearly due to more CO2 today. There's no evidence that the temperature has had much consequence from CO2 or storms. Or none of that makes any sense, but this is true. Okay? And then this is actually good for us. Okay. So this, I hope, is the end of one final, maybe it isn't the final, but one more episode of an extraordinary popular delusion and the madness of crowds. Lots and lots of people, decent people, have been brainwashed into thinking that there's a crisis and therefore we have to fix it. I mean, if I thought there were a crisis, I would be on the other side, but I know enough physics to know there isn't a crisis. But many people don't know, so they're easily deceived. And I think that's coming to an end, at least in the United States, and hopefully the rest of the world will follow. India and China have never believed this to begin with. And well, thank you. I'll stop at this point.
Ladies and gentlemen, please welcome to the stage the Executive Director of Heartland Impact, Cameron Schulte.
Yeah, I'm happy to answer questions.
Good afternoon. I'm Cameron Schulte. I'm the Executive Director of Heartland Impact and also the Director of Government Relations at the Heartland Institute. Our next guest, our next featured speaker, I am very excited to introduce. As Executive Director of Heartland Impact, I get to travel the states and talk to state lawmakers where the most exciting public policy reforms are happening. And most conversations about economic development and economic growth, they tend to focus on states like South Carolina and Texas and Florida and Tennessee. And when I talk to lawmakers in West Virginia and Louisiana, I tell them the exact same thing. I say, when we're talking about the economic juggernauts that are South Carolina, North Carolina, and Tennessee, and Texas, and Florida, I tell these lawmakers, every conversation about them should include West Virginia and Louisiana. And so it is that I get to introduce Governor Patrick Morrisey. It is a pleasure to welcome a man who has spent years fighting for West Virginia and who now has the opportunity to help lead it into an even stronger future. Anyone who follows politics knows public life is not exactly a low-stress profession. If you can survive years of lawsuits, headlines, and the occasional strongly worded editorial, you are probably ready for just about anything. Governor Morrisey has done exactly that. What makes his leadership matter is that he understands something important about West Virginia. His state's opportunity does not come from pretending to be something it is not. It comes from leaning into the assets it already has. West Virginia has extraordinary strengths. It has abundant natural resources, a hardworking people, a proud industrial tradition, and the kind of resilience you cannot fake and definitely cannot import. West Virginia's future should be built on those strengths, not in spite of them. That is one reason his role in West Virginia v. EPA was so important. That case put West Virginia at the center of one of the biggest legal and economic fights in the country. It was about whether federal regulators could try to remake the energy economy without clear authority from Congress. And West Virginia's answer was clear: no, you cannot do that. It was a major win for constitutional government, for common sense, and for the idea that states like West Virginia do not have to all quietly sit while others decide what their economy should look like. Now, as governor, Patrick Morrisey has the chance to build on that same foundation by expanding economic opportunity across his state. Because the truth is, West Virginia is not short on potential. It is not a state searching for an identity. Mountaineers know who they are. The challenge is making sure policy catches up with the strengths they already possess. West Virginia can lead in energy, it can grow manufacturing, it can attract investment. It can create jobs that give young people a reason to stay and build a life along the country roads. West Virginia's future is not limited by a lack of assets. It is unlocked by leadership that knows how to use them. So this afternoon, please join me in welcoming a leader who has fought for his state, who believes in the people, and who understand that West Virginia's best opportunities are still ahead. Ladies and gentlemen, Governor Patrick Morrisey.
You know, I could use him back in West Virginia. He does quite the introduction, doesn't he? You know, it's so nice to be back with you today. I know that my first experience with this incredible group started many, many years ago when I was a staffer on Capitol Hill. I was the Deputy Staff Director, Chief Health Counsel for the U.S. House Energy and Commerce Committee. And I remember always enjoying my meetings with Heartland, and because you would get the most fascinating, interesting, and correct interpretations of issues. So my excitement for what you do goes back many, many years. And I will tell you, when I listen to the introduction, I can't help but think that West Virginia's now going to be leading the way for America's energy comeback in a way you haven't seen before. And you know, it's interesting because I'm not going to go into the kind of scientific detail that you all are grappling with the endangerment finding and many issues. I care deeply about those issues. But for 12 years before I served as the governor, I took office about 15 months ago, I was the state attorney general and worked on a wide variety of different issues. I think a number of these are going to be very familiar to you. But beyond the legal works that we'll talk a little bit about and where that's led our state, all of the efforts on behalf of the state of West Virginia, they were really driven by the fact that I had a belief that for West Virginia to succeed and to really reach its potential, to be that shining state in the mountains, we had to better utilize our vast amounts of energy resources. We have so much coal lying in the ground still in West Virginia. We think of our Marcellus and our Utica shale. Some people call it the Saudi Arabia of the gas industry. It exceeds the Permian Basin. We're looking at nuclear, and we're embracing nuclear because when we look out and see the future, I'm not just interested in the next 10 to 15 to 20 years. I'm interested in the next 100 years of increase of standard of living for our state. And so when I became Attorney General, I became very focused on the fact that for a state that is ranked at or near the bottom of many economic rankings, our standard of living, our workforce participation, quite frankly, our healthcare outcomes, that we had to do some things that were fundamentally different than what were being done in the state before. Because, you see, West Virginia deserves a place in the pantheon of states, given its natural beauty, given its vast energy resources, and the indomitable grit of its people. So, as Attorney General, I became motivated to protect our vast energy resources. Makes sense. A lot of the initiatives that I was very involved in related to coal. West Virginia is the second largest producer of coal in the nation, and we employ significant amounts of people, even to this day, after the dramatic reductions to the coal industry. It's still one of the largest industries in our state. And for every coal job that we have another 7 related jobs. It's still a powerhouse in West Virginia. West Virginia also has massive amounts of gas resources, as I've said. And right now we're number 5 in the country in terms of the amount of natural gas production in America. 10% of the gas of America comes out of West Virginia. That's a pretty incredible thing. But as I started to look at those issues, and when I was Attorney General, I thought we were underperforming. To be truthful, I want to grow our energy resources even more. Because in order to lift West Virginia's standard of living up, we need to better think about ways to monetize our energy resources and create more value for the citizens of our state. Because for the longest time, we'd mine the coal that makes the steel that powered America during World War I and World War II. We were the folks that fueled the Industrial Revolution. But frequently, that coal would be used or the gas would be used, and it might have a short shelf life in West Virginia and then get shipped out of state. Both as Attorney General and now as Governor, we're trying to transform that and monetize the value of our energy industry so there's a lot more financial benefit right in the Mountain State. That's been the goal. But I will tell you, it's not been easy. I picked a couple tough topics to take on when I became Attorney General in 2013, because at that time, there was an administration in place that was seemingly hell-bent of closing down every coal-fired power plant in America and ultimately eliminating all fossil fuels. So what did the little state of West Virginia do? Well, I was an old regulatory lawyer. I was fortunate enough to work on many, many regulatory issues in my life, but I wasn't a constitutional litigator. I never claimed to be. But I thought it would be pretty neat for this old regulatory lawyer who knew how things worked and how to get things done to partner up with a wonderful team of Supreme Court litigators who knew their way around the Supreme Court and the Court of Appeals. And when you married up the knowledge of that old regulatory lawyer with the incredibly gifted Supreme Court appellate litigators we brought in, West Virginia became a powerhouse in the fight to defend America's energy independence. And what you saw beginning in 2013 through the end of my tenure in 2024 is that West Virginia led the way on most of the major environmental questions that occurred during that time. And these weren't just light little cases. These are big, impactful matters that impact tens upon tens upon tens of millions of people. And I'm not afraid to tell you at the beginning, boy, they went after me like you wouldn't believe. I was the first Republican elected in West Virginia as Attorney General in 80 years. So when I first came in, they all said, there's an error here. This is a mistake. We don't want to see you replicated in other offices. And so they came at me, and they came at me, and they came at me. And we said no. But I will tell you, at the beginning, when we started to handle these cases, we suffered a few losses in the courts. I'll probably be one of the only speakers that you'll ever hear from that is really proud of a 2-5 record. And let me tell you what that means. When you look at the history of West Virginia v. EPA, the case that a lot of you know about, we lost our first 3 cases in the Court of Appeals. Now, we happen to know something that a lot of other people didn't. Well, 1, we were right on the law, and we're going to talk a little bit about that in a minute. But 2, our goal was always to get up to the U.S. Supreme Court, because we thought the D.C. Circuit, quite frankly, was a little stacked against us. So we were persistent. But there were a lot of people when they saw us go 0-1, 0-2, 0-3, they were all wanting to drum me out of office. And they came at me very, very hard. Fortunately, we stuck to our guns and we kept going. And obviously the proof is in the success that we've had over the years. When I look at West Virginia and I think of the incredible energy resources we have in the ground, it's truly amazing. And then fast forward to where we are today, where America is facing a fight for data supremacy with China that West Virginia must not only be part of, that West Virginia must help lead, just like it did during the Industrial Revolution, just like it did during World War II. When America ultimately competes and defeats China for technological data supremacy, it's going to be West Virginia power that leads the way. And this is one of the greatest threats that we have from a national security perspective, that there's a lot going on in China right now. While all those coal-fired power plants were being decommissioned, China is moving and growing its energy resources in a way that most Americans can't contemplate. So when I look and I hear these people talking about the Green New Deal, and there are a lot of incredibly strong science arguments against what they're doing, I tend to focus on the legal issues and, quite frankly, the national security concerns that we have if the far left gets their way and the Green New Deal agenda advances. And that's what motivated me as Attorney General, and that's what motivates me as Governor. So we have a lot of resources in West Virginia, and we've worked really hard to be able to use those resources effectively. But that Green New Deal scam that President Trump talks about, there's no place in America it hits harder than our state. you try to close down coal-fired power plants, that's not only a gut punch to the coal industry, it wipes out entire communities. And I always used to look at the regulations undergirding the Clean Power Plan, and I'd read them, and I'd look to myself, and they would talk about the potential for climate change of 0.0001 or 0.002 on the global stage, and why America needed to do all the work for it. And I would say, can we not have some comparison of whatever you may think the benefit is, and it's questionable, but even if we granted them all the arguments on their side, what do you tell the hundreds of thousands of people that are being forced into poverty in Appalachia? Aren't their lives important? Well, they are. They're incredibly important. And that human dynamic has always been lost in even all the legal arguments that have gone forward. But it shouldn't be lost, because there was such an affront to basic moral decency when these guys try to shut down coal and eliminate the use of gas. I get offended by that. But that motivates me to work harder and harder and harder to protect our citizens. The good news is the other side has overreached at historic levels. So when I say that we were 2-5, and I'm proud of it, we didn't prevail in the DC Circuit, but we did go 2-0 at the US Supreme Court, winning, thank you, winning the historic stay of the Obama Clean Power Plan back in 2016. Interestingly, after that decision, it was Justice Scalia's last decision before he passed away. So I believe 4 days later, Justice Scalia passes away. Timing is everything in life, huh? So we prevail then. We work with President Trump when he's in office. And then obviously we got the terrible Biden administration, which was even worse, I think, than the Obama administration with respect to climate. But beyond West Virginia v. EPA, and I'm going to talk about that a little bit more, we took on the leadership mantle to go after the growing abuse of the administrative state. You see, I look at a bunch of friendly people out here. How many people, show of hands, have watched as Congress has allowed the executive branch to grow by leaps and bounds by funding them and by allowing them to seemingly regulate everything that moves in our country? Right? Here's the good news. All of us can stop that. And I would argue, through the cases that we've shepherded through over the years, we've made a major dent in the ability to rein back in the administrative state. Just look at what's happened with West Virginia v. EPA. It was hailed as one of the biggest cases out there, but it stood for a very simple prospect, and quite frankly, a prospect that should work for both the right and the left. Straightforward. If you have a question that has a vast economic or political significance on our country, the court simply said, that's a question for Congress to decide, right? If something is so big, you don't want these unelected bureaucrats to rein in. Otherwise, the voters of West Virginia, of California, of Texas, of all of our great states, they lose the ability to use their constitutional tools to be relevant. Last time I checked, we didn't elect all the bureaucrats that exist within those agencies. And so we approached that from that basic theory. And so we, during the West Virginia v. EPA case, looked at this as a tool to dramatically rein in the excesses of the administrative state. And that major questions doctrine, most assuredly it applied to stationary power plants, right? But it went well beyond that. If you have questions involving FDA, if you have questions involving the Federal Communications Commission, if you have questions affecting healthcare, you always have to look at whether Congress clearly delineated power for those agencies. Did it speak clearly to provide power to those agencies? And if it's a question as large as the Clean Power Plan or the endangerment finding, then you do not pass go. You do not collect $200. You go back to Congress, you seek authority, you comply with the Constitution, and respect the separation of powers that our founders envisioned. Straightforward concept because it works whether you're a Republican or Democrat, right? This is a value-neutral issue, but it deals with what's been going on for 40 years, the seizing of power that was best left for Congress and, quite frankly, left for the states. And Congress, we believe, had been so irresponsible for so many decades because they didn't want to weigh in on the tough issues of the day. Let the agencies resolve it. But states' rights get blurred in the picture as well. And the agencies started to assert more and more power. And Congress provided more and more monies for them. At least with respect to West Virginia v. EPA, and I would argue it's kind of sister companion case that came a few years later, Loper-Bright, there's been a major retrenchment in federal power. You see, West Virginia also played a major role in the Loper-Bright case. Why? Well, this regulatory lawyer who was in West Virginia at the time as the Attorney General, we filed over 10 amicus briefs, led the states to get rid of Chevron deference. And I'm happy to report that just a couple years ago, we were able to do just that. Pretty cool, right? Great case. We were so excited when Loper-Bright was going through. We were a little bit bummed that we weren't the party in the case because we like to be in the middle, but we played a major role as the lead state amicus to get rid of Chevron deference, and we're excited. I thought Paul Clement did a great job in the argument, and that is another fundamental win of the day. Now, we take these tools and we go to battle again. And there are just almost unlimited number of examples of the Obama and the Biden administration trying to stop the use of fossil fuels and limit our citizens' ability to lift up their states, to lift up their standard of living. I could talk to you about the Waters United States rule. West Virginia out in front, once again, leading the state's effort to stop the waters of the United States rule. This group knows about that, right? I remember having conversations. This was actually the easiest case to take to a town hall because I would go speak to the people, and it was actually easier to explain than the Clean Power Plan because I would say to maybe a group of farmers or a group of businesses, imagine that you have a large puddle or an ephemeral stream and you want to regulate that like it's a federally navigable waterway. Think about that for a minute. Everyone can understand that concept. When you think about navigable waterway, you think about boats. How many boats do you know that are rowing down the puddle down the street? Not so many. So we were able to put together really compelling arguments and work, and we were involved leading the way back in 2015, and then during the Trump administration, then the Biden administration, alternating positions as lead party and as lead amicus, and we were able to get that done. And when you look at those cases and the work we did in other areas, it's paved the way to provide the toolbox and the tools to go after the vast excesses of the administrative state. But just because we have the tools doesn't mean we can stop. There are a lot of things that need to keep occurring, and I can say I know that this group is all in on that effort. Because just because you won on the Clean Power Plan, just because we've gotten rid of Chevron deference, just because we've gotten rid of Waters United States rule and many other problem areas, thanks to the Trump administration and others, doesn't mean we're done. We're dealing with a new fight right now. We have an endangerment finding that was wrongfully foisted upon us because of the improper Massachusetts v. EPA case from many, many years ago. So we have to keep focusing on these issues and continue to make progress to make sure that the separation of powers that was created so artfully by the founders many years ago continues to be respected. And so I know there are a lot of people working through the legal arguments on that. I would like to argue that one of the many, many reasons why the endangerment finding should go down is because it fails the major questions doctrine. What we just talked about, right? Can you think of a more vast matter of economic and political significance than regulation of carbon dioxide? It is generic to everything in our life. We're basically, how do you regulate something? It's everywhere. It's big. So if this isn't a major question, I don't know what is. So in that lies at least part of the way that the endangerment finding is going to be dismantled. And I think there's a unique opportunity for that. But there are other pieces that need to be done. One of the things, we were very aggressive to try to get rid of the endangerment finding when I served as Attorney General. But I will tell you that I was always cautioning folks, build up the data, the body of evidence from a scientific perspective as well. That's critical when you're talking about the endangerment finding. I know there are a lot of people in this room who care about that and recognize the importance of that. So, thank you. Your work is really important in that regard, and it's going to continue to play a critical role as endangerment finding issues get litigated, and we know there's litigation started already on that. But we're going to be in that fight as well, and by saying that, I'm the governor of West Virginia. I'm not the Attorney General anymore. But I can tell you I care an awful lot about what the Attorney General does in West Virginia. And we've had some good conversations. West Virginia led an 88-page comment letter against the endangerment finding in support of what the Trump administration is trying to do. And we're looking for different ways to partner with them and help them to make sure that we could prevail in that fight. But a lot of this wouldn't happen but for a lot of your work, because you get before public officials. You talk about these issues on a pretty regular basis. You educate attorneys general and governors and other people who matter. West Virginia plays a disproportionate role on regulatory matters, I'm proud to say. We're the little state that roars. But we're going to roar a little more. And while I come here today to give you a little bit of the background of some of the legal issues of the day, I do want to take a few minutes to talk about the future of West Virginia and why I do all of these things. You see, when I go down to McDowell County, one of the poorest counties in America, or I travel across West Virginia, I see a level of poverty that's disconcerting. We're a really poor state. We have pretty rough healthcare outcomes, whether it's diabetes or COPD or obesity, many, many things. We have to reverse that. One of the ways to reverse that is to much better leverage our energy resources. So looking at those issues, now coming in to be the governor 15 months ago, I tried to put in place a series of transformational initiatives designed to lift West Virginia up. And I'm going to walk you through what those are. First, we should embrace the fact that West Virginia is America's energy state. That's an applause line, by the way. When you look at the amount of coal and the gas that we have, we need to be utilizing that for the betterment, the growth, the wealth creation for our people. But one big difference of what we've done in the last 15 months than what had been done forevermore is that you have to be cognizant when you have energy, you need partners. Energy needs to fuel things. I mentioned the international fight for data supremacy with China. America needs to fuel that fight. West Virginia has resources that could be pivotal in helping us win that fight. West Virginia also has new opportunities. When you start to monetize the intersection between energy and technology and data, or energy and aeronautics, and energy and healthcare manufacturing, you start to see the opportunity to create whole new sectors of wealth in West Virginia. And that's what we're doing. About a year ago, we passed a series of new laws in West Virginia that's already leading to tens of billions of dollars of capital investment in our state. It's incredible. Over the last 6 months, West Virginia, on a very conservative level, has had public announcements of over $12.5 billion of capital investment and projected 11,000 jobs within 6 months. That's more than any full year on the books in West Virginia's history. And as we begin to line up more manufacturing and some of these data centers coming in, we have an opportunity to double and triple that. Not being satisfied with $12.5 billion of investment, but moving to 20, to 30, to 40, to 50. What that does is that draws a lot of resources into our state. That helps our state, that helps our counties. And then we created a wonderful dynamic, a great incentive for the people of our state. You see, every time a new data center comes in, there's a portion of that money, 50% of the original dedicated property tax dollars, go into a fund designed to eliminate the state income tax. Now think about what, I heard someone clap, that's good. I hope the percentage of support for eliminating the income tax is higher than that, right? But think about that for a minute. A state that's been struggling to get cap investment in tries to bring the resources in so that when the benefits come through this intersection of energy and industry that I talked about, the value of that flows right back to the people of the state. 50% of every dollar goes back into the fund to eliminate the income tax. 40% goes back to the counties. 10% shared with all the counties. 30% to the originating county, which makes sense to share a little bit more resources with the county that's doing a lot of this. What does that do? Well, it means there are going to be huge amounts of resources for roads, for infrastructure, and to handle things the right way. So West Virginia, since this law was passed, is getting incredible amounts of interest. And it's leveraging our energy resources. And we're not doing it the way a lot of states do it. Right during COVID, a lot of these states went on a spending spree where they said, oh, we've got billions of dollars, let's buy a company. And you might overpay 40%, or you might buy a company and 25% of them may go out of business. Look, I'm a believer in incentives. West Virginia has really good incentives. But I want to invest in the fundamentals. And if you build the right environment where you have shovel-ready property, you have good water and sewer, you have good infrastructure, the right power purchase agreements, people will come. You know that Field of Dreams movie? People will come, and they're coming to West Virginia. Not because we're putting all the dollars in to company A, B, and C. It's because we're doing the fundamentals right. Capitalism and free markets work. We need more people to rely on them. That is what we're doing in West Virginia, and it's beginning to pay off. Robust focus on energy and leveraging those resources. But then, here's the secret sauce. We know that a lot of states try to throw money around. I looked at this issue when I came in to serve as governor. I said, well, West Virginia, our budget isn't nearly as big as Texas or Florida or Ohio or Pennsylvania. Just look at our neighbors, right? Virginia, Maryland, Pennsylvania, Ohio, Kentucky, all have much larger budgets than West Virginia. I said, so how do we compete? Well, there are a couple ways to do it. Certainly, financial resources matter, and we are investing in our people. But one of the other ways that we thought West Virginia could get out in front of our neighbors and have an economic competition where we win was on the regulatory front. And you know, the person who worked so hard to win WE versus EPA and to really rein in the excesses of the administrative state believes passionately that when you reduce regulatory burdens, you reduce disguised taxes and you give innovators and companies a chance to soar. Because if the cost of doing business in West Virginia is more affordable than the other states, that's a major competitive advantage, right? I think you all agree on that. And to go further, if you can cut red tape faster than all the states that you touch, that's a major competitive advantage. If you can move at the speed of business or faster, and if you can move faster than your competition, you're going to win a lot of those economic development fights. And if you know you can't throw the same dollars in, why would you fight on those terms the same way? Once again, yes, there'll be incentives, financial incentives will be competitive, but not just to have all that hard cash go, invest it strategically, quite frankly, like you would if you were in a sporting team, right? If you had a big basketball team, and I said, you know, I want to defeat these guys with 7-foot center, 6'11" power forward, all these incredibly tall guys. Would you try to say, well, I can put a 6'6" guy up there and I could potentially, you know, it's only a 5-inch deficit. No, you'd probably try to find the fastest point guards and you'd be faster than them, right? You'd beat them at something they're not as good at. Competition has many different facets and forms. In West Virginia, we're going to win on the regulatory front. We're going to be faster than everyone. We're going to cut tape better. And that's what's going to lead West Virginia's comeback. So that's what we're focusing on in West Virginia. And obviously, it's a state that can have an enormous amount of influence on America's energy dominance into the future. When we looked at that question I raised earlier about China, which concerns me every day, I worry about that. I know we're, you know, dealing with Iran right now, very serious issues, but I can't help but keep thinking about China and the incredible threat that China poses to our country. And so I know that West Virginia and many other states have to get a lot more serious about energy generation, power generation in our states. So one of the other initiatives that we came up with and announced last September that's getting traction around America is we announced that we're going to increase power generation in West Virginia from 15.9 gigawatts of energy today to 50 gigawatts by 2050. We call it our 50 by 50 plan, and it's designed to pull more of our resources out of the ground, but then we have to make sure it's transmitted. Transmission matters, and we have to do it in a secure and an environmentally friendly way. We can do that. And in fact, we have to do it. Because when we look at the dearth of energy resources out there in some of the other states within PJM and the grid system, we know West Virginia has to step up. That's why we're doing it. When I first mentioned this, I delivered the speech about 50 by 50. I had a lot of people, they cackled a little bit. They said, there's no way you're going to get to that place, right? Since then, we actually have publicly announced over 3 gigawatts since 6 months of new baseload power. We've identified in the short term another 9 gigawatts of energy, which we think may be public in the next year to year and a half. And we think there's a pathway to 20 within 5 years. More. Think about that for a minute. This is because a state decided to develop its own energy policy that was going to position itself to be at the center of the fight against China, be part of the national security solution, to lead to wonderful things for our country. That's what we're doing in West Virginia, and it's working. We get more calls about our 50 by 50 plan and our data center law and our red tape cutting system. You come to West Virginia, you get to go to one person to deal with your permits. One. It's a one-stop shop system. So you move fast. And if you don't meet the timelines in West Virginia, we give you your money back, right? What kind of government does that? West Virginia's going to do that because we're betting, we're all in on speed to build. That's how we're going to win. And that's how West Virginia is not going to be 48th in the rankings. We're rising, we're fueling our comeback, and it's beginning to work. That's why I wanted to come here today, because there's a great story coming out of West Virginia. And we think that our state has the ability to play a major role on the international stage. But to do that, we got to keep our eye on what's going on in Washington, D.C., right? We know we have a favorable administration now, and we've been working very closely with them, and we're excited about that partnership. But let's not forget, we had to deal with 2 terms of Barack Obama and a term of Biden. There was a lot of damage that occurred to our state and to the country as a result. To truly advance America's energy dominance, we're going to need predictability and certainty and durability over a period of time, regardless of who's in the White House. I'm very hopeful that we're going to keep the White House for a number of terms. But let's take advantage of where we are now and build these structures and system, keep creating the tools that I've talked about, right? Getting rid of Chevron deference, having the major questions doctrine through West Virginia EPA, getting rid of the endangerment finding. We keep doing that, we limit all the damage when the other side is in office. So I'm very happy to be here today. I've had wonderful memories of this group, going back to when I was a young staffer on Capitol Hill. And now I'm a little bit more grizzled as the governor of West Virginia. But we're doing wonderful things. I want to thank you for all of your support over the years. I see a lot of friends in the audience, and I'll look forward to seeing you again at the next event. Thank you, and God bless.
Ladies and gentlemen, please welcome to the stage the president of the Science and Environmental Policy Project, Ken Happola.
Greetings, carbon-spewing life forms. Each time you breathe, you take in carbon dioxide at the rate of about 400 parts per million. You spew out 40,000 parts per million. Carbon dioxide is a pollutant. How dare you? But what about photosynthesis? Oh, that's insignificant. It's not really discussed in any of these comprehensive studies on global warming. For example, from the IPCC and from the U.S. National Climate Assessments. And we all know carbon dioxide is causing dangerous global warming through the greenhouse effect. Well, in early 1900s, many astronomers asked an important question. Given its distance from the sun, why was Earth warm enough to support life? Starting in 1859, John Tyndall of the Royal Institution used instruments or early spectroscopy instruments that measure the interaction between light and matter such as molecules. He discovered that certain atmospheric gases are transparent to visible light, but interfere with infrared light, which is how planets cool themselves. In 1863, Tyndall reported that the dominant gas interfering with the rapid cooling of Earth was water vapor, not carbon dioxide. He wrote, "This aqueous vapor is a blanket more necessary to vegetable life of England than clothing is to man. Remove for a single summer night the aqueous vapor from the air which overspreads this country, and you would most assuredly destroy every plant capable of being destroyed by freezing temperatures. The warmth of our fields and gardens would pour itself unrequited into space, and the sun would rise upon an island held fast in the iron grip of frost." I bet you won't read that in an IPCC report. The work of the IPCC includes some excellent physics, but its conclusions are often based on omitting physical evidence that contradicts its conclusions. That is not the scientific method, and it is not what we call the scientific method. That requires that all the physical evidence be considered. Omission is a violation. Further, the IPCC makes assertions for which it has no evidence, such as the warming caused by carbon dioxide will be doubled by a warming caused by water vapor. We haven't been able to find that doubling. Frederick Seitz, an eminent physicist, declared that the summary for policymakers of the second IPCC report was the worst abuse of the peer review process he had seen in 60 years of U.S. science. After he died, he was branded as a merchant of doubt, along with 3 other distinguished scientists, including Fred Singer, who was the founder of CEP. The claims produced no evidence of improper action. Just the book contained a great deal of accusations, claiming that the evidence can be found in the citations. Sorry, it wasn't there. Later, CEP established the Frederick Seitz Memorial Award to honor those who have the courage to stick to the scientific method, even at the cost of their professional careers. I'm pleased to announce that the 2025 recipient of this $10,000 award is Peter Ridd of Queensland, Australia, who was fired from his professorship at John Cook University for not obeying the party line that carbon dioxide is causing dangerous ocean acidification, destroying the barrier reef. Ridd has a PhD in physics, and he was a member of the Australian Institute of Marine Science. He began studying the barrier reef in 1984, focusing on ocean currents, sediment movement, and coral ecosystems. He headed the physics department of James Cook University from 2009 to 2016 and led the Marine Physical Laboratory for 15 years. Over his career, Ridd published more than 100 scientific papers and developed innovative optical and electronic instruments for measuring the environmental conditions of the corals. He did something really unusual. He went down and dove among the corals to physically check them out. Ridd used the core principle of the scientific method. physical evidence dominates. I give to you from Queensland Peter Ridd, to whom we're giving this trophy as a small symbol of his great work.
Thank you very much. So it was a big surprise to get this award from the Science and Environment Policy Project. And to honour Fred Seitz, we'll be putting this prize to some really good use, making some videos to push science integrity to take place routinely by governments when science is being used for public policy. So there are many, many environmental issues. Climate is obviously the big one. I think that Fred Seitz would approve of how we're going to use this award. Now, essentially, my main aim over the decades has been to fight against not just the details of the corrupted science, but to work out why this has happened, why the groupthink has taken hold, and work on methods and systems so that we can reverse this groupthink. How the peer review system of publication has corrupted things and essentially made groupthink almost inevitable. We're going to be introducing, hopefully the next few months, systems of guaranteed challenge for science that used in public policy here in the state of Queensland. We're starting on a small scale, but we're going to build up from that. And this prize will help us a great deal. Now, actually, one of the things about the prize is a very, very generous prize, which we're going to use for this project. But actually, compared with the amount of money the other side have got, which is sort of like tens of billions, probably hundreds of billions of dollars, it's small beer. But the thing is that we've got one extremely unfair advantage on our side, and that's that we've got the truth, or at least we will use the scientific method to try to get to that truth. And we can magnify the $10,000 a million times with that scientific integrity. We've got to keep going for that. And I actually feel a little bit sorry for people like Fred Seitz or Fred Singer or my mentor, Bob Carter, who died before it's actually now becoming fairly obvious that the climate scam is failing. It's actually a really good time to be alive after years, decades of darkness on this particular thing. Now, I just want to share my screen for a second because I want to show you, I can never allow an audience to get away without showing my favourite graph in the whole wide world. And I call this the second battle of the coral sea because this is the amount of coral on the Great Barrier Reef. And everybody in America and in Europe and in Australia has been told that the Great Barrier Reef is in terrible shape. And yet, when you actually look at the data from the Australian Institute of Marine Science over the last 40 years since records began, we can actually see that the amount of coral on the Great Barrier Reef is at record levels. In fact, we hit a record a couple of years ago. And although if you consider the uncertainty band, we're not quite above these levels in 1985, the last 5 years, at least the headline value, is greater than any amount of coral that we've had in the previous 35 years. Now, of course, you've been told that there's been massive bleaching events which have killed a huge amount of coral from hot water since 2016, 5 of them. So despite these massive events which have killed a huge amount of coral, supposedly, we've ended up with record amounts of coral. And that's not even the best news. The best news is the type of coral that's now exploded, as it always does, is actually the type of coral that's most susceptible to hot water bleaching. So this proves without any shadow of a doubt that the Great Barrier Reef is in wonderful condition, one of the most pristine ecosystems on Earth. And it's just incredible that people have been told that it's not in good condition. Yeah, we get periods when there's little coral. We have a bunch of cyclones go through, crown of thorns, starfish. It fluctuates and the bad guys make use of that. But essentially, if this was the second battle of the Coral Sea, the Great Barrier Reef won, and the scientific institution have shown that they're utterly and totally untrustworthy. Now, I mention the second Battle of the Coral Sea, but to you Americans, I need to mention the first Battle of the Coral Sea, which happened just over the horizon. Well, it's a long way over the horizon on the other side of the Great Barrier Reef in the Coral Sea. This is the USS Lexington, which had just been torpedoed, and it was going to sink, but the Americans won here, a massive strategic battle. It saved America and it helped save the world. And I mention this because actually you Americans are doing it again. And I thank you with all my heart on this climate scam thing, which is clearly coming to an end in America. Us climate realists over here in Australia and also in Europe and the UK, we look to what's happening to America and we just marvel and we thank you for everything that's happening there. It turns out that actually things are getting better here in Australia, but we're just really following what's going on in America. Now, yes, I know that in the US, you've got a whole lot of hard work to do. There's so many of the climate alarmists that are in universities and in other positions of importance. But there is no doubt, I think, that, you know, if you keep pushing, you're going to win over there. I don't know whether you're aware of, you probably are, of a report from the Democratic Party that came out just recently, last year, surveyed a huge number of Americans, and the conclusion of that was, with advice to Democrat politicians in America, was don't mention climate because the voters don't give a toss about it. It's not important to them. In fact, they've got so many other things to worry about that if Democrat politicians keep on going on about that, they're going to vote for somebody else, and I wonder who that might be. Now, in Australia, we are following the American lead. We're following where you guys are taking us. And actually, a lot of the news coming out over the last couple of months has been just so encouraging here that we're having a bit of a revolution like you had. So can I say, finally, thanks to all the institutions over there, the CEP, Heartland, the Carbon Dioxide Coalition, which I'm a member of, and I also need to throw in the Australian Institute of Public Affairs, which I'm a member of here. Thanks for all the great work. But also to the great American climate realists, the ones that have passed away, like Fred Seitz and Fred Singer, but the ones that are over there that are alive and kicking and fighting away, like Judith Curry, like Will Happer, like Willie Soon, the guys. Thank you so much to all of those. So can I just conclude by saying, really, America is saving the day again, just like it did in 1942 over the horizon there. So God bless America and thank you.
Boy, that was wonderful. Congratulations to Peter. The wonders of technology. He got up, that's 3 in the morning, I believe, in where he is down under. So he really wanted to be with us, and I'm very glad that it was able to happen technologically for him today and for all of us on the stream and also in this room. That does it for our lunch plenary program for right now. Just like as before, we need to clear this room so that the hotel staff can do their magic and get this ready for the next breakout sessions, because this doubles as a breakout room. In this room at 2:20 p.m. Eastern Time will be Beyond CO2, Other Possible Climate Drivers. Wonder what those might be. And then upstairs on the ground floor, lobby floor, it'll be Problems with the Temperature and Climate Records. So choose your panel wisely, and we'll see you in about 20 minutes.
If you Google climate change,
Yeah, each one got 20. Right.
Arthur, you work with the Heartland Institute, you're kind of like a writer of grant. Right. Oh, well, I know Joe was big on this issue, and I was going to say he's the other one I know that's big on this whole issue. I was going to say, where are you originally from? Originally from this area? Where in New York? Okay. Oh, that's pretty cool. So you're an Islanders fan? Are you a Rangers fan? No. I'm a Caps fan too. But there was still, I'm originally from Buffalo, the other end of the States. You know, how many people say that? What are your interests out of curiosity? You know, like, you have to say, like, what do you like to do?
Thank you.
I play guitar. I play electric guitar, but now I play fingerstyle because I'm older. When I was a kid,
We say this, I'm doing it.
but now I do pretty much everything, but I do it fingerstyle. But I don't play in a band anymore, so I just play like, you know, when I accompany a remixing some songs. It's mostly, could be anything from the one from Ipanema to Red Hot Chili Peppers or something that's more contemporary, or Stones or anything like that.
That's what science is all about.
I just use it for
taking some backward. Every step they make is always backward.
One-man band type thing. Probably drive my wife crazy. Well, they are now. I mean, I think we're so
It's a very serious Oh yeah.
What I was going to suggest is, I know I haven't, but I was going to suggest is, Willie will then speak, and I'll introduce you, and you speak, and I'll introduce, instead of introducing all three of you at once, I'll just introduce you right before you speak. Okay, and then I'll Ronan second, whoever I wind up introducing second.
And then if the Q&A or come up, that's fine. But now it's clear that they make it like this.
Yes.
Don't worry, we'll bring more. Whichever, yeah.
We probably need another.
Data.
Hey, Ronan.
Hi, our team is gathering. Yes.
You play guitar. He plays guitar too. You play guitar. You don't play guitar. You play
No.
his kids.
Oh, just kidding.
No.
Your kids?
His kids.
My kids is
He's just passed all of his kids. All musical.
No, zero.
What about your wife? Does she?
No. Because what we don't even have food to eat, so nobody wants about music.
But he passed it on. So
All my three kids are really.
no, they're very good. They're very good musicians.
Oh, no, I saw boy. Yeah. I think so, yeah. Obviously came after the revolution. I think so. Definitely. I don't know what's want to know about that part.
Yeah.
Right. Yeah, sure is.
And now there's the divisions as well, you know, family sessions as well. Yeah, I would say if they have questions, I would ask Bill about why people are all concerned about cattle, they're concerned about retail, but not about rice paddies.
Yeah, rice paddy, you know.
Yeah, and that is like,
termites.
yeah, you could say that's a bad rice production. Yeah. No, it's one of these policies that we've been going to. Not yet. It's continually, hopefully it's going to be, the Green Party had been in a coalition and they didn't make it back into the reshuffling. So they kind of have been like that, you know, so. It wasn't me. I was opposed to it. Yeah. Yes.
It's right here. Right. It's representing Ireland. The whole Irish Republic is under his head now.
anti-Trump today. It's going to be the view.
The rain in Spain falls mainly on the plain. Okay, works. All right, if you could please come in, take your seats. We'll get started. All right, my name is Craig Rucker. I serve as president of the Washington, D.C.-based Committee for a Constructive Tomorrow. And on behalf of CFACT and the ICCC, we welcome you to our panel discussion today called Beyond CO2, Other Possible Drivers. We have a list of 3 outstanding rock stars that are going to be presenting today, all PhDs. Dr. Willie Soon, Dr. Ronan Connolly, and Arthur Viterito. And our topic is kind of an interesting one. And that is, other possible drivers beyond CO2. I think it was Dr. Judith Curry who one time talked to me, and she's actually in our movie, which we produced. I don't know if any of you saw it, called Climate Hustle. All right. Good. I know Willie was in that as well, but one of the things that she talked about in that movie was how scientists are just really looking only at CO2 to the exclusion of other factors as to what could be causing climate change. I'm old enough to remember when this issue broke back in 1988. I was a young person in Washington, D.C. when Hansen made his famous proclamation that he was, I believe at that time he was only 95% certain that the Earth had hit some unprecedented warming. That would later become, what, a 98% consensus or 99% consensus? All BS, of course. But the first thing that went through my mind, I was talking with our other co-founder at CFAC, David Rothbard, as I said, wait a second, what about the Vikings? First question, right off the bat. I am a student of history. And of course, if anybody is a student of history, you would know the Vikings settled Greenland. They mysteriously left there in the 1400s. And people always said, why did they leave? Well, the consensus at that time was it got cold. They left, right? And there was other things. You could look at the Mendenhall Glacier in Alaska. It was melting and it was making headlines. Climate change. What did they find under that? A forest that they didn't know existed, but dated to 1000 AD. They would never have known this. Same in Switzerland. A glacier melts, and that makes the news. What they don't say is they found a Roman road and a Roman mine under this glacier. Climate has been changing, and our obsession with it only being CO2 seems to be what's driving the debate today. So this panel is going to be looking at possible other reasons that there would be climate change. And I know that Dr. Willie Soon is somebody who is very outspoken in the past about how solar activity could be playing a big role. Think about it, the sun could actually be influencing the temperature. And he will be the first one to speak. Now, he barely needs an introduction. I'm sure everybody in this room pretty much knows who Willie Soon is, but I'll give it just because I'm the host. He's an astrophysicist, geoscientist, formerly with the Harvard Smithsonian Center for Astrophysics. In 2018, he co-founded the Center for Environmental Research and Earth Sciences series. He's been in the news a lot, especially in the past. In our movie Climate Hustle, we featured him as being very much under attack. At that time by the New York Times articles and everything. His courage on this issue is really sensational and inspirational, and it always has been to me. So we're really consider this a blessing to have him in our coalition here of people that promote climate realism and sound science. And another little thing about Willie, the guy's funny. I don't know if you've ever seen his videos, but he can carry off humor. I think you were even in California one time. Did you not do a comedy show?
Yeah, comedy improv.
Comedy improv.
Hollywood, yeah, I will. Debating a UCLA professor.
That's right.
So little known that, and in fact, you can kind of see this comedy because I asked him, what are you going to be talking about with response to this topic? He goes, oh, you just tell him Willie Soon's talking. I go, cool, what's at least the title of it? He goes, Wild Goose Chase. So I don't know what that means, but I do know that whatever he's going to be talking about will be very good. Welcome to the stage, Willie Soon.
Thank you, Craig. All right. Are we excited yet? All right, let me get my teleprompter and get started. It's very unusual for me, but since I got only a little time, so I better get straight about my behavior. All right, good afternoon, everyone. Indeed, my name is Willie Soon, and I want to dedicate this talk to the memory of my teacher, colleagues, and friends, Dr. Michael Connolly. Let me start by asking you to imagine that you are standing in this completely dark room. You've been told by the UN IPCC very confidently that somewhere in that room, there is a black cat. You search earnestly, armed with highly sophisticated equipment. After a great deal of effort, you say, I found it. But here's the problem. There was never a black cat in that room. This is a central metaphor of this presentation, and it applies precisely to one of the most consequential numbers in modern climate science, the Earth Energy Imbalance, or EEI for short. EEI is the number that underpins the entire scientific and policy argument that the Earth is accumulating heat at a dangerous and accelerating rate due to human greenhouse gas emission. It is reported by the IPCC AR6 report as roughly 0.7 watt per meter square, a tiny fraction of the roughly 340 watt per meter square of solar energy arriving at the Earth's atmosphere. To understand why this matters, we first need to appreciate the sheer scale of the solar energy system that drives the Earth's climate. The sun is not a polite background light bulb. It is an almost incomprehensibly powerful engine. The sun radiates about, wow, wrong graph. Anyway, the sun radiates about 4 times 10 to the 26 watt of total power. For one or two of you that may have fallen asleep in a class when scientific notation was taught, 10 to the power of 26 just means that 1 followed by 26 0. Earth intercepts only about 2 times 10 to the 17 watt of that, so making Earth roughly 2 billion times weaker as a radiating body than the sun itself. Earth's own internal radiogenic heat contribute a mere 2 times 10 to the 13 watt, essentially negligible in comparison. This presentation asks a very deceptively simple question. Do we actually have reliable measurement to support the claimed EEI of 0.7 watt per meter square? The answer, supported by a comprehensive review of the published scientific literature, is a resounding no. To understand why EEI is problematic, we need to go back to its origin. The concept was introduced by NASA climate modeler James Hansen in 1985, paper published in the journal Science. That paper was not primarily about measurements, but it was about climate response time, specifically how long would it take for the Earth temperature to fully respond to increases in atmospheric carbon dioxide. Hansen's model suggests that warming due to CO2 added by humans had not yet been fully realized by 1985 because the ocean absorbed heat slowly, creating a lag. But critically, the energy imbalance that Hansen invoked was not derived from measurement. It was a model output used to argue that humans needed to act now rather than wait for observable warming. This is the historical root of EEI. The abstract of the 1985 paper is revealing. It explicitly states that this unrealized warming calls into question a policy of wait and see regarding the issue of how to deal with increasing atmospheric carbon dioxide. In other words, EEI was not derived from first principle of physics or from measurements. It was constructed from the very beginning as an argument against a cautious evidence-based policy approach. As this presentation bluntly put it, EEI was wholly invented to kill wait-and-see policy response, not as a scientific deduction. That 1985 paper also confessed and admitted that the Earth may at some point undergo a rapid transition to the equilibrium climate for current atmospheric composition. So Hansen indeed also admitted that EEI index may not exist in the real world after all. The crooked road from Hansen 1985 speculation to its current status as an IPCC-endorsed measured quantity in 2026 is precisely what this presentation traces, a path, as we shall see, run in multiple loops of circle. The EEI concept reappeared prominently in a 2005 science paper by Hansen and colleagues. That paper calculated using a climate model driven by greenhouse gases and aerosols that the Earth was absorbing approximately 0.85 watt per meter square more energy than it was emitting. The paper then stated that this result was confirmed by precise measurement of increasing ocean heat content over the preceding decade. This is a subtle but critical sleight of hand. The EEI was not measured, it was a model output that was said to be consistent with ocean heat measurements, a circular argument that will recur throughout this talk. Before examining what the satellite and oceans are actually telling us, it is worth pausing on a deeper conceptual question. Does global warming require a genuine net energy imbalance, more energy coming in than leaving, or could surface temperature increases result from a mere redistribution of energy within the climate system without any net planetary imbalance at all? This distinction matters enormously for how we interpret EEI data. According to the pro-IPCC scientists, indeed global warming can only occur because of positive EEI imbalances. But this group of authors was studying climate change from last glacial maximum to the Holocene and the present, appears to be unwilling to admit that there were no human industrial activity to cause positive or negative EEI in the past. With that question in mind, let us look at what the best satellite instrument actually tells us. NASA operates a sophisticated set of satellites called CERES, or the Cloud and the Earth Radiant Energy System, designed specifically to measure the Earth radiation budget, how much solar energy coming in and how much Earth infrared radiation goes out. If EEI is real and measurable, the CERES should be able to detect it. The CERES team owned 2009 paper in the Journal of Climate authored by Norman Loeb and colleagues found that the raw 5-year global mean net flux from the standard CERES instrument was 6.5 watt per meter squared, not 0.85, not 0.7, 6.5. This is very worth highlighting. The raw satellite measurement is roughly 8 times larger than what Hansen's model predicted. The CERES team acknowledged that the major sources of uncertainty were instrument calibration errors of 4.2 watt per meter square and uncertainty in total solar irradiance of 1 watt per meter square. Together, these uncertainties are enormous compared to the claimed EEI signal. You cannot reliably detect a signal that is buried beneath uncertainty several times its own size. What happened next is extraordinary. Jim Hansen, in a 2011 paper in Atmospheric Chemistry and Physics, acknowledged that 6.5 watt per meter square uncertainty in CERES result. He then wrote that because this result was implausible, the CERES team introduced calibration factor to bring the measured imbalance in line with what their climate model expected, namely 0.85. Read that again carefully. The satellite data shows 6.5. The highly tuned and adjusted model say it should be 0.85. So the scientists insist on adjusting the satellite data to match the model. Then the model was said to be confirmed by satellite data. This is circular reasoning in its purest form. The IPCC's own 6 assessment AR6 report published in 2021 quietly admit this process, as we shall see in the next slide. The IPCC own energy budget diagram show EEI at 0.7 watt per meter square in a neat box in the lower left corner. But the text beside it in AR6 Working Group 1, Chapter 7, page 935, tells a more complicated story. The AR6 text states explicitly that NASA CERES data product were adjusted within the estimated uncertainty to ensure that the net top of atmosphere flux was consistent with the estimate of ocean heat content for the period 2005 to 2015. The satellite measurements were forced to agree with the ocean heat estimate. The ocean heat estimate was then used to validate the satellite measurement. Neither is an independent measurement of EEI. Well, the World Meteorological Organization, WMO, The parent organization of UNIPCC is not that far behind in terms of making false claim on the hypothetical EEI index in their latest report on the state of the global climate 2025 put out 2 weeks ago on March 23, 2026. It is rather humorous to us that the WMO heavy promotion of their use of EEI as a key climate indicator for the very first time in 2026 can now be immediately and instantly proven false by this talk and our published paper. But what are the real uncertainty or true error bars of all various proposals of EEI? A comprehensive 2024 paper by Maria Hakuba of NASA JPL and colleagues in Survey in Geophysics confirmed that the calibration and retrieval uncertainties in series data remain an order of magnitude larger than the claimed EEI value itself. This is the state of the art, not a historical limitation, but the current situation as of 2024 and 2026. The chart from Hakuba et al. Tells the story clearly. The series Terra single scanner data show a mean EEI of 4.4 watt per meter square. The adjusted series multi-platform product show 0.76. The two products show nearly the same trend over time, but their absolute values differ by nearly 4 watt per meter square. This is not a minor calibration offset. It is a fundamental inability to determine the absolute level of Earth energy balance. Regional comparison between NASA series observation and the European Weather Prediction Center's climate models reveals even larger discrepancy. Look at the bottom graph, where regional differences in incoming shockwave radiation between NASA series and the model ranging between plus and minus 8 and 70 watt per meter square in large area. Global averages hide these enormous regional errors that make the hunt for the claimed EEI of James Hansen and UNIPCC rather like searching for a needle in a haystack, or a very cruel joke if I can be politically incorrect. Now, let's talk about the ocean. I don't want this graph. Next graph. Let's talk about the ocean. The ocean is the dominant heat reservoir on Earth. Its average depth is approximately 3,700 meters or 12,000 feet or nearly 2.5 miles. Any honest attempt to measure the Earth energy imbalance via ocean heat content must grapple with how much of the ocean we have actually sampled. The answer is sobering. Only 6% of all hydrographic observation in historical database lie below 2,000 meters. Yet, approximately 52% of the entire ocean volume lie below 2,000 meters. The deep ocean, the part where holds most of the Earth's heat capacity, is for all practical purposes unmeasured. The Argo Float Network, the most advanced ocean monitoring system ever deployed, consists approximately of 4,400 autonomous floats spread across the global ocean as of April 2026. On a world map, this looks reasonably impressive, dots scattered across every ocean basin, but the appearance of wide coverage of surface ocean conceals a fundamental sampling problem of measuring the three-dimensional volume of water in the ocean. When you filter the Argo deployment map to show only float operating below 2,000 meters, the picture changes dramatically. The dense coverage on the ocean surface evaporates into a handful of isolated dots for deeper ocean, about 230 to be exact. Deep Argo float capable of profiling to 4,000 to 6,000 meters are being developed but remain very few in numbers. The deep ocean is not being monitored. It is being assumed. Let us now return to the claim IPCC of 4.4 watt per meter square. No, this is another slide that should not be there. Of EEI of 0.7 plus or minus 0.2, which rely heavily on the Argo-based ocean heat content measurement. This is indeed the question Jonathan Kohler and our co-author asked in our 2026 paper. What is the true uncertainty of that Argo-derived number? By the way, if you're not satisfied with my talk now, Jonathan is talking at the other room. We all should stop here and just run up there, right? Just kidding. Our paper, entitled IPCC EEI Assessment, is based on physically invalid Argo float estimate of global ocean heat content, systematically catalog 5 major categories of uncertainty. Unresolved mesoscale variability contribute plus minus 0.6 to 1.2. Persistent sampling gap in the deep ocean contribute plus minus 0.35. altimetry and mass budget uncertainty plus or minus 0.29 to 0.37, structural discrepancy between the Eulerian and Lagrangian measurement framework contribute plus or minus 0.1 to 0.4, arbitrary baseline and climatology choices add a further plus or minus 0.1 to 0.3. When compounded at 95% confidence level, the total uncertainty is at a minimum of plus or minus 1 watt per meter square. The claim signal of 0.7 by IPCC is entirely within that range. It is statistically not different from 0. Therefore, we can safely conclude that the Argo project is not able to rescue IPCC political claim on EEI. Before leaving the EEI discussion, we need to step back even further and ask about the most fundamental input into the Earth energy budget, the sun itself, obviously. But how well do we know how much solar energy is arriving at the top of the Earth's atmosphere? This is the question posed in the next major section of this presentation. The answer is deeply uncomfortable for those who claim precision in EEI measurements. So how does NASA CERES handle the question of total solar irradiance, or TSI for short? The broader problem is illustrated by the available satellite TSI data from 1978 till present. At least 17 different satellite instruments have measured total solar irradiance since the late 1970s. Isn't it obvious that all these satellite data do not agree with each other? Some show TSI values centered around 1365 to 1367, others around 1359 to 1362. The range of values across instruments is several watts per meter square, again far larger than the claimed EEI signal. A comprehensive 2024 analysis by Ronan Connolly, Michael Connolly, and myself and 5 other colleagues constructed 21 distinct TSI composite records from various combinations of these 17 instruments. The composite differ meaningfully in their long-term trend. Some show solar activity declining or staying flat, but others showing increasing trend over recent decades. See the highlighted group F. Grouping the 21 composite by the long-term solar cycle behavior produced 6 distinct families as shown in this slide. The choice of which TSI composite to use in climate model or NASA CERES product directly affect the computed EEI. There is no scientific consensus on which composite is correct. This uncertainty propagates through every EEI estimate that uses NASA CERES data. There is yet another layer of uncertainty that must be confronted. How well can we measure the Earth's planetary albedo, the fraction of incoming sunlight that the planet reflects to space without absorbing? Now, let us look at these 2 stunning images of Earth from the DISCOVER or the Deep Space Climate Observatory satellite. The DISCOVER satellite's EPIC camera, which viewed the Earth as a full disk from the L1 Lagrangian point, 1.5 million kilometers or 930,000 miles from Earth, illustrate the problem of measuring planetary albedo. On your left, on December 13, 2020, Earth measured planetary albedo was 0.35. On August 4, 2020, it was 0.253. This is a difference of nearly 0.1 in albedo, driven primarily by seasonal and meteorological changes in cloud cover. A change of only 0.01 in planetary albedo corresponds to a change in absorbed solar energy of roughly 3.4 watts per meter square. Day-to-day cloud variability alone can therefore produce energy flux change that are several times the entire EEI claim. The full daily albedo record from DISCOVER covering 2015 to 2021 show enormous variability. The albedo oscillates by about plus or minus 0.02 units or plus or minus 7 watts per meter square around its mean on time scale of days to week with additional seasonal structure. When all the years are stacked together by day of year, a clear seasonal pattern emerged in the DISCOVER data. The albedo peaked near the solstices, June and December, when either the northern or the southern hemisphere is tilted towards the sun and cloud patterns are at their most extreme. Comparing NASA's CERES-derived albedo with the range of IPCC climate model reveals substantial disagreement, particularly in the boreal summer months of June, July, August. The model do not agree with CERES, and CERES does not agree with DISCOVER. None of this discrepancy is small relative to the EEI signal. The most troubling aspect of the discrepancy between NASA Ceres and Discover is not in the magnitude of albedo, but in its seasonal timing. Ceres data on your left show peak albedo value occurring near the equinoxes, March and September. Discover data on your right shows a peak near the solstices, June and December. These are fundamentally different seasonal patterns. We do not know yet which instrument is correct, and the discrepancy has direct implication for how much solar energy can absorb at different times of the year. This slide perhaps requires no commentary. It is sufficient to note that when climate science's most celebrated satellite team admit that it cannot close its own energy budget without adjusting its data to match the model it's supposed to validate, and when IPCC quietly acknowledges this adjustment in a subordinate clause on page 935 of its Working Group 1 report, the metaphor of confused IPCC climate scientists chasing a phantom signal is not entirely uncharitable. This presentation arrived at a clear conclusion. The Earth energy imbalance as currently estimated and reported by IPCC and mainstream climate science is a phantom number. It is not a directly measured physical quantity. It is the residual of a series of model-anchored adjustments applied to satellite and ocean measurements that individually carry uncertainty many times larger than the claimed signal. When the full uncertainty budget is honestly accounted for, as Kohler et al. Do systematically, the total uncertainty in Argo-based EEI estimate is at least plus or minus 1 watt per meter square at 95% confidence level. The signal of 0.7 is entirely within that uncertainty range. It is statistically indistinguishable from zero. I think I'm going to close this, let's wrap up the discussion, right, of the phantom EEI with this quick video. Well, is this the phantom black cat that IPCC asked us to find in the darkroom? I think the black cat metaphor is apt, not because the Earth energy system is unimportant, but because the confidence with which EEI has been invoked in scientific report and policy document vastly exceed what the actual measurement can support. A more honest scientific community will report EEI as unmeasured and unmeasurable at current instrumental and systematic uncertainties, and would acknowledge that the claimed signal of 0.7 cannot be distinguished from zero with the tools currently available. Until that honest accounting is performed, EEI remains what it has been since James Hansen first invented it in 1985, a policy tool dressed in the language of measurement science. Climatology on the question of Earth energy imbalance is indeed like being in a dark room searching for a black cat that isn't there and shouting, "I found it." Thank you very much for your attention. And of course, this is a warm-up act for a talk that John Clauser will give tonight, tomorrow. Okay, you guys are next.
All right, thank you, Willie. And I say that I've never had an issue with black. In fact, I had a black cat try to cross in front of me, got scared and ran the other way. I don't know quite what to think of that. Anyway, our next guest is actually from Ireland. No mistaking the accent when you hear him. I was thinking as an improv person, maybe we could tell an Irish joke, Willie? No? An Irishman walks into a bar and, no, just, anyway. His name's Ronan Connolly. And he earned his Bachelor of Science in Chemistry from the University of College in Dublin. He got a PhD in computation chemistry in 2003 and a PhD, and actually won a BOCS award for the best doctoral research. He's worked in areas of sustainable aquaculture, wastewater treatment, energy efficient building design. He runs a global warming blog. I think it's called Global Warming Solved, and has contributed to numerous peer-reviewed publications. Little known fact about him, he also plays guitar, and you dance, right?
Yeah, that's okay.
So he can maybe do an Irish jig for you too. All right, without any further ado, Ronan Connolly.
Hi, I'm not sure how many of you caught this interesting, oh wait, do I press? Where do I point it? Here? No, point it. This one? No. I don't know, it's not moving. Okay. So I don't know if you managed to catch this interesting admission from the UN's Undersecretary for Global Communications in 2022. So let's have a listen.
For example,
can you
if
hear?
you Google climate change, you will, at the top of your search, you will get all kinds of UN resources. We started this partnership when we were shocked to see that when we Googled climate change, we were getting incredibly distorted information right at the top. So we're becoming much more proactive. You know, we own the science, and we think that the world, you know, should know it. And
wow, so I didn't know anybody could own the science. How exactly did they buy it? Or, well, let's have a look at this talk. So let's start off with the science that they owned in 1989. And this was the director of the UN Environment Programme was warning us that entire nations could be wiped off the face of the earth by rising sea levels if the global warming trend is not reversed by the year 2000. A little bit late, it seems. Okay, so just to give because I'm talking about the UN, but I'm just looking specifically at the climate change aspects. So there is different divisions in it, and the annual UN conference meetings are kind of under this branch. But what we're going to focus here is on the UNEP. They co-founded in 1988 the Intergovernmental Panel on Climate Change, or the IPCC. And so when you hear the UN climate change reports, that's what they're talking about. So let's start with the first assessment report in 1990. And I have to admit, and you can download all of these from the UN website as well. So, but I have to admit, this one is actually quite reasonable report. Even now, it's a decent report. And a key bit is they got it so that you can read it. You don't need to be a super specialist to try and follow it. So it had not too much jargon. And so they invited scientists from all sides to give their perspectives. And so it was like quite a relatively objective, but that was the problem. Because when you include all of the sides, then you get this thing. So what they focused in on is they said, well, look, the climate models say that humans should have caused about 0.5 degrees Celsius of global warming since the 19th century. And they said, and there has been about that much. And so they said it's broadly consistent with the climate models. But then because they had to present both sides, they also kind of were conceding, well, look, the 19th century was the end of the Little Ice Age, relatively cool period. And then they also pointed out the problem was that you had that warming mostly occurred in the early 20th century when CO2 was low. And then when you got up to the 1940s to the 70s, you actually had global cooling. So when the CO2 is supposed to be rising, it's cooling. And when it was the opposite of what they said. So the UN weren't very happy with that. So 5 years later, they said, can you do a better job? Do it again. And so they said, right, okay, we'll do it. The problem was, by the time they'd written most of the report, the results were still the same because the science hadn't changed that much. But fortunately for them, one of the authors, Dr. Ben Santer, he said, guys, I have 2 papers. They're not published yet, but I'm hoping that they will be published sometime soon. And I think these have provided the smoking gun, the fingerprint of human activity on climate change. And so on that basis, they added into the summary for policymakers, they added in this line here, the balance of evidence suggests a discernible human influence on global climate. Okay, discernible. Wow, so what were these 2 reports? Well, the first one, it's paper 1, it's not actually proof of anything. What they did is, remember saying there was the 1940s and 70s was cooling, which is the opposite of what you'd expect. Well, it said maybe that human-caused air pollution might be contributing to cooling, and so maybe there's another explanation, and so it hasn't been debunked by the temperature trends, but that's not a proof. But this was the big one. They said, oh, what we've done is we've run a computer model, and what we've done is we've predicted what the changes in the global temperatures in the atmosphere should be with increasing CO2. And this is a complicated thing, but just this is from their paper. That's the lower atmosphere, the troposphere. That's the upper atmosphere, the stratosphere. And that's the North Pole, South Pole in between. And each of the colours, the redder it is, the hotter, the more warmer you're getting. And they're saying, actually, you get these green cooling in the stratosphere. And they said, that's what our model said should have happened. And he said, between 1963 and 1988, this is what the weather balloons were showing. And they said, oh, look, the colours are kind of similar. That's their fingerprint. Okay, that's what they were saying. And then it's like, just have a note of this little one here, because Pat Michaels and Knappenberger, they pointed out that, yes, let's just look at this, the brightest red patch on their fingerprint. And he said, yeah, if you look from 1963 to 1988, it is warming. But if you looked from a longer period, from 1958 to 1995, it's the change to sign, not going up. That meant that big red blotch should have been a big green blotch. So it wasn't just Michaels and Knappenberger. We had a number of others, including Fred Singer, who was mentioned earlier on. And so this is the science they owned in 95, and the problem was that shortly after the publication, Dr. Sander's smoking gun went up in a puff of smoke. So the 2001 report, they said, okay, the problem is now Sander's fingerprints have gotten a bit too muddy, so they needed something else. But fortunately, they had another co-author, new one, Dr. Michael Mann, and he said, I have this paper, it was published, and it uses tree rings and ice core, other temperature proxies, and it shows that 1998 was the hottest year in 1,000 years. On that basis, they said, oh, it's likely human-caused. Okay. So this is a graph, a lot of you may be familiar with it, but you can see the idea is that it's like slight cooling for the first 1,000 years, and then around 1900, it rises up like the blade of an ice hockey stick. Do you see the comparison? Okay, so what happened after this report? Well, people started pointing out, a lot of people started publishing major flaws in the hockey stick, and including Willie contributed to this, but it's not just people like Willie who think that it's natural. We even had like the godfather of global warming, Wally Rucker, Hans von Storch. A load of people were all pointing out serious methodological flaws in the paper. And then other groups said, let's start doing our own temperature proxy reconstructions. And so you had here, this is the red line is the hockey stick. And then this is Esper et al. And they pointed out, look, 1,000 years ago, when Craig was mentioning about the Vikings colonizing Greenland, we had the medieval warm period. And then afterwards, we had a cooling, what was called the Little Ice Age. And then we got the current warm period. Okay, so that's not a hockey stick, is it? And then we also had Moberg et al. They actually went all the way back 2,000 years. And so you can see, again, 1,000 years, medieval warm period, Little Ice Age, and the current warm period. Now, some of you might be saying, oh, but Ronan, look, you have this little green bit here. It's hotter than that. Well, okay, the green bit is instrumental records. Proxies are good for doing comparisons, but they're not the same as instrumental. And if they were, when they're doing the weather reports, they don't cut down a tree, count the number of tree rings and say, that's what the temperature is. They use thermometers. So they're good for getting relative, but they're not, it's apples and oranges to compare the two. So this is a science they owned in 2001. And again, they were relying essentially the hockey stick graph, but then pointing out problems with that, others pointing out that there was a similar medieval warm period 1,000 years ago, and all of this stuff here. So now they were stuck. They couldn't use their hockey stick anymore, so they said, well, we have a new plan. Computer models, the savior of the IPCC. So they have what are called detection and attribution studies. So it's a little bit technical, but you need to understand it. What they do is, a forecast is you make a prediction of what's going to happen in the future, right? So a hindcast is you make a prediction about what should have happened in the past. So what the computer modelers were invited, they said, look, can you simulate what should have happened in the 20th century due to increases in greenhouse gases? Anthropogenic forcings is what they called it. And they said, could you also throw in some natural factors? So some of the models looked at changes in the total solar radiance, TSI, the amount of energy reaching the Earth from the sun. And they also said, let's look at volcanic activity. And then they said, look, some of them looked at both. And that gave us this pink envelope. Now, the black line is their global temperature curve. And you can see, it kind of fits in. But then they had 5 models, only 5, went and they reran it just with natural factors, and they got the blue envelope. And you see that the problem, they said, but look, from about the 60s on, you don't see, there's a divergence. And said, that is their proof. They said, so therefore, from the 60s on, is mostly anthropogenic. That's their argument. But is this a good argument? Well, the first question is their models good enough? Were they including enough natural factors? And I just explained their method of volcanic activity, they are only considering one factor. If you have a volcano that erupts the dust so high up into the stratosphere, then that called a stratospheric volcano, they say that leads to 2 to 3 years of cooling. But you can't get warming from cooling. So the only way you can get natural warming is if you get a long-term increase in TSI. So that's the only mechanism, according to these models, for having long-term warming. But other researchers have been pointing out there's loads of other mechanisms. You can have indirect solar influences, changes in oceanic and atmospheric circulation, other types of volcanic activity, cloud cover changes. So it's a very simplistic definition. But the other thing is, do we know how TSI has changed? And so it's like, the thing is, we don't have direct measurements of TSI before the satellite era. So what you have to rely on are solar proxies for it. And there are ones like the carbon-14, beryllium-10 isotopes, but the one that most groups focus in on is these sunspot numbers, which go back to Galileo's time. And the thing is, this is not so, essentially what they have is every 11 years or so, you get a rise and then a fall, a rise and a fall. And in the minimum, you end up having zero sunspots. You can't get less than 0 sunspots. So it's always the same minimum every cycle, but that you get sometimes increases from one to two. And so that's what a sunspot. You get see these, at the moment we have quite a few sunspots because we're at near solar maximum, but the solar proxy just goes up and down, always the same 0. But what's actually happening to TSI? So in 1978, we had Nimbus, and then in 1980s onwards, we had NASA's Akram satellites, and we've had more since, as Willie mentioned earlier on. And so they said, we can directly monitor TSI from space. Wow, we can finally see how good our sunspot proxies are. And then it turns out, they're not so good. So the thing is, you do get this 11-year cycle, but there are also changes between solar minima and solar maxima that are not captured by sunspots. So that causes a big problem for the groups using sunspots as a proxy for TSI, including the IPCC. So what is the IPCC? Well, fortunately, there is another rival group led by, Froelich and Lean. They said, do you know what we can do to fix this problem? What if we take NASA Akram satellite data and we adjust it until it matches the sunspots? Wow. Round of applause for the PMOD group. That was it. Now, so Scafetta and West, 2007, they just pointed out if you use the ACROM data instead and for calibrating your solar proxies, you could explain most of the warming since 1900 in terms of natural factors. So this was the science they owned in 2007. So what did they do for the next report? Well, they're probably very concerned about that. So they just ignored it. They said, ACROM, we just use PMOD, and we'll just repeat the same analysis. But this time we'll change it from it is very likely to it's extremely likely. Wow, that's a great idea. So it's essentially the same idea. You have on the left what they call natural forcings only, on the right natural and anthropogenic, and you see the divergence and say, oh, it's mostly human caused. So this is when I came onto this scene here with my first, myself and my late father, Michael. We collaborated with Willie. This is our first paper. So we went and we said, well, first of all, why are they just using the green Wang et al. TSI reconstruction? Some of them, there's other ones that are similar, but we found there was 8 TSI and like 4 of them were completely different character than those. So why are they only including that? And then the other thing is the urban heat island problem. We were saying, hang on a second, the urban heat island, cities are warmer than the surrounding countryside. Okay. But urban areas are only like 2 or 3% of the land, but they make up the majority of the weather stations that are used for calculating global temperatures are in areas that have become urbanized over the last century. And so the question is, how much of the global warming in the IPCC we're doing is actually local urban warming that's on a large scale? And the IPCC, based on largely on Jones et al. 1990, a very simplistic paper. They've been basically saying, oh, it's probably less than 10%, and so we don't really need to do anything about it. Okay, well, we said, look, let's have a more serious look. So what we did is we took all of the stations, urban and rural, and you get this curve here. And then we said, let's remove all of the urban and just look at for the northern hemisphere. We didn't have enough for the southern hemisphere. This is what we get. So the first thing is the long-term trend shows up to 38% could be urbanized. But the other thing is, note the character. This looks like just kind of a straight line going up with a few wiggles. But in the other one, it's kind of like warming up to the 1940s, cooling to the 70s, warming. It's almost cyclical. It's a different thing. So we said, I wonder what happens if we use one of the TSIs that the IPCC ignored and the black line. And then it's like, oh, that's an interesting result. Do you see it? Black line versus the rural temperatures. So Willie talked about this about 10 years ago at this conference. So you can check that out. But our paper was quite well received. Even we had people citing it. This guy, Professor Padman Chai, he was pointing out, oh, yeah, everyone, you should pay attention to what we're saying about TSI and the urbanization bias. So we were quite excited when we found out that he then was made co-chair for AR6. So we're like, oh, wow, it'll be a nice report. So we said, okay. But as time was getting closer to AR6, we were noticing they're just ignoring the TSI. In fact, they were knuckling in it and they're digging down and they were saying, we're only going to use a new one, Mattis et al., ignore all of the others, and they no mention of urban heat island. And so we were like, okay, the IPCC, it's a political group. They're trying to create something. We said we want to actually see what the scientific community is doing. And for us, consensus is for textbooks. Real science depends for its progress on continual charges. And so we have to address what the different perspectives, not just the ones that, so we did this collaboration involving a large number of scientists to try. And so what did we find? Well, first off, we found when we updated and improved our urban-rural, we got the same results. In fact, it was now 39%. But we also said, well, are there other estimates of temperature records? And we said, yeah, I want you to notice, these are different ones, but notice the cooling, warming, cooling that I was talking about before, tree rings, sea surface temperatures, glacier lengths, the weather balloons, and the satellites, all of these, this seems to be a real phenomenon. And then we said, do you remember I said there was 8 TSI? We now had found 16. And we were saying, oh, a lot of them are flat. And that was the one they looked in the 5th report. And now they were saying, oh, we're going to use this one. But why are they only using the flat TSIs with the cooling from or the decrease? What if they'd used any of these that were also available? They could have used them, but they didn't. And so what we found is, depending on which TSI you use and how you correct for urban heat islands, you can explain anything from global warming being mostly human-caused, as they said, or mostly natural, or somewhere in between, right? So how did they deal with that? Well, again, they completely ignored our papers. Now, look, it's not about my ego, don't really care, but just for the record, they are aware of us. They cited our paper on snow cover, where we were contradicting saying that their coverage of snow cover was completely wrong, except they twisted it to make it sound like we agreed with the IPCC. That's the way they do it. So they then said, but there was a journalist for the Epoch Times, Alex Newman. He was interested in this story because our paper had been published in June 2021, and the AR6 came out just a few weeks later, and they said, he asked the IPCC, did you consider this in your report? And they said, no, we didn't, because the deadline, we'd missed the deadline by 11 weeks, which is true, that's fair enough. But notice the corollary. That meant the day they launched their brand spanking new AR6 report, they were saying, oh, it's already past its sell-by date, and we know, and we don't care. Okay, that's the thing. And then I just want to knuckle down on just this other point that they mentioned, which was the urbanization. They repeated the claim, but not only did they insist in saying, they said this, cheek of them, they said, no recent literature has emerged to alter the AR5 finding. No recent literature has emerged to question it. It's like, or to alter. So look at Zhang et al. Zhang et al. 13% Scafetta, up to 40%. These were in the deadline, they had met it. But also, look at this, Xi et al. 2019, they cited this particular paper. Now, this is a large thing, so I just got to do it, but I just want to see. This is page 1 of Xi et al., okay? And so I just want to, let's zoom in on this little bit down here. And it's like, what does it say? AR5 said that urbanization bias is less than 10%. However, other studies have demonstrated that urbanization would have a much larger effect. Namely, Connolly and Connolly have analyzed this. So the paper that they're citing is already contradicting that statement. And it's like, look, IPCC, fine, you don't have to cite my work, but if you're going to cite a paper, can you at least please read the first page of the paper you're writing or citing? And so also remember, co-chair, he was talking about it. So Epoch Times asked, well, what happened? Why did you say that when the co-chair is saying it's an issue? He says, decisions on citations are up to the chapter team authors, not the co-chairs. So not even the co-chair input was sought on this. So this is the science that they've owned in 2021. And one other thing I wanted to point out, this is the exact same analysis since 2007, 2013. The only thing that changes is their confidence in it. It was very likely, extremely likely, and now it's unequivocal. And the literature is against it. So that is how the UN came to own the science.
We're becoming much more proactive. We own the science, and we think that the world, should know it. And
that's all, folks.
Okay, that was good. Good job. Oh, that was good. It brought back to mind one of the things we do at CFAX, we go to these UN conferences, and I've been going to like almost 30 of them. They're at COP 31, I guess, coming up this year. One of the early ones I went to was in Den Haag. I went with a guy named Chris Horner, some of you may know, from the Competitive Enterprise Institute. Also was there with David Rothbard from our organization. And the left is not really, the people in the UN are not really expecting people from Heartland, CEI, CFAC, CO2 Coalition to be at these meetings. So you can catch them off guard. And in this particular case, we wound up meeting up with a guy from the Brazilian Space Agency who was ahead of the IPCC, or at that time. And he sat down, we had some Belgian beer with him. And as we were talking, I started bringing up arguments that were mentioned by Dr. Soon and Ronan and others, just we're giving them basic science, some of the contradictions in their report. The guy kept agreeing with everything they were saying. He's ahead of the IPCC. He goes, yeah, no, they're right. They're right. I go like, okay, so why are you coming out making contradictory statements to what you know is wrong? He put his beer down, took our coasters and started moving. He said, this has nothing to do with the science. This is about moving the chips around. Interpret as you would. But it was very impactful for me. Got a chance to say that on C-SPAN right after that. Anyway, our next speaker, Arthur Viterito. I'm excited about what he has to say. He's a retired professor of physical geography, taught at the College of Southern Maryland, George Washington University, and University of Pittsburgh. He serves as an energy and climate advisor to the Heartland Institute. He's going to be talking about something that I guess is very much what you're working on, Bastardi, dealing with how energy, it calls it the geothermal paradox, volcanic activity under the ocean, I guess, and how that may influence temperature. So I'm excited to hear what he has to say. Oh, by the way, he's also a guitar player, very much like Ronan, and I am too. I was thinking of us getting together and we'd let Willie sing, maybe call ourselves Willie Soon and the Climate Skeptics. You want to?
Love it. Love it.
Yeah. All right, take it away.
Thank you. I'd also like to thank our hosts and sponsors here for giving me the opportunity to present this. It's the geothermal paradox, or what I like to call the one big beautiful paradox. And what it posits is that even though geothermal energy is only 0.03% of the total global energy budget, it's small, it appears to have had a significant impact on the Earth's recent temperature changes. And we're going to present some theoretical information, some observational information, and some statistical information to prove the point. Increasing geothermal heat flow strengthens the oceanic convection while intensifying the transport capacity of the ocean currents. Now, why is this important? The oceans contain 1,000 times as much energy as the entire atmosphere does. In fact, the top 3 meters of the ocean contain as much heat as the entire atmosphere does. So this is a massive reservoir of heat, and if you get it to move around a little bit and to somehow amplify heat exchange for different parts of the globe, it does make a difference. Now, 80% of the Earth's geothermal heat has its origins in the submarine volcanoes and hydrothermal vent fields. We see the hydrothermal vent fields here on the left-hand side. These are, we've all seen these National Geographic things with the gummy worms and all kinds of strange things crawling around out there. Temperatures coming out of these vents get up to 400 degrees Celsius, or about 750 degrees Fahrenheit. The underwater volcanoes, they're a little bit warmer. They get up to about 2,200 degrees Fahrenheit. So we can get some significant convective activity as a result of this. Now, here's a map of the zones where most of this geothermal heat is being realized. The largest area is off the west coast of South America. This is called the East Pacific Rise. The East Pacific Rise is a spreading area. It's an area where the crustal plates are being pulled apart. The Pacific Plate, for example, which is, of course, to the west of it, is being moved about 3 to 4 inches per year. That includes the plate, the lithosphere, and all the water that's on top of it. We also have the Mid-Atlantic Ridge here, which is the longest one, and then we have the Indian Ocean complex here, which comes down to the Mid-Atlantic Ridge, the Mid-Indian Ridge, and the Antarctic complexes of the Pacific and Indian Ocean. Now, as reported by Davis et al., and this is sort of a founding principle here, seafloor hydrothermal systems are known to respond to seismic and magmatic activity along mid-ocean ridges, often resulting in locally positive changes in the hydrothermal discharge rate and temperature. So, what we have here is a founding principle That is, whenever we have an earthquake, when we have seismic activity in these spreading zones, we're going to see changes in the temperature because these magmas come out pretty hot. Here we see a box diagram of this. We have our magma chamber down here. These are basaltic magmas that get up to, as we said, about 2,200 degrees Fahrenheit or 1,200 degrees Celsius. Now, they refer to this as a mid-ocean ridge. The mid-ocean ridge is actually part of a larger complex that I'm calling these spreading zone centers. And earthquake frequencies in these mid-ocean spreading zones thus provide us with a proxy for geothermal heat release. That is, the more seismic activity we see in these spreading zones, the more heat that's being released to the overlying ocean above it. Now, we've developed a 4-point flow chart for this geothermal paradox, and hopefully we'll walk you through this step by step. Increased geothermal heating in mid-ocean spreading zones will be driven by higher seismic activity in those areas. Let's see if we have, in fact, had more seismic activity in these mid-ocean ridges or these mid-ocean spreading zones. To assess this, we're going to use what is known as the GCMT catalog from Columbia University. It's the Global Centroid Moment Tensor Catalog. It is considered to be the highest quality seismic database in the world. They look at mid-size and large earthquakes, and they have what is called a magnitude of completeness of about 5.3, going back to the mid-70s. That is, they've recorded 100% or nearly 100% of all the earthquakes going back to the mid-70s. And this is really important. We want to make sure that we minimize sampling errors if we're going to be sampling the number of earthquakes that we've had. Here are a couple of references on this point. And in fact, if we graph what I'm calling MOSIA, mid-ocean spreading zone seismic activity. This is a noto bene, as they say in Italian, note this well. The mid-ocean spreading zone seismic activity, we see that there has been an increase starting down here in 1977. We start our time track. It moves up nicely. We see a big jump up that starts in 1995. I think Judith Curry talked about that today. And then we see another jump up going here in 2007, 2008. The 2005 data hasn't been completed yet. They run about 4 months behind to complete this catalog. So we're seeing that, yes, we've had a 5-fold increase from 1977 all the way up to 2014 is the high point on that, to about 108. Now, people say, look at the graph. Well, look at the frequencies are very, very low. They're like sunspot numbers. However, that's for the earthquakes 5.3 and higher. The entire envelope goes down to a seismic reading of 1, and it's a logarithmic relationship. So all of these numbers here, to get the entire seismic envelope, is times 10 to the 4th. So we're talking about 220,000 here and a little over 1 million here. So we got to keep that in mind. A lot of seismic activity. Now, so we've shown that there has been more seismic activity, or MOSIA has gone up. We can assume that greater geothermal heat flow will then result in more ocean convection plus stronger currents via what we call an intensified thermohaline circulation. And this is the key to this whole thing, this thermohaline circulation. Let's look at first the convection. And according to Model and Wheat, thermally driven convection of seawater occurs through oceanic crust of all ages. Most of the hydrothermal heat loss occurs on the mid-ocean ridge flanks. That's these spreading zones. As I said, I use the more comprehensive term. The estimated heat loss on the flanks is so large that upwelling must occur over a large fraction, 5 to 30% of the seafloor that's less than 65 million years in age. This is critically important. There's a lot of water sitting on top of these spreading zones. It takes a tremendous amount of heat to get it to convect. But there's enough heat, as I said, when you get up to 2,200 degrees Fahrenheit, you can convect these things. You can see that we have a large area of ocean. The reds, orange, and yellows are less than 65 million years of age. The vast majority of the ocean crust is less than 65 million years of age. 5 to 30% of that will get convection. All right, and convection at the bottom is critically important because that drives what we call the thermohaline circulation. And now we'll describe what that is. So, according to NOAA, they describe the thermohaline circulation as a process driven by density differences in water due to temperature and salinity variations in different parts of the ocean. It's also called the ocean conveyor belt. Here we see a bird's eye view of the thermohaline flow in the Atlantic. This is called the Atlantic Meridional Overturning Circulation, or AMOC. This is a critical component, a critical driver of the ocean circulation. And we see down here upwelling of bottom waters in Antarctica. This is due to what's called diapictal mixing. It then becomes a surface current that moves up through the entire Atlantic basin. And then we see downwelling off the coasts of Iceland and Greenland. And this downwelling is a critical driver of the thermohaline flow. Here we see a side view of this. This is the Atlantic circulation. We see here the upwelling of what's called the North Atlantic deep water off the coast of Antarctica. It then migrates through the tropics in the Atlantic basin, picks up heat, and then by the time it gets to mid-latitudes, it starts to lose heat. And as it loses heat in the Arctic region, it gets colder, and if it gets cold enough, it starts to freeze. And this is when the party starts. If you start to freeze seawater, the ice is rejected from the crystal matrix. What's left is fresh water. All icebergs are fresh water. And what you're now left with is a very, very cold and salty water that will sink rapidly. This area here in the Arctic is referred to as the chimneys. The chimneys displace an incredible amount of water, about 1 billion cubic meters of water per minute go down the chimneys, which is about 20 times as much as the total output of all the Earth's rivers. So there's a tremendous amount of water being pulled down to become the North Atlantic deep water, in which it then circulates back up and comes back. This entire thermohaline cycle is what is referred to as deep convection. Here we see the entire picture. We see upwelling in both the Pacific and Indian Ocean, and then we see the downwelling here in the Atlantic basin. This circulates the water over a period of about 1,000 years. Now, the critical part of this is that it doesn't move at the same speed. It varies. So, there's an extensive literature on the impacts of underwater geothermal heating on the thermohaline circulation. Here's a citation from Ballarata and colleagues. It is shown that ocean geothermal heat is a significant forcing that can weaken the stability of the water column, i.e. causing convection, warm the bottom water, and strengthen the thermohaline circulation. That is, this entire flow speeds up. Now, you say, well, that's just one article. What's the big deal on that? Do we have to really believe it? Well, here's 8 more of them, all peer-reviewed articles in top flight journals, Journal of Geophysical Research, Geophysical Research Letters. And here's 8 more. We're up to 16. I could have expanded this out a few more pages. There's an extensive literature on this that has been completely ignored by the climate community. They don't want to hear about this stuff. So, here we have a strengthening of the thermohaline circulation will then intensify ocean currents at all depths. Here we have what I call the 3 amigos. That is, according to NOAA, ocean currents are driven by wind, water density differences, which is the thermohaline flow, and tides. Okay? Tides, number 1, we can cross this off the list because these are constant. We predict tides years out into the future. Tidal tail. Any fishermen here? You know that they have tide tables. They go out, I think it's 2 years. It's a constant, okay, for the time frames that we're dealing with. Winds, of course, are highly variable. Thermohaline is also highly variable, as we saw from the Mosier graph. Strengthened currents will transport more heat from the tropics into the Pacific and the North Atlantic and the Arctic. And these are critical regions. The Arctic has warmed the fastest. That's called the Arctic amplification. The second fastest regions are the North Atlantic and the Pacific, and the third is the tropics. I'm going to show how it all ties together now. So here we see the thermohaline flow in the Pacific. We have a long fetch along the equatorial regions here, and then it runs into a thing called Southeast Asia and Australia. And here we have two continents coupled with a series of archipelagos that bottle the water up. That is, the water reaches a choke point. And this choke point forms what we call the Western Pacific Warm Pool. This Western Pacific Warm Pool is a critical feature of the oceanic circulation. And we can see that over time, this Western Pacific Warm Pool has gotten bigger, it has gotten warmer, it has gotten deeper as the thermocline has deepened, and it has also gotten bigger. Sea level has risen in this area. So, the excess heat from this expanded Western Pacific Warm Pool is then pushed eastward by the Kuroshio Current and the Kuroshio Extension. First northward and then eastward. These are the equivalents of the Gulf Stream in the Atlantic. And as we say here, the Kuroshio and the Kuroshio Extension, I'll show you a map in just a second, are warming 2 to 3 times faster than other areas of the ocean. The Kuroshio Current Extension is also shifting northward and increasing its transport capacity. In other words, it's pushing out more water and it's pushing out warmer water. Here we see the Kuroshio Current here. Here we see the Kuroshio Extension up here. And we can see here for June of 2023 a nice expression of this. We see that this area has warmed up very, very nicely. The North Pacific stands out. This is a semi-permanent feature now that we've been seeing in recent years. Let's take a look at the Kuroshio complex here. This is from Climate Reanalyzer. We're going to see what's going on in this area. Remember our three amigos: tides, constant, wind, thermohaline. Wind speeds have been going down. So if wind speeds are going down and tidal forces are constant, the only thing that can strengthen that is thermohaline intensification. That's the only thing that's left. We also get increased convection in this area. Off the east coast of Kamchatka, we have what's called the Forark Basin that puts out a tremendous amount of geothermal heat. It's a shallow continental shelf that's only 600 meters in depth or less, and it generates a number of hotspots. I wrote a short article on this about the geothermal hotspot back last summer. Thanks to Joe Bastardi, he pointed this out, said, hey, you got to take a look at this. And according to Google Gemini, hydrothermal activity off the east coast of Kamchatka is characterized by intense, ongoing, geologically complex, high-temperature submarine systems. The region contains over 30 active volcanoes and approximately 270 hydrothermal vents. The water that gets heated up off the coast of Kamchatka will be pushed southward, where it hooks up with the Kuroshio, and here we will push it out into the middle Atlantic. We have this nice triangular-shaped region off the east coast of Japan, and let's see what happens in a case study for August 12th, 2025. We see that this region was subjected to over 2,000 seismic events. That's 70 events per day, or a seismic event every 20 minutes. The area lights up like a Christmas tree. And you can see the entire Pacific Basin has lit up as the North Pacific Current pushes it around. This is a semi-permanent feature of the Pacific. As the geothermal activity increases in this area, we see the Pacific actively warming up. In the North Atlantic, we see a similar situation, but here the flow is what we call meridional. That is, it goes from south to north. Here we see the Gulf Stream, okay? And here we see the North Atlantic Current. And like its Western Pacific counterpart, the Atlantic also has a warm pool. It's called the Atlantic Warm Pool. And what's been happening to the Atlantic Warm Pool? The Atlantic Warm Pool has also been expanding. It's been growing at a rate of 500,000 square kilometers per decade. That's over the last 40 years. And the Gulf of, it's called the Gulf of America now, sorry, has experienced an acceleration of sea level rise between 2010 and 2020. A study by Smedzrud demonstrates that North Atlantic transport has increased significantly since 1900. A more granular study by Ozil using satellite-derived altimetry observations revealed an increase up to twofold in North Atlantic current surface velocities over the last 24 years. This is the North Atlantic Current. It moves through the European Arctic corridor. It gets squeezed in. It's pushing more water into the Arctic. This process is very well documented in the literature. It's called Atlantification. The more water you push up from the Atlantic into the Arctic, guess what? You warm up the Arctic. You warm up the Arctic ice starts to melt, and you then kick in a feedback mechanism. Let's look at the area studied by OZEAL from 1993 to 2016. This was their study area, and the wind speeds are down. So if the wind speeds are down, it's not the tides, it's not the wind speeds, it has to be thermohaline intensification. That's the only thing that can cause that. So, all of this, the expansion of these warm pools, the increased current velocities going to the North Pacific, the North Atlantic, and the Arctic, results in higher tropospheric temperatures, higher sea surface temperatures, and less Arctic sea ice. And that less Arctic sea ice contributes to what is called the Arctic amplification. The Arctic, by the way, is cooling twice as fast as the tropics and 7 times as fast as the South Pole. All right, so there's a huge differentiation here. And here we see the curve of Moja, which is our mid-ocean spreading zone seismic activity. That's the blue curve. And here's the red curve, which is the lower tropospheric temperature. And with using a 2-year lag, we see a tremendous amount of coherence in these 2 data sets. The R value is 0.74. This is an incredibly noisy system. We have urbanization, reforestation, deforestation, afforestation, desertification, changing cloud cover, and yet the mid-ocean spreading zone seismic activity, our proxy for geothermal heat, is accounting for 55% of the variation in the lower troposphere. And this is satellite-derived temperature. We say, let's take out the land because that's a complicated, it's a confounding variable in this. With a 1-year lag, we see that our mid-ocean spreading zone seismic activity in blue and the sea surface temperature anomaly. We're looking at the sea surface temperature. Here we see an R value of 0.85. That is explaining 72% of the variation in sea surface temperatures. Finally, if we look here at Moja and Arctic sea ice extent, here again, Moja's in blue. This is Arctic sea ice extent. We see that it's a perfect, almost perfect negative correlation. The correlation here is negative 0.91. If a student ever came to me and said, I found something with a negative 0.91 correlation, I'd say, go back and redo the experiment. Something's wrong. It's too high. We can invert that and say the inverse of Arctic sea ice extent is the amount of Arctic region that becomes ice-free. That is the ice-free Arctic, and flip it into a positive correlation with no lag, and it's practically a 1-to-1 correspondence. Here are critical summary statistics. This is the last slide. We can see the R values here, very, very high. This is the number I particularly like. This is what's called the p-value, for all you statistics junkies out there. This is the probability that the relationship between Moja and lower troposphere temperatures is about the same probability of you winning the Powerball lottery with a single ticket. Here we can see the correlations are higher with sea surface temperatures, very small numbers. That has 11 zeros before you get to a real number. This one for Arctic sea ice, that has 16 zeros and then an 8. In such a very noisy system with lots of feedbacks, all sorts of things going on, we're getting extremely high correlations here that are highly significant. In fact, in the statistical literature, they talk of highly statistically significant, and that's what we have here. So, thank you.
All right. Thank you, Arthur. That was good.
Thank you very much.
All right, we're going to be taking some questions. I just want to make one comment, and we'll have some people with microphones here looking for questions. But while we're waiting for our first question, just want to make this comment that there are I've had reporters come to me and say, you know, some of your scientists are touting things like you just saw here with the volcanoes, others the urban heat island effect, others the sun being the clean driver. He said, doesn't seem to be unity on this. I say, well, that's kind of true. I said, that's called the scientific method. We're not advancing just one theory, but we're letting them all be heard. What does unite us is we aren't buying the science that the UN is selling us. So our unity comes in opposition to what the Greens and the IPCC has been pushing. So, with that ado, is there a question? Oh, go ahead. And for you gentlemen, do we have a microphone for them, or should they just go up to the?
Speak right here.
Okay.
Well done, gentlemen. Thank you very much. Joseph Fournier from Alberta, Canada. All three of you guys are like I'm your fan. I've read everything you do. And I've spoken the most with Arthur, so I'm gonna direct you a question because I've really been captivated by your research going back to 2015. And I think the question I have is actually coincidental because we also got some of our best astrophysicists here. So I would like to ask, what is the connection between changing solar system climate, our environment within the solar system, and changing plate tectonic energies? Because it seems like something's driving the energy within our plates. That's what you said, Arthur, there about reminding us about the logarithmic scale for seismic activity. And we're talking million events peaking now. To me, it speaks to something external to the Earth that's driving this. I think there's been research that's showing that there's possibly a differential rate of rotation between the core and the mantle. So we're talking about something that's deep, deep in the Earth, correct? I'll leave it there.
I think if collectively we could answer that question, you're probably looking at 3 Nobel Prizes. I mean, that is a profound question. It is a truly profound question, and one that is going to require a profound answer. And do astronomical forces have an impact on this? I've read things that say yes, that they do, but I will defer to the astrophysicists on the panel here to see what their.
Well, the difficulty is, like you saw what I was showing with the different TSI, which TSI is the most simple definition, or aspect of solar variability, which is the changes in TSI. But we can't even agree on what the trends have been. As Willie showed at the end of his talk, a slide from our recent paper looking at the TSI, we don't even know if TSI has been increasing over the satellite era, if it's been flat, or if it increased and then went decreased. That's the honest answer that they're doing. Now, the IPCC and the UN, they know because they know everything before they even look. It's like, and so they're insisting that if you apply a whole series of adjustments to the satellite data that you can get a flat line. But what if it's an increasing? Well, if it's an increasing, you would get a similar positive thing. Now, so the thing about having a correlation is that, in our 2015 paper, we pointed out there are different reasons why you can have a correlation, and we actually categorized 4 types. So one is that you can have a causal correlation, and that's the one we're most interested in. This is following the other because this is causing it. But you could also have spurious ones. So you could have a coincidental correlation where, after another few data points, it disappears. And it was just a coincidence. And that's what things like p-values are trying to go against. And you also have a constructional correlation, which is where people are adjusting the data to create a thing. But a key bit is you have a commensal correlation. So a commensal correlation is when you don't know the 2 factors. One might not be causing the other, but they might both be caused by a common factor. So if you are looking at, say, you were showing a positive temperature, or, a trend going upwards, and then you were showing the Arctic going downwards. And if you'd looked at, say, F in the TSI ones, then you have it kind of going upwards. But if you looked at A in our TSI, it would be flat. So we really aren't at this stage. You could make a definite answer, but you have to cherry pick your data choice.
Can I say something? To answer you directly, I would like to point you to at least 3 talks I have done. I started this trend in 2018, 2023, maybe I did one for the Doctor for Disaster Preparedness. I have this, what you call a super duper concept that involves solar orbital, meteorological, climatological, tectonic, and magmatic relation. It is the whole bag, whole 9 yards, that I try to see them all together through coupling of not only the radiant energy to the relative sun-Earth distance and gravity, obviously. So it's a full-fledged of things that, and guess what? I have empirical evidence to show this thing. The earthquake phenomenon that I found that have that kind of relation, for example, season, right? You know that the difference between just winter and summer, that thing was huge, 90 watt per meter square, right, in terms of radiant energy. But it's also the relative distance. For example, if you look at all the volcanic eruption ever been recorded, right? So collection, Smithsonian has that big catalog, the whole thing. You will find very surprising if you phase all of this into individual month, you will see that it's not an equal distribution over every month. It's actually have a seasonal pattern that's related to the relative distance. That's the biggest surprise I've ever seen. And then there are more. And then I can show deep earthquake. So in my talk, I have all the data. I'll show you guys more later if you're interested, but it's a very complex problem. But that's the most, what you call, you study the whole thing to understand everything, not for just tiny little portion here and there, of course. That's my super duper theory, yeah. But it requires data to support it. I have some evidence.
Unfortunately, we have run out of time.
Oh,
but our panelists will be up here, and you can approach them afterwards. In the meantime, let's give them a round of applause, and thank you for all being at our panel today. relatives that I have from a long time ago were thinking of doing it, because I know some of the ones who can't do it. Apparently they speak English themselves. I know. So I'm gonna meet a bunch of relatives that I've never seen, but they're connected. They're like what are second cousins. I have a whole family in Europe that was left behind.
But you have to accept premises that are very, very unlikely, even to begin the mechanism to shut out.
Right, and that's what I say. So I did my spit thing, and I realized that I have I'm related to half of it. I got everything from English, German, Norwegian, name the country, my relatives are there. Oh, I found out I had Jewish roots. I did not know that. Not very much. I don't know as though I would have been deterred by something, but
They say Israel is the largest TV. The other one's real interesting is all the volcanic activity in the western ice shelf. Very. This guy's a hell of a lot more expensive. I'll let him take over.
I got along also for the other ones.
You basically said that they could calcify them and transports heat from the
I can't disown any of my kids. They all have 50% of my DNA. I have Spanish more. Only like 1% or 2%, but apparently I have No, I love it. I did not know. It doesn't go back to grandmother. showed up to like one before I They got it from so if they had had a month, yeah, that's what it is.
What does he work for? Me, James, and then Jeff. Yes.
We look for I'll control this. You don't have to choose anything on
It's all right. You're evicted, and you got to take all your stuff.
All right. Very funny, Calder. Yeah.
I'm actually speaking right here.
Should I read all? Yeah, well, I can't. I'm not Hollywood, so. Fighting climate change for more than 20 years. Okay. Where'd I put my goddamn pen? Wait, what? Start? Okay. Good afternoon, everyone. Thank you to conference hosts, the Heartland Institute, CFACT, CO2 Coalition, and What's Up With That, for hosting this vital gathering and for the opportunity to speak on this panel. I'm Danielle Carl, Special Advisor to the President of the Heartland Institute, and one of the proud co-founders and current Vice President of Ways and Means for Republican Women of Simi Valley and Moore Park. As a founder of our local Republican Women's chapter, I've seen firsthand how empowering conservative women at the grassroots level turns shared values into real action, and at the same fighting spirit that they show is exactly what's needed to win the courtroom battles that will restore sound science and American prosperity. For the next few minutes, I want to share something that should give every one of us real hope and a clear battle plan. We are not here just to complain about bad climate policy. We are here to end the era of Dr. UN says the science is settled, once and for all. In the one place where facts still beat narratives, the American courtroom. Everyday scientists who dare to present certified observations that contradict the UN climate story have their papers rejected without comment by the very journals that claim to love peer review. The gatekeepers have spoken. If it doesn't support the narrative, it doesn't exist. Federal courts are different. They remain the last safe haven for real science. Why? Because of Federal Rule of Evidence 702, the Daubert standard. Strengthened by the 2023 amendments, judges are now explicit gatekeepers. Generally accepted is no longer enough. Proponents of expert testimony must prove by a preponderance of the evidence that it is reliable. Every single claim must pass 4 rigorous Daubert criteria. Climate models and studies simply fail the reliability test when they are confronted with the actual certified observatory records from NASA, NOAA, and the other 11 global climate centers. Emphasis on the NASA and NOAA records and data, as opposed to speculative assertions and predictions, the NASA and NOAA bureaucracy has made to keep taxpayer dollars flowing their way. Once that unreliable causation testimony is excluded, the findings of fact in the case shift dramatically. Judges and juries are no longer base their decisions on computer game opinions. They base them on hard, certified data. And if a judge ignores a well-supported Daubert motion, that creates a clean record for appeal, all the way to the Supreme Court that wrote the strengthened FRE 702 rule in the first place. The results of this is that we can win. And what does victory look like? A win in court is not just one case, it is the beginning of the systematic downfall of UN climate theory inside the United States. It creates a proven playbook that energy-producing and Western nations can use to defeat modern-day politically imposed pseudoscience wherever it appears. Climate stops being a third rail issue. It becomes another proven example of government overreach, one that speaks directly to independent voters. It strengthens the case for continued conservative leadership that recognizes climate realism in 2028 and beyond. The human and environmental benefits are enormous. Accelerated greening of the earth, stronger marine and terrestrial habitats, higher living standards for everyone, especially the poor, through lower energy costs that restore access to education, healthcare, and opportunity. We are not starting from zero. Millions of social media views are already shifting public opinion in support of the EPA's heroic 2026 rescission of the 2009 CO2 endangerment finding. The three pillars that have sustained the UN narrative, courts, public opinion, and investment, can now be dismantled. The call to action is that nothing can be taken for granted. We must act immediately. Strategy and tactics must be planned and executed now to cut the narrative off at the knees, nail the coffin shut, and bury it deep. The EPA has shown courage. They need our support by fire. Defense counsel, policymakers, donors, and citizen activists in this room, you are the ones who will make this happen. Use the actual scientific data, support the lawyers filing these Daubert motions, amplify the certified data, and keep the pressure on every front. When we win in the courts, we don't just win a legal battle. We restore science, restore prosperity, restore hope, and restore America's leadership in both economic strength and genuine environmental stewardship. That sets the tone for the panel that we're having with such excellent panelists. And I'm going to first bring back on our James Taylor, the president of the Heartland Institute. For those of you that don't know, Taylor is the former managing editor of Environment and Climate News. He's been on just about every channel that you can think of, from CNN, Fox News, Fox Business Channel, MSNBC, PBS, NewsHour. It goes on and on. He has been in this climate fight for over 20 years, and he is leading the pack in all of the work that he does. So once again, our amazing Heartland President, James Taylor.
Thank you so much, Danielle. Thank you all for being here at the International Conference on Climate Change. Danielle is rather modest. She gave a little bit of an overview of her work, for example, with Republicans' Women's Club. But basically what she didn't tell you is that she used to be, now I get the exact title wrong, and she'll correct me on this, but essentially she was the executive assistant for the Director of Sustainability at the multi-billion-dollar corporation Netflix. Now think about this. You are the executive assistant for the Director of Sustainability, Director of the Sustainability Department. Your job, you're seeing all of the inside strategies and the vernacular that's being used within this woke leftist beast that's indoctrinating the world, and they have a separate department that specifically is designed to comply with, but also advocate for what they view as sustainability. Now, I can tell you from my experience working with Danielle, she's a dynamo, she's incredible, but it's funny when somebody there who just wants to do her job, and even though she understands that we're not really facing this climate crisis, and maybe she's not as woke as the rest of them, still doing her job, one day, people there at Netflix, we were at an event, happened to see Danielle and I talking, and they could not believe the disloyalty of speaking with someone that would be a climate denier. And after that, we'll just leave it at that for now. But Danielle has tremendous courage, professionalism. She is a real asset here at the Heartland Institute. Now, we also have on this panel a couple of late additions, which means I'm going to keep my time much shorter than I'd intended. That may be good for you. It may be good for climate alarmists, but it's going to happen either way. But a few points that I think are very important to mention. Danielle mentioned the Daubert standard, Federal Rules of Evidence 702, and it often gets overlooked. Really, we can talk about the data, we can talk about the evidence, we can talk about the specifics of what is and is not happening regarding climate change. But like in so many other topics that are in the policy debate today, that doesn't mean much if the courts step in, sometimes properly, sometimes not, overstepping their bounds. We see how the courts right now, many of the courts, John Roberts says there are not Democrat judges and Republican judges. Yes, there are, John. We know that. I mean, the more that you say it's not like that, the more that you undermine your own credibility. You have to acknowledge that. You can say the judges have integrity, we just see things differently. Okay, you can say that. But there are Republican judges, there are Democrat judges, and there are very activist judges, where we see the inclination, indeed the eagerness right now to destroy anything that Donald Trump is doing. And perhaps some of Trump's executive orders, maybe they do cross a boundary line of what's proper or not. But you can see when a certain case, or any case, goes in front of a certain judge in a certain court, you know what the outcome is right away. It's that way for Donald Trump's executive orders. It's that way for many other topics. We saw this at the Heartland Institute. We've been fighting big tech's coordinated censorship of free speech in social media. And there were laws passed in Florida and Texas to protect free speech online. And when big tech sued to invalidate those laws, coincidentally, or maybe not, each time in the federal district court, they got a Democrat-appointed judge. And I told my colleagues, okay, our side's going to lose. Doesn't matter. Well, it's Florida, it's Texas, they're on our side. Doesn't matter. You have a Democrat judge. And by the way, I looked into their specific histories, and they were indeed activist judges. And sure enough, they lost. Then you get to the federal appellate level. And both times, I believe it's the 11th and the 5th, Joe would know better than me, but in Texas, the federal circuit there. Five, yeah, so the 11th and the 5th, I was right. 30 years after law school, I still have it. So looking at the judges that were, again, randomly selected, it's like, wait a second, these are Democrat judges, at least that are, I believe it was in the 11th in Florida, this was majority Democrat appointed judges, defied the odds. In the 5th, we had a better draw. And sure enough, that was the outcome. The point is this, as Danielle mentioned, the Daubert Standard, Federal Rules of Evidence. We have lawsuits that are being waged, and Jeffrey and Joe are going to talk about that. Lawsuits where the environmental activists and climate activists are trying to hold big oil or whoever else responsible for mega damages for climate change. By the way, I have no sympathy, no special sympathy for big oil, but we are going to stand up for what the facts are regarding climate change. We are going to see climate activist groups sue and try to overturn the endangerment finding repeal, led by Lee Zeldin, who was here this morning. We have to understand and know how to navigate in the courts. The Daubert Standard is key. The Daubert Standard, Federal Rules of Evidence 702, which sets up what judges may or may not consider in terms of evidence, probative evidence. And the biggest takeaway is this: facts and data trump speculation. You must have facts and data. With that in mind, climate models are not scientific proof. Climate models are not even scientific evidence. They are speculation, largely by government bureaucrats or university professors whose funding dries up the moment the case for a climate crisis disappears. We need in the court of law, and we need public opinion, we need groups like the Heartland Institute, CFAC, CO2 Coalition, what's up with that, to make sure that the attorneys that are defending, especially EPA, understand that you have to point this out. You can't just, oftentimes they walk away. Sometimes the attorneys for EPA and other agencies, they don't even really believe in what the Trump administration is doing. They're career staff. They have to vigorously fight for what is proper legal tactics and strategies. But they also can't shy away from the evidence. I've heard from folks inside, attorneys that are working inside with EPA, connected to, speaking with, well, they don't want to go into the science because it gets too nitty-gritty and we fear that the other side may prevail. But if the only thing that's being offered to assert a climate crisis is models and predictions, all of which have failed. We have the data. Climate at a Glance, one of the books that you have in your goodie bag here. We have the scientific evidence that should be presented in a court of law when they say that because of climate change, we're getting worsening hurricanes, worsening tornadoes, all this harm and damage. BS. Don't shy away from the evidence. The data and the scientific evidence trump models and trump speculation. And that's why Danielle chose to lead with that and emphasize the importance of Federal Rule of Evidence 702. And it's not just models that are not proof. By the way, when there's a statement from the bureaucracy at NASA, NOAA, the UN IPCC, again, that is not proof. It's not even evidence. It's speculation. The facts and the data are on our side. So with that, I am going to turn the podium over to, first of all, it's going to be Holger Thus, and then we're going to have Jeffrey Clark and Joe Morris. Jeffrey Clark and Joe Morris really have been, they're attorneys that have fought many battles, and on this topic in particular with Jeffrey, so they'll have quite some valuable information to share. And Holger, I guess I'll make this my introduction of Holger, my formal, informal introduction of Holger. Holger Thus is the president of the European Institute for Climate and Energy. They're based in Germany. We have worked with Holger for many years, close to 20 years. They are the Heartland Institute of Germany, or you could say we're the ICA, the European Institute for Climate and Energy of America. But that's how close we are, that's how effective they are. And what breaks my heart, it really does, because it can happen here soon, and will if we make the wrong political decisions. The German government, and of course throughout the European Union, the same is happening. But the German government is cracking down on anybody who stands up to the party line on climate alarmism, or really anything else. But in this case, for the battles that they're waging, when I say battles they're waging, they present conferences like this to spread information. I'm just going to digress for one moment before turning it over to Holger. To show you how bad it gets, I was in Poland a couple weeks ago, and Tomasz Sakiewicz, and he has a video he's filmed, and we're going to show it either tonight or tomorrow, just a short little video. But he's kind of like the Rupert Murdoch of Poland. He founded and runs TV Republica, which is the Polish version of Fox News. They filmed and broadcast the CPAC Poland event last year. I was there. It was an amazing event, and they put it on Polish television. The Polish authorities have gone to Tomasz and said, we want the name, the address, the contact information for every person who attended that event. The Polish police. That's what's coming. That's what Holger's had to deal with in Germany. Not that specific example, but that type of legal persecution. And so with that, I'm going to turn the floor over to my good friend Holger Thus, fantastic organization, European Institute for Climate and Energy. Holger.
Thank you. Thank you for this wonderful introduction. I'm not used to such introductions, really. Thank you, really. I enjoyed it a lot, and also thank you one more time for the invitation to this conference. I really enjoy to be here, and it's been also a few years that I'm speaking at one of your conferences. It's really big fun, thank you. And I also believe in conferences because where can you meet so many wonderful, interesting people and find new books? And yeah, I enjoy it a lot. Now I try to unlock my telephone because my presentation is on my phone and it's switching itself off all the time. So that's going to be fun. Yeah, so maybe you go to the next slide. Yeah, exactly. Because I wanted to use the opportunity also to explain the situation a little bit. What's going on? Here's the thing. Okay, nobody told me. I wanted to explain the situation a little bit on our own example because this makes it a little bit more sense. So what you see here is this article where, I mean, you might wonder what ICCC does or doesn't do, or what it is, or how the situation is. And it's always this abstract debate about freedom and freedom of speech and all these things. Here you have and I'm talking now a little bit about ICCC, just that you have an example what's going on in Europe. And I think we are a good example for what James described a moment ago. So what you see here is a cutout of a so-called scientific study on climate deniers. Because it's now a science in itself, there was a decision inside the European Union a couple of years ago to fight climate denialism by going into these groups and to do kind of to do papers and conferences on deniers and and the people invited were sociologists, but also psychologists. They wanted to, of course, present us as like crazy people. And one of the results is this thing. And just to describe the methodology, because I've been asked, how do they fight you and how do you defend yourself? Okay, now somebody even calls me. It's also interesting. One more thing, like here on top, you see this logo. Maybe I go to the next slide because I was a little bit enlarging it also. So how does this work? I press the button. Yeah, okay. Yeah. So you see on top, Climate Social Science Network. So what they do, there's such a network. It looks funny, looks progressive, colorful, diverse. It's not as funny as it seems, because there you see the logo. This on the bottom is Brown University. So first lesson learned for today: international cooperation. Heartland ICCC is important because there are people in the EU. They are under investigation by so-called science organizations, and behind it is American Brown University. Yeah. I don't know. It feels funny. If you dive even deeper and you go through all these menu points here, you find that such reports are financed by you, the taxpayer, because there are now budget lines. I don't know if our friend Lee Zeldin was cutting these budget lines. I think he talked about it in the morning, but in the EU, these budget lines are definitely there. And in the neighborhood of these budget lines, of course, you also find budget lines for financing the media. We used to have these two ladies coming to these conferences, writing long articles about how bizarre all this is from their viewpoint, and they're all financed by the taxpayer, by the European Union. It's a lot of money, maybe not for them, but for a small NGO like ours, this would be a lot of money, I can tell you that. But what makes me happy, on the other hand, is when they then come to the conclusion that we are, if you can, I think in the back you cannot even read this. It says here, a stronghold of climate change denialism in Germany, case study of the output and press representation of the think tank ICCC. So I totally love this stronghold of climate change denialism. It's from 2022, and they say, they also, and this is, you can generalize this, climate change denialist think tanks have played a major role in climate obstructionism in the United States, and now I cannot even read it myself. And then it says also that they work with their US counterparts. And again, you can see, like that's the major conclusion is, yes, their work, ICCC's work, makes sense. The second conclusion in the summary is, and this international cooperation is playing a part. And the third conclusion, it's implicated, it's not really written here, is of course, and for that we have to fight them because this is so dangerous for our agenda. And I think everybody should know that, who's asking himself, why do we have these think tanks in Europe or in America? What are these people doing in Washington? the other thing, because there is a clock running, I have to go through these things a little bit with a, I mean, I could speak for hours about all these things that are playing a certain role if you do the job we do. Something totally else, legal framework. I understand this is here also kind of a lawyer's workshop, kind of. They also, step by step, changed the German constitution. And that's maybe, God forbid, but maybe you also get a democratic administration in a couple of years. And just to maybe it's interesting to see how they did it in Germany, because the constitutions are a bit similar with the federalism and all this. It started, I mean, the most important is that, like, really the thing that really changed everything was a new paragraph. It's 143H in our constitution. Like, our constitution has, I think, 145 paragraphs, and they introduced this. And they were defining as an official objective of the German constitution climate neutrality by 2045. And of course, climate neutrality is a weasel word based on fake science and hoaxes, but of course they take it that seriously. And this has two nice consequences. Number one is, and that's also the official explanation, they can now create as much fiat money. We are no longer speaking about budget lines or budgets, speaking about the creation of new fiat money for the saving our planet, basically. This is what it says. And what they are talking about is up to 500 billion euros annually, or even more if the gravity of the situation demands it. This is what they are saying to their own constitutional amendment. And they call this, on top of the insanity, they call this investments. You know, this is similar to the stuff that Lee Zeldin was talking about in the morning. Before that, there was a Supreme Court decision, and you know, you have a Supreme Court as well. Like, these court decisions, they take usually a long time. And in this case, it was like the court decision was on Monday, and the new law was in place on Friday, or something like this. I made this now up. Maybe it was 2 weeks, but not longer. So what you can see is it was a stunt. It was not really somebody with a problem going to the court. It was all very well prepared by certain interest groups. And you can also prove this. We don't have the time for this. What I also wanted to say with this constitution, I forgot this with this constitutional amendment, the election of the new parliament was in February. The old parliament, to amend the constitution and to implement such a paragraph, was meeting one more time in March 18 last year. And the new parliament started to work March 25. So even this, most of the people that studied law in Germany and know the constitution from there, they all agree that this was entirely unconstitutional. However, nobody cares. All the people, all the parties in our parliament, from the Greens to the Christian Democrats, except the conservative AfD party, agreed on the procedure, and the constitution has been amended that way. I mean, they do not even follow procedures that are like 70, 80 years old. So even this does not matter anymore when it's about saving the planet. The other point, I think people talked about this, scientific dissent leads to immediate job loss. I don't think I have to explain this. This is like the reason that people like me are talking about climate science and not real climate scientists. Yeah? I'm not a climate scientist. I also want to say this. I'm just a critique of climate science and climate scientists. So I think it's easy to understand. The media doesn't want to understand this, by the way, but I think you don't need to be a chef to understand that the soup is not very delicious. Yeah? That's like the thing, Anyways, then I also would like to mention at least all these institutes. I don't know if you ever heard of the IIASA. This is an international institute based in Vienna that was created under the infamous, I think, Johnson administration. Disarmament and all this, they are still there. And the president is this infamous Schellenhuber from Germany. It's a little bit like playing pool, you know. There are a lot of balls rolling around. They're all somehow connected. You don't know which one is falling into which hole and what is popping up and what, you know, what is next. And these people are, you just go to their website, and the first headline that you find is, I just picked this up, centuries of net negative emissions required to secure a safe climate future. And they are supposed to do entirely different stuff, but they've been hijacked and they are more or less shaping the agenda all over Europe. And democratic institutions have to come second, and I'm almost sure that such groups they have no legitimacy, but of course they were behind all these constitutional and other amendments. And their agenda is purely socialist. I must know it, I grew up in socialism. Net zero is an official target, yeah, that's like obvious. And what we see now in Germany is that the insolvencies of companies are at an all-time high. You as Americans should be happy about this. I was just reading, like, our biggest company, Siemens, is now investing $250 million in Lexington, North Carolina. Just imagine this. I've been in North Carolina. I mean, this is not really the most central place of the world, you know.
That's West Virginia.
That's West Virginia. Yeah, we learned this today. West Virginia is the center of the world. Anyways, more trees. Yeah. And the other thing is mass migration out of Germany. Like, it's a little bit like the Arabs are coming in, the Germans are moving out. I hope the president here understands that you know, there should be a big door, maybe that's like should be closed or more closed, but there should be a little door on the side, and you should let all these German doctors and engineers in. I think you need them. But seriously, of Generation C, 4 out of 5 of these young people are thinking about leaving Germany, and 1 out of 5 is already, like, they are 20, 25, they're already planning their emigration. They don't see a future for themselves in Germany anymore because of the overall situation. Then, of course, the last point is these little discriminations that are piling up against organizations like ours. EU regulations concerning censorship. I could talk for hours, but as I said, we have this watch here. And maybe if you have questions, I could answer this. The good news is that climate skepticism in Germany is on the rise. This was always a thing I did not understand. I'm also doing this for 20 years, and the Germans, they wanted to protect the climate like crazy, and the numbers are still very high, but they're now definitely going down. And of course, when something is developing in the direction the government doesn't want to see, then of course you have to a little bit think around the corner, because all these different polls I was quoting, they have not much to do with each other. You have to a little bit think for yourself. Well, it shouldn't be a problem since you're climate skeptics. So I don't know if you can read this. I can read it out for you. So there's data from 2009 saying 55% of the Germans ranked climate change as one of 4 most serious problems. That was higher than EU average. 2026, 15 years later, sorry, 17 years later, it's a little bit less. 53% of the Germans feel personally responsible for fighting climate change. And that's a drop from 69. And then climate updates, the other part, 72% say climate change is man-made and real, but 65% and only 65% are worried or very worried. But this is a drop in support also of 15% since 2021. So also the speed of decreasing numbers is accelerating. And then last number, AFD, this party is very conservative. They went up from, and they are climate skeptics. And the reason that they're climate skeptics is that we wrote it, or we helped them writing it in their manifesto, yeah? which was also not easy. I have to say this, like when they started this new party, the wind power lobby and other green lobby groups joined them and came there very well prepared, trying to somehow shape an alarmist right-wing party. I don't know if this works, but they at least tried very hard, and they were also very well financed. But the numbers of this party are like 2020, only 6 years ago, they were on 11% on the federal level, and now it's 25%. And you can see how this party has many problems. I'm not a member of this party, and I'm also not promoting any party politics, to be clear. But of course, you have to imagine how dire the situation is if the people support this party anyway, because you can also lose your job if you're active in this party, not as a voter, but if you're a very prominent member, then it could lead to personal consequences, serious ones. So that I'm already at the end of my presentation, but I wanted to say one thing, and also particularly because my friend Craig Wrightstone is interested in this. This is a mofetta. I don't know if you know what a mofetta is. I like to talk about mofettas because they are natural sources of carbon dioxide, and they're everywhere. And it has to become a passion of mine to look for these things. And because I really wonder, honestly, why we talk so much about carbon dioxide, but not so much about natural carbon dioxide sources. And so people tell me sometimes that's always the same amount of carbon dioxide emissions coming out of the ground. I don't really believe it. But I wanted to at least that you, because I do this all the time, I know that most people have never even heard the word mofetta. Yeah? So I wanted to, please forgive me for this little joke at the end of my presentation. So next time you invite me, I give you a nice presentation about mofettas if you want. And I also wanted to make sure that I'm really also a little bit at least interested in the science of climate change, not only arguing with government officials and criticizing them and all this political stuff. And yeah, that's already it. Thank you very much for your attention, and yeah.
So next up is Jeff Clark, who is the former President Trump selected and Senate confirmed Assistant Attorney General of the Environment and Natural Resources Division of the U.S. Justice Department. From 2020 to 2021, Jeff was also named, simultaneously served as the former Acting Assistant Attorney General of the DOJ's Civil Division. This is quite impressive. I'm reading it along. Here's Jeff.
Okay. Well, thank you, Danielle, and it's always an honor to be here. I was at the last conference that was held in Orlando. Instead, this time you guys have come to my adopted hometown since I've become a swamp dweller in Washington, D.C. And it was considerably more fun and more relaxed, I think, in Orlando. For me, everything in D.C. is tinged with tension. So I thank all of the organizers and you. Since I'm a late-breaking addition, you may be looking at me, other than the quick introduction of like, who's this guy? Why is he not on my program? So I'm grateful for them slotting me in. So look, I've been in Republican presidential administrations for a long time, going back to Bush 43. So in Bush 43, I was a Deputy Assistant Attorney General in the Environment Division. And then in Trump 45, President Trump made me the head of the Environment Division and then eventually also the head of the Civil Division at the same time. And that's 1,400 lawyers. I was coming off of that those stints when I was here for a prior conference. This time, actually, seems like you didn't get the memo. So I just left last month the first year of service for the Trump 47 administration. This time around, I was not dispatched to the Justice Department, but to an entity inside OMB, the Office of Management and Budget at the White House, so just a few blocks from here, running an entity called the Office of Information and Regulatory Affairs, which is called OIRA. And at this point, you may go to sleep unless you're really familiar with Washington, like what the heck is I was the acting administrator of OIRA. And I left after my 300 days under some complex statute called the Federal Vacancies Reform Act expired. Now I'm back at a think tank called the Oversight Project, where I welcome all of you to follow our activities. We're filing a brief tonight, actually, to try to keep you, even while you're visiting here, safe by getting final authorization through the courts for President Trump to have deployed the National Guard here to turn around the crime wave. But I have a more common title to the extent the media tries to translate things for people from the presidential administration. I was the regulation czar. That's what the newspapers would call me. So all of the regulations across the entire executive branch would come through me. And that includes all of EPA's regulations, and not just all of EPA's clean air regulations like the ones related to climate, which you're very interested in, but also EPA water regulations, EPA solid waste regulations, the Superfund statute, the Federal Communications Commission, the Securities and Exchange Commission's regulations of stock market offerings. You name it, it came through me. So it was a big job, and President Trump, for the first time ever, actually made all of the so-called independent agencies subject to OIRA, to the regulatory czar. And the president tasked us, so I'm going to give you some good news before I kind of start talking about some of the climate-specific topics. The good news is that in Trump 45, President Trump tasked OIRA and the whole administration with pulling down 2 regulations for every 1 new regulation that he put into federal law. And that goal was met. And so this time, President Trump decided he was going to set an even more ambitious goal. And in an executive order that he issued in January of 2025, he demanded that we actually achieve a 10-for-1 or more deregulatory ratio. And so we had to pull down 10 regulations for every new one that went in. And so I'm here to report to you, maybe I'll even, sometimes I get spoilers. I spoke recently at the Yale Law School to conservative law students there at the Federalist Society, and one of them actually had looked this up, so he's kind of ready for me, but maybe I'll catch you guys by surprise. So after the first year of the Trump administration for fiscal year 2025, what ratio do you think we achieved? And we exceeded 10-to-1. How much do you think we got to? 27-to-1, did I hear? What else? No, it's higher. Higher. Higher than 98. We got to 129-to-1. So, President Trump's deregulatory agenda is the most ambitious deregulatory agenda in history, and that record of accomplishment is unmatched, and I'm pleased to have helped President Trump for that first year. Now let me ask you, okay, you might say, all right, well, you're pulling down all kinds of things, but they regulate everything under the sun. You can pick up a unit credit for every time you bump off something even small, but let's aggregate it. Economically, I can tell you what the result is, and that's also impressive. So I'll tell you that in the second year of Trump 45 administration, his first term, so that was 2018, fiscal 2018, the total net amount of deregulation netted against new regulation was about $24 billion. So this time around, for fiscal 25, the first year of his second term, and you have to keep in mind it's only sort of part of a year because of when it starts with when you take the oath of office and get inaugurated, that was $212 billion. So in the first year of the second Trump term, we exceeded by almost an order of magnitude the amount of deregulation done in the second year of the Trump administration. So these are, thank you. These are very impressive numbers. I am going to talk about the endangerment finding and my history about it, which is probably the subject that was most interesting in grabbing me here for a presentation. But first, let me highlight something for you that I think has not gotten sufficient attention in the, I'll call it, conservative libertarian community, which is our total destruction of the California electric vehicles mandate. So the California, under their crazy leftist governors and the California Air Resources Board and the California legislature, they'd mandated phasing out conventionally powered vehicles, the internal combustion engine, and they were going to have all electric cars. And the way that works under the Clean Air Act is that, so let's go back to what I'll call the Clean Air Act kind of dawn of time. So before the Clean Air Act kind of comes in around 1970, in the 60s, California is experiencing a massive problem with smog. And that's because of the fact that it becomes a driving culture. If you've driven in California, I have, there just seem like there are freeways to everywhere, and constant jam-ups and the like. And this kind of started early, and it's also in a geographic situation where you got the sea and then you got the mountain, and the air kind of gets trapped, and then you have a smog problem. So they decided they were going to solve the smog problem with their own state regulations. But then along came, especially with the growth of the environmental movement, the Clean Air Act's passage in 1970, and then big amendments in 1977. And as part of that, Congress decided in its wisdom that for car manufacturers, right, you don't want to have 50 different cars you have to manufacture for each of the states in the country, right? It would be chaos. You couldn't achieve economies of scale. And so we just have to have one national regulatory standard that the auto manufacturers in Detroit back then, now we got a lot of international competition, could hit. But California said, hey, wait a minute, we've been regulating before you guys got here. We need a special exception. And much to my personal disappointment, since I spent a lot of time in my career in private practice when I was not in government fighting against the California Air Resources Board, they got a special exception. What they can do is they can go into EPA and they can say, hey, we would like to regulate more stringently than you because we have special air quality problems here in California, especially in LA, which is usually a severe non-attainment area under the Clean Air Act. And if they can make certain demonstrations, the EPA administrator will grant them an exemption from preemption, a waiver of preemption, it's called. And what that means is the supremacy clause doesn't kick in and the Clean Air Act does not prevent them from regulating. They're allowed to have their own standards. And this is why nationally, sometimes you might even notice it if you go to buy a new car, you'll sometimes see, does it have the California emissions package? A lot of times the manufacturers will make cars that just even meet the California standards, so it's easy and they can just make one car rather than, a potential 49 state car and a California car. Then also in Congress's extreme wisdom, in 1990, they amended this regime to allow other states to borrow the California system as long as those standards are identical to the ones in California. So-called identicality requirement. So, now you got actually I forget the precise number. I think it's more than a dozen states at this point. 16? Somebody tell me? You guys whispering? 16? Okay. So Bruce knows it's something on that order. And so you have the manufacturers producing, a kind of 16 state car and a car for the rest of the country, right? Unless they want to decide to voluntarily build everything up to the more stringent California standards. Okay, using this power and going to the Biden administration, they got preemption waivers for their electric vehicle mandate to try to wipe out all conventional cars in California and just have electric cars. So I've been critical of Congress in terms of what they've done in the Clean Air Act and the Clean Air Act 77 amendments and then the 1990 amendments. But here's something good that Congress did on the deregulatory front. They passed something called the Congressional Review Act. And what that provides is that when a new regulation is passed, it has to be sent to Congress. And Congress can pass a law, which in this instance they call a concurrent resolution. And if they pass that law, they can override the regulation. And then it has a special bonus feature, which is if Congress does that, if both houses pass such a concurrent resolution and they wipe out they wipe out any regulation. It's not just an environmental regulation. It's not just the California auto situation. But here, if they pass a resolution to override the preemption waivers, then California is out. And it's not just that those regulations are gone and then California can come back and do them. The statute, the Congressional Review Act, the CRA, provides that all substantially similar regulations to those California regulations are blotted out forever. In order for them to get those regulations back, they'd have to get a targeted new statute passed and through Congress allowing them to do that, which is a tall order, especially in our kind of gridlocked world. So Congress passed that at the start of the Trump administration. They blotted out 3 of these preemption waivers that were supporting the California electric vehicle mandate. President Trump, and I was there in the East Room in the signing ceremony when President Trump did it, he signed those into law. California electric vehicle mandates, dead, and hopefully permanently dead. Now, if Gavin Newsom becomes president, the left is creative. I'm sure they'll try new ways to get around that. Or maybe they'll get a new statute passed if they manage to get enough strength in both houses of Congress. But at least for the moment, the country is safe from these wacky electric vehicle mandates. And that is a major accomplishment that President Trump has already achieved. Thank you, Chuck. So now let me turn to the endangerment finding. And I have a long history with the endangerment finding. And the endangerment finding starts at an earlier stage even than the actual finding in the Obama administration, which is a case called Massachusetts versus EPA. So we have to take you back now to the Clinton administration. Clinton administration gets a rulemaking petition from a purpose-built group called the International Center for Technology Assessment, which looks to me to have disappeared from the map. So some leftists funded this group called ICTA. They filed a rulemaking petition and they said, we want to regulate carbon dioxide and other greenhouse gas emissions from new motor vehicles and engines. EPA, please do that. And the Clinton administration sat on it. They didn't do anything. And one reason why they could do that is that under administrative law, they really don't have a particular obligation to act on any timeline. But what did they do when President Bush, the younger, got elected? They decided to leave us a birthday present and going out the door, you coming in present. They put the petition out for public comment, and then that teed up the need for us to resolve it in some way. So in Bush 43, we denied the rulemaking petition. It was challenged in the DC circuit. I had a very heavy hand with the career people who reported to me and were not happy about following my instructions. But I argued that case in the DC circuit against the state of Massachusetts, which joined this tiny group, ICTA. And I won. I won 2-1. And then I returned to private practice. I had a young family, wanted to make some money. I worked right across the street at the old offices of Kirkland & Ellis. I thought the world was safe from this nonsense, but no such luck. The DC Circuit did reject the en banc petition, so the full court didn't take the case, but the Supreme Court accepted cert. Sadly, my former colleagues in the Solicitor General's office, because they take over Supreme Court cases, they flubbed it, and they lost 5-4. And then the Bush administration double flubbed it, because they could have just gone back to what the Clinton administration had done and sat on the petition and not do anything and leave office. But no, some genius decided they were going to put it out for comment again. And they also decided to put it out for comment. Just think of how dumb this is. And I can be critical of an administration even that I was a member of, because I was certainly telling them not to do this. The political people put out statements in the Federal Register notice that said it would be dumb to regulate greenhouse gases. It would be disastrous for the national economy. There are very serious scientific questions here, like we wouldn't do it. But they also put out EPA career people's view that it was lawful to have these regulations, that they would be a good idea, and that it would not be economically disastrous. And the two things went out together. And then that was what the Obama administration picks up. So they come in 2009, and President Obama puts together his team. He gets a very bright leftist law professor from Georgetown, a woman named Lisa Heinzerling, who was a Justice Brennan clerk and a Judge Posner clerk on the Seventh Circuit. Very, for those of you who don't know, very stellar legal academic credentials. She writes a plan for them to issue a series of 4 rules, the first of which is the endangerment finding, and then boom, we have climate regulation for the first time in history. And then, now I'm in private practice, I challenged the endangerment finding. The DC Circuit ruled against us, but we did manage to bring down one of those rules in the Supreme Court in a later case called UARG that Justice Scalia wrote. So we had a partial victory, but we didn't have a complete victory, and the endangerment finding was still on the books. I was part of efforts in Trump 45 to get the Trump 45 administration to pull down the endangerment finding. President Trump did pull out of the Paris Climate Accords, which is great, and then he pulled out of them again in Trump 47. Could not get across the finish line pulling down the endangerment finding in Trump 45, but I don't give up, and the people I work with don't give up. We did get it, a final rule pulling down the endangerment finding in the Trump 47 administration. And so now, I can't claim that that's, there is some litigation about the Congressional Review Act pull down of the California electric vehicle mandate, but I just don't see how that could possibly survive. Far more of a case that's going to be a real fight, first in the DC Circuit, which one of your earlier speakers said had been stacked against us. That was current governor, former AG of West Virginia, Patrick Morrisey, who I worked with on all these things over the years. And it is stacked. It was stacked by President Obama. So it's going to be hard to win there because we're probably going to get a majority Democrat judge panel there. Hopefully, maybe we'll get a majority Republican judge panel. Maybe we'll get at least one Republican judge to dissent. But we're going to have to fight that through the DC Circuit. I think everyone anticipates that the issue of the endangerment finding is so huge and so costly. You know, I've seen good estimates that I believe from very solid economists that it costs the national economy tens of trillions of dollars, okay? So, and this thing is foundational not just for mobile source regulation, the cars I talked about, but for stationary source regulations and things like the Obama Clean Power Plan. So being able to like permanently inter that and stack up, you know, feet and feet of earth on top of it so it can't, you know, become a zombie or a vampire is the goal. But I think everyone realizes we're going to have to do that in the Supreme Court. And if we can, you know, it's a question of like, can we hit, you know, a home run or at least a, you know, stand up double or triple or something like that, just to preserve pulling down this endangerment finding, that would be great. A true home run, which is what Governor Morrisey at lunch was arguing for you, really should happen, is it would be great after his win in the West Virginia versus EPA case, which instantiated the so-called major questions doctrine, that if you have a major question of economic and vast economic and political significance, then you need an especially clear statement from Congress in order to regulate, and that doesn't exist as to anything related to climate, then we could really hit the grand slam. What would the grand slam be? The Supreme Court saying, you know what, in Mass versus EPA, we said that carbon dioxide was an air pollutant, which Justice Scalia mocked in dissent. He called it, your theory that anything that enters the air is an air pollutant it means that everything from frisbees to flatulence could be denominated as air pollutants, right? To permanently get rid of that and have the Supreme Court say, you know what? That was relatively ambiguous text. We don't see a clear statement in the Clean Air Act that you can regulate for climate change purposes. And therefore, the major questions doctrine applies, and therefore, EPA was right to repeal the endangerment finding, and then the thing can't come back unless Congress passes a totally new statute, which again is a very tall order. So with that, I will leave it there and turn it over to the next speaker.
So next up is a member of the Board of Directors at the Heartland Institute. He serves as the chairman, Mr. Joseph A. Morris, who was elected as the chairman back in 2020. Mr. Morris is a partner in the law firm of Morris and De La Rosa with offices in Chicago and London. He maintains an active practice conducting trials and appeals in the areas of constitutional, business, labor, and international law. He is a member of the bars of the Supreme Court of the United States, the Supreme Court of Illinois, and several other courts. And yet another very impressive background, but to get to it, Mr. Morris.
Thank you, Danielle. Thank you. Like Jeff, I used to work down the street at the Department of Justice. I was an assistant attorney general under President Reagan and Attorney General Meese. I'm pleased to say that I was present at the creation of the originalist movement when General Meese launched that effort with a remarkable address to the American Bar Association. Let me begin by echoing something. I'm delighted to share the platform today with Jeff Price because the work that he's been doing for the last year or so at what sounds terribly bureaucratic, OIRA, the Office of Information and Regulatory Affairs, seems gray. It's actually extremely important, and it has a pedigree that goes all the way back to President Nixon, who tried to get control of the administrative state by creating a point under the control of the president where when all of the agencies, including independent agencies, promulgated regulations, they had to pass through some kind of review controlled by the President of the United States. Now, the theory of that is not terribly complicated to those of us who merely read the Constitution of the United States. And all paths, by the way, in my remarks will come back to this. The Constitution of the United States, don't leave home without it. That applies to you too, Holger, and I'll get to that in a moment. Article 2 in Section 1 of Article 2 of the Constitution vests all executive power under the Constitution in a President of the United States, which means that any executive power that's exercised by anybody, whether it's a soldier, a lawyer, a regulator, derives from the president. They derive all of their authority from the president, and they are under the supervision of the president. And beginning with President Nixon, there was an effort to get control of this process. And strangely enough, it's contested. It's contested by the bureaucrats who don't like being supervised. It's contested by people on Capitol Hill who like having points of contact other than the president through whom they can get things done behind the president's back, so to speak. So presidents consistently, of both parties, but mostly Republican presidents, have tried to get control of the executive branch through various features. And finally, with the enactment of the Paperwork Reduction Act, President Reagan got authority to create an office inside the Office of Management Budget with somebody immediately below the director of that office, now to be the director of the Office of Information and Regulatory Affairs, to be that reviewing person. And that office has a tremendous pedigree from the time of President Reagan until the time of Jeff Price. I think the first director of that office was a guy you've all heard of, Jim Miller, who went on to be an economist, who went on to be the director of OMB. He was followed by Chris DeMuth, who ran the American Enterprise Institute for many years. He was followed by Douglas Ginsburg, who is now a judge of the U.S. Court of Appeals, one of the good guys on the U.S. Court of Appeals here in the District of Columbia. Wendy Lee Graham held that office. Naomi Rao, who's now a judge of the U.S. Court of Appeals, held that office. Some very super people have worked very hard to get control of the bureaucracy under presidents who were serious about it, such as President Reagan. But these guys, in President Trump's administration and Jeffrey Price, who have perhaps done more to accomplish that in all these years. And that is because, and here's something that's very good news, and I think it's also something very dangerous. Donald J. Trump has given the world a master class in how to push the exercise of executive power to the extreme, to the maximum. He's pushed the envelope over and over again in direct control of the bureaucracy, in the use of executive orders, in the assertion of control over the independent agencies. We've got Supreme Court litigation underway right now over the president's control of things like the Federal Reserve Board and other putatively independent agencies and so forth. I remind you, there's no power in the Constitution to execute anything other than through Article 2, and that means the president, right? Now, that's all good news because we see very good things flowing from that, including the work of Jeff Price, right? The danger, of course, is that we're not the only ones who are paying attention to how to use these levers in such an aggressive and robust way as President Trump is doing. And there will be successor presidents who have very different political objectives than those of President Trump. There will be presidents who will want to reanimate the administrative state. There will be presidents who will want to use the powers of the presidency to exert ever more dirigist control over the economy. And as they do that, they will look back to the precedents set by President Trump in this amazing demonstration that we've seen for the last 14 months of the use of presidential power. We've been cheering it, and rightly so. But the question is, how do we keep those tools from getting those levers of power being controlled by people who have very different objectives and a less robust attention to the ultimate question of the freedom of the American people, including private property, free enterprise, and the like. Now, that's where the rest of the Constitution becomes extremely important, and that's why the role of the courts, a robust role of the courts, in asserting the boundaries of constitutional authority, including forcing Congress to do what Congress often does not want to do, and that is to exercise its responsibility to make major decisions. Because if you think about it, Congress at any moment could roll back many of the excesses of the administrative state simply by legislating boundaries. Now, there are lots of political reasons why Congress doesn't like to do that. Part of that is the simple objective of most individual Congress members is simply to earn re-election. And how do you earn re-election? It is by avoiding making controversial decisions. And if the people get the sense that Congress is ultimately responsible for policy choices that are being made, well, then people get mad at Congress. So it's far easier for Congress as an institution to identify a problem, deplore the problem, create an agency to solve the problem, give the agency the name of the problem, like the Environmental Protection Agency or the National Highway Transportation Safety Administration or some such thing, and then delegate to it the responsibility for fixing the problem. Now, you know what happens, of course. It adopts regulations. People challenge the regulations. They go to court. It takes the court years to decide the challenges of the regulations. Then the regulations come back. They go in force. People don't like the outcomes when the regulations go in force. They challenge them in court again, right? And the litigation follows. And it's years, and therefore several election cycles, it's years that follow before the actual consequences of whatever it is that Congress did becomes apparent. And people can say, well, Congress was to blame, except that was Congress, 3, 5, 8 elections ago. In the meantime, members of Congress say, listen, I've done what I can do about the problem. I've said, executive branch, go fix the problem. If you don't like what's going on, blame the president, blame the agency, blame the courts, don't blame me. That is the heart of the problem, the evasion of the major questions responsibility of Congress. That is the heart of the delegation doctrine problem. Congress gets a benefit out of shirking responsibilities, doesn't it? In that electoral, in that political sense. And if there is something that the American people could do at the grassroots level on a daily basis to adjust that problem, it's simply to ask Congress to take responsibility for making major decisions. Now, the Supreme Court of the United States, in recent times, is doing its part by refocusing those questions, taking away the ability of executive agencies without the approval of Congress and the president to make major decisions by saying we need to revisit these questions. The boundaries of power need to be redrawn, and that's why the overruling of the Chevron decision, which we just talked about this morning, and the reinvigoration of the major questions doctrine are so important. And what is at stake there is the vitality of the American experiment that we began 250 years ago with the Declaration of Independence, leading to the adoption of our Constitution some 13 years later. Now, that Constitution is rather different from Germany's Constitution in that it is even harder to amend than Germany's Constitution, and it has built into it not only some pretty strict separation of powers notions, which, if enforced, go a long way to protecting liberty, including liberty over private property and free markets, but also the First Amendment. And the absolutely single most important legal question in front of all of us, including every one of you, which is your freedom of speech. Because freedom of speech is not only the heart and soul of citizenship in what ought to be a free country. Freedom of speech is also the heart and soul of the scientific method, isn't it? That is the essence of the scientific method. It is the freedom to pursue the truth and speak your results. Tell the world what you know. Tell the world what you question. Tell the world what you doubt. And tell the world what must be doubted and what must be tested in order to pursue those doubts. There is no scientific method. There is no scientific process without freedom of speech. And that's why the core responsibility of people who work and try to defend and vindicate the Constitution of the United States has to be the protection of the freedom of speech. Now let me speak to one last matter in litigation that I think this audience, our friends, the friends of all the sponsoring organizations, including the Heartland Institute, will appreciate, because we have often ourselves, whether individually or institutionally, been defendants or near defendants in lawsuits of the kind I'm about to address. On February 23rd of this year, just a few weeks ago, the Supreme Court of the United States agreed to decide a case coming up from the Supreme Court of Colorado. That case was brought by the commissioners of the county of Boulder and the city government of Boulder, Colorado. And they sued the Suncor Energy Corporation, a couple of its entities, and the ExxonMobil Corporation. This is a lawsuit that they started in state court, and what they sued for was state torts by the energy companies for doing what? For selling fossil fuels to create the climate crisis. I'm not making that up. These are selling fossil fuels and thereby creating the climate crisis with impacts in Colorado, they claim violated common law rights against public nuisance, private nuisance, unjust enrichment, also violated the rights of Coloradans under the Colorado Consumer Protection Act. And then also they charged conspiracy. Now, what's the wrongdoing that they claimed that the energy companies had done? First, selling fossil fuels, and thereby causing the climate crisis to the injury of the people of Colorado. And second, defrauding the people of Colorado by knowing the truth about the climate crisis and hiding it. Now, on that last theme, of course, we want to chuckle. Hiding the truth about the climate crisis? You claim that the energy companies had secret knowledge about what use of fossil fuels do. The energy companies had secret knowledge about what goes into the atmosphere. Al Gore has been telling the world, the United Nations has been telling the world about the truth of climate science, right? About the dangers of emissions. By the way, Holger, you showed us a very interesting muddy picture of a source of carbon dioxide emissions. Behold, I am a source of carbon dioxide emissions. Right? Yeah, this is what I mean. Yes. The lawsuits contend that the energy companies knew the truth and hid the truth. Now, that's a pretty far-fetched notion given the immense public debate over the climate issues. But think about it for a moment. They also charged conspiracy And who are the other participants in the conspiracy if you wanted to broaden the conspiracy beyond the energy industry? Well, wouldn't you know it, everybody in this room is a member of that conspiracy, aren't we? We all speak up in opposition to the consensus, and thereby, by the lights of these litigants, we are parts of a conspiracy and should be not only silenced, but made to pay the county and city of Boulder, Colorado, for whatever the climate crisis has cost them. The energy companies responded to this first by removing the case from state court, from the Colorado State Court, which I think makes sense because the local plaintiffs are bringing the case in the local court and they're suing people from outside the state on a theory of local law, Colorado state law, governing the issues, the controversies in the case. And the first thing that happened when they got to the federal district court in Colorado was that the plaintiffs moved for remand back to state court on the theory that it fell under an exception to the federal jurisdictional rules. And the state court agreed. Rather, the federal court agreed and remanded the case to the state court, the state trial level court. The energy companies appealed to the Court of Appeals for the 10th Circuit. The Court of Appeals for the 10th Circuit affirmed the lower court, and so the energy companies then took the case to the Supreme Court of the United States. This is a while back. And the Supreme Court of the United States thought about the matter, and over a dissent by Justice Kavanaugh, denied certiorari, denied review. So the case went back to the state courts in Colorado, and the first thing that happened in the trial level court in the state court in Colorado is the energy companies moved to dismiss for failure to state a claim. To put a little flesh on those bones, they argued that they did nothing that violated the common law rules of torts, but more important, there is no state law of torts that governs this. It's been preempted by federal law, beginning with the Federal Environmental Acts, the Clean Air Act, which completely, the argument is, vacates state regulation of the field, and the trial court denied that, saying it's true that the Congress, in enacting the Clean Air Act, vacated the federal common law of such torts crossing state lines, but that leaves in place the state common law, the law of Colorado. Thank you very much. We'll proceed with this case. That decision was appealed to the Supreme Court of Colorado. The Supreme Court of Colorado, with 2 dissents by justices of that court, affirmed the trial court. And then the energy companies came back to the Supreme Court of the United States on the question of whether or not this case can go forward to trial in Colorado, or if it is in fact preempted by federal law, if this is a case, because it implicates interstate commerce, international commerce, and the powers of the federal government that have been asserted by Congress in that field, the case does not belong in state court at all. And that is the case that the Supreme Court of the United States has agreed to take up. Now, that case is being briefed now, and it will be decided, it will be argued, I'm sure, in the fall. I don't think we have enough time between April and June to get the case fully briefed and argued now. So it'll be heard next fall, and it'll be decided sometime within the next year by the Supreme Court of the United States. Now, in order to decide that case, the court, because it's faithful to the Constitution of the United States, is going to have to address the questions of whether or not it has jurisdiction to decide that case. There will be an interesting fight that probably is more interesting for lawyers than it is for citizens and scientists about whether or not the Supreme Court has jurisdiction to decide that case. But I think there's a pretty good indication. It takes a minimum of 4 justices to agree to decide a case, and they took that case knowing that they have to decide the jurisdictional issues. So I think there's an appetite for the Supreme Court of the United States to decide this case. And I think they understand both the implications of this case for the question of federal preemption of state attempts to regulate this field on a piece-by-piece, on a case-by-case, state-by-state basis in a way that, of course, would create a patchwork quilt of regulations, 50 different state rules regarding cars and gasoline formulae and who has to pay what penance for being a quote-unquote climate denier. Now, the significance of this case it goes, I think, beyond the mere dealing with an annoying bit of litigation in Colorado. Because many of us in the room know that this isn't the only case of that kind that's been brought around the country. They've been brought in New York, they've been brought in Illinois, they've been brought in Hawaii and several other places, often by the same law firm that goes around to local governments, city governments and county governments, and saying, listen, this is going to cost you nothing. We're going to sue the energy companies, and by the way, anybody else who might be part of their conspiracy. So there's somebody, some organization, local organization that's constantly yipping that there is no climate crisis, we'll sue them too, and allege that they're part of the conspiracy that's defrauding your people and preventing the truth from being spoken. You don't have to pay us anything. We'll sue them for damages, and when we collect the damages, we'll take a third or whatever the proportion is that we agree on. So this kind of litigation is not unique. What is unique and important about it is this is the first time that this litigation and the qualitative aspects of it that merit judicial scrutiny have finally gotten to the Supreme Court of the United States. So watch this space. In that case are bound up questions of the power of the judiciary to shape jurisdictional questions, the power of the federal government to assert supremacy in the field of interstate and international commerce, and the duty of the judiciary to protect against improvident uses of state law to shut down speech by alleging that part of the tort, part of the wrong, is suppressing truth in a conspiratorial way. All of that is on the table. And I am optimistic that we have an opportunity here to strike a serious blow for freedom through the judicial system. Now, when I look at you, ladies and gentlemen, I think of Danielle's opening remarks about the importance of evidence, the importance of factual evidence. Is Steve Malloy in the room? Steve Malloy is my colleague on the board of the Heartland Institute. I don't see Steve here. Steve, as you know, has been a champion. He's speaking on the other panel right now. Well, the nerve of that guy. Steve has been a champion opponent of junk science. And what has evolved under Rule 702 of the Federal Rules of Evidence that Danielle described is a fairly increasingly rigorous process of weeding out junk science from federal litigation. And I look at this room full of people who are genuine experts. I think any number of you I could put on a stand and qualify you by virtue of your experience and your methodology as legitimate experts to be able to present evidence to a court. Several times during the day, I've heard other speakers refer to you as an incredible group of people. I want to apologize for that insult. There's nothing incredible about you at all. What I have found in this room, in 16 iterations of the Heartland Institute's International Conference on Climate Change, is nothing but credible people. And I thank you for your faith in the Constitution of the United States, and I thank you for your courage to speak the truth to power. God bless you all. Danielle, you're in charge.
Q&A.
Well, does anybody have any questions for this? I have the mic. Okay. Perfect. Does anybody have questions for this supreme group of individuals? Go ahead, Christine.
Oh, you hold it. Great. Yes, Carrie Brown. Either Heartland or perhaps the Federalist Society this last week or two put out something about the packet that the judges can look to for an overview of climate is highly subjective and needs to be modified. Can someone fill me in on that one?
Jeff,
Oh, yeah. Can you guys hear me from here?
Yes.
Yeah. So
I think he's talking about the administrative office thing,
the Federal Judicial Center.
The handbook.
Yeah. So my new organization, the Oversight Project, we are at work on that. And I've been corresponding with one of the audience members, Chuck, about that. So the focus of my organization has been on removing, targeting one of those chapters in particular, and that's apparently been taken down from the Federal Judicial Center's website. Maybe I should take a step back and explain for other people what it is we're talking about. We're talking about the left tries to co-opt the science whenever they can. And so, as you heard from Danielle, there is Daubert review, there is Federal Rule of Evidence, 702, and there is, this test of making sure that things are truly scientific. But judges oftentimes, right, they're generalists. As I used to say when I was in law school, there are too many English majors around here. And they don't really have any particular expertise, and they don't want to acquire any real expertise oftentimes. A real trial lawyer goes on to actually be able to try to at least achieve basic level mastery of some important discipline that's involved in cases that they do. But there are lots of lazy-brained people, and sometimes they float into the Article III courts, and so they get a climate change that comes across their case that comes across their desk, and they're like, boy, this is a political hot potato, and I don't want to have to learn this stuff. You see the equations from Will Happer. Quick diversion on Will Happer. I remember when I was the Assistant Attorney General of the Environment Division, I went over to meet with Will Happer, who was a White House advisor in Trump 45 on climate issues, and he told me about how he'd solved one of the main problems for Star Wars, for missile defense, like using his physics intellect. And I was like, there is nobody like that on the left. We get a lot of people who get master's degrees and they treat them like experts. Anyway, back to my main subject. So the thing is, you have a lot of lazy judges and they're looking for shortcuts. The left knows this. So what do? They get some climate scientists who agree with them, support the consensus, and then they've written up this kind of manual of, oh, here's a handy-dandy, complex-looking cheat sheet on climate change. So if you get a climate case, just go look at our handbook. And of course, it's entirely biased and would entirely skew things, but that would let the judges turn their brain off. Now, we think that this is, and I think the people who are critics of it think this is a totally ridiculous exercise. The only thing that a judge should be considering is the evidence presented in the adversary process in front of them, not some kind of external document that lets them turn their brain off. So anyway, we're trying to get that totally blown out in terms of the Federal Judicial Center that put their imprimatur on this. And then also the National Academy of Sciences has done the same. And one of the chapters we've been targeting, so they play games. Like they took one thing down from the Federal Judicial Center, but it's still up on the National Academy's website. So we're going to keep dogging that. I hope that the Trump administration takes steps against this as well. The problem is the judiciary is doing this, so it creates a separation of powers issue for the executive branch to try to do something about it. And then the National Academy, it's kind of quasi-governmental, but it's not exactly governmental. That creates difficulties. I had to wrestle with a lot of those questions. So anyway, this manual is a bunch of crap, and we need to bring it down, but it's not as easy as you might think.
I don't have a question as much as I do a comment. I'm Ramey Johnson. I'm Walt Johnson's wife, and he did the documentary A Climate Change, or A Climate Conversation. I sat on city council for 10 years, and I wanted to have a study session that would come to city council and give both sides of the climate narrative. The people that are pushing this silliness are vicious bullies. And for 2 hours, every 3 minutes, I was literally crucified. We were always afraid that they were going to come and protest in front of our home. And with my husband so involved in gas and oil, it was a real concern. They are vicious.
Hearing two sides? My goodness, who does that?
Yeah.
I saw Francis.
It's evil.
Hold on a second.
Yes, Jeff Clark
I know you were at OIRA, and of course the rescission of the endangerment finding came down. Nothing in that discusses the science other than to say we're not going to discuss the science of this or take a position on it. And I'm wondering what you can tell us about how it came to be done that way and whether you think that's a good way to have done it.
Let me put it this way. I'm still defending a series of 4 privileges from the Trump 45 administration in litigation that's now entered its 6th calendar year. Executive privilege, law enforcement privilege, deliberative process privilege, and attorney-client privilege. I cannot exactly say. The only thing I would be willing to say is, based on the history as you heard it from me, you could imagine what internal positions I might have taken. That's all I can say.
The question here for Jeff. What he didn't say was he brilliantly won the Massachusetts versus EPA case by citing a National Academy of Sciences report. And why that was so persuasive was just why he said most judges have no idea of science. They're English majors, history majors, and hated the science courses they had to take. The problem is the alarmists have brilliantly created 3 documents. They've created a National Sciences report with bogus science on climate change in September of last year. Then they created 2 new chapters in the reference manual for scientific evidence that is sent to not only 3,000 federal judges, but more than 3,000 state judges. And judges are, just for the reasons that Jeff won, likely to cite these very authoritative documents, these 3 documents. One of the reference manual chapters is the one that has been removed from the Federal Judicial Center's version, is about climate science. That's another junk science report on that. The second chapter is about how science works. And what they did there is they say, science isn't determined by scientific method. Guess what it's determined by? Consensus. And so you got 6,000 judges, you got not only the endangerment finding case, but you've got these 36 cases like this case in Colorado are asking for trillions of dollars, and judges are going to those 3 documents. They'll look at that and plaintiffs will use it. My question is twofold. First, is there any chance in any of the regulations that the Trump administration hasn't issued yet to use this, the 7-county case, that is, have the agency analyze and refute the science in each of those 3 cases? And under the Supreme Court's 7-county case, you get great deference to scientific findings by an agency. And that's one question. And the second question, any way else to attack those 3 reports?
So, all right, I'll try to field that like this. The first point is I would try to use the Data Quality Act to attack this stuff. The problem that we've encountered is that the courts are not very interested in enforcing the Data Quality Act, because in order to decide whether something is truly quality scientific information, you actually have to get yourself into the subject and look at the scientific literature and figure the issue out, which has the same problem I pointed out earlier. So the judges look for shortcuts. The worst decision on this is one that Judge Ludig, who was thought to be quite a conservative maven until he got hit with a mega dose of Trump derangement syndrome. Now he appears on MS Now and all these other channels attacking.
Having left the bench.
I'm sorry?
Having left the bench.
Having left the bench, yes. Having left the bench with the intermediate stop of cashing in as the general counsel of Boeing, which of course produces planes that are entirely free of defects at all times. Which is a scientific issue as well. But in any event, Ludig produced this opinion that said basically, it's called SALT Institute in the Fourth Circuit when he was on the bench, that said that the Data Quality Act couldn't be enforced. So the DC Circuit, and you guys have probably heard of Jim Tosey, right? Jim's been pushing that you need to get, people need to push the Data Quality Act. And, you know, if you know, we're going to have we get a lot of things to do with the oversight project, but I'll think about an initiative on that front because that's important for that. And I'm sorry, what was the other part of your question? Oh, 7-county. So for everyone to understand, what is the 7-county case? So the 7-county case is a case about the NEPA statute. And what is the NEPA statute? The NEPA statute is the National Environmental Policy Act. That was passed in 70. You know, it was one of Nixon's things he really accomplished. But what it really does is it imposes a lot of red tape on any form of big project development in the United States and also on new rulemaking. And if something is so-called major federal action, which doesn't actually take a lot of federal action, it can take like a little smidgen of federal action that goes into your project, like some kind of permit approval, then you have to do a big NEPA analysis. Like these things often go multi-volumes, you know, like they sit on shelves and no one reads them, but supposedly they're very important to the environmental community. And so all they do is they look through the volumes and they find some issue that was not looked at very hard. And they say, oh, you know, you didn't comply with NEPA. They get an injunction from a judge and they shut down the project, okay? So President Trump had a big NEPA reform effort in Trump 45, which I was very involved in, and I got it through two unsuccessful preliminary injunction challenges. And then in this administration, we've also done a lot of NEPA reform, but the Supreme Court, you know, gave us a huge favor. They issued this 7 counties decision, and they said, you know, you refer to one of the reasoning components of it, but the overall effect of it was that basically when the agencies are doing NEPA analysis, they're going to get a healthy form of deference from the courts. The courts shouldn't be fly-specking these NEPA documents. You know, if there's someone from the National Highway Traffic Safety Administration who says, you know, this is not going to cause a lot of highway death, or this is not going to cause a lot of trees to die, you should take that, you know, as something that, you know, you shouldn't have every judge. And they go to their favorite forums, right? They go to San Francisco, they go to New York City, they come to DC to shut down projects. So, you know, the first challenges to the Trump 47 NEPA reform are kind of working their way through courts, San Francisco again. So, you know, then it'll go to the Ninth Circuit, then it might go back to the Supreme Court. But the 7-county decision was a big form of deregulation that the Supreme Court gave us a gift on. You know, we've built on it, but the 7-county decision gave us a giant platform, Chuck. There's like a hyper form of deference for things at the frontiers of science, especially, which the DC Circuit's very fond of, that this kind of ties to. You know, like
may I speak to that just for a second? I realize we've got some more questions to get to, but this ties to in a way, conceptually, to the Chevron problem. Chevron oil, that case decided by the United States Supreme Court, 40 years ago by John Paul Stevens on the court then. Small world department. I joined that law firm as John Paul Stevens left it, and I got his office and his furniture. So I spent the first several years before I went to work for President Reagan. I lived at John Paul Stevens' desk, his lawyer desk. I knew Stevens well. In that case, Chevron oil was in litigation with the Natural Resources Defense Council, and in that case, it was the mirror image of the world that we see most of the time. The agency, the Environmental Protection Agency, had decided something kind of in favor of Chevron. Their interpretation of the statute that they were acting under, not scientific evidence, but their actual interpretation of what Congress must have meant with the statute, favored Exxon and rather Chevron. And by the time the case got to the Supreme Court of the United States, the Supreme Court looked at it this way: whatever it was Congress said, we don't understand. I mean, it was an ambiguous statute. But what the agency said in this instance kind of made sense. And the agency said it understood the statute and it was applying its best reading of the statute. It made sense to us. It was as good as anything else. And it favored Chevron, so the Supreme Court came down in favor of Chevron and against the Natural Resources Defense Council. Yay? Well, all right, to a point. But over the next 40 years, what came out of that was deference to agency interpretations of statutes. And it got worse and worse and worse as agency, it gave Congress an incentive deliberately to pass ambiguous statutes, because then the agencies got to interpret them, right? Because that's the Supreme Court threshold. If the statute's unambiguous, judges know what to do with it. But if the statute's ambiguous, we'll defer. So we get to defer to the agency responsible for enforcement of the statute. So we get in this habit of deferring to agencies, and it took 4 decades to reverse that finally with the decision we were talking about this morning. That's part of the intellectual laziness and the constitutional laziness that afflicts this town. The Supreme Court will do its part from time to time to correct that problem. Presidents like President Reagan, President Trump will do their part from time to time to correct that problem. But the only way to correct that problem, root and branch, is go back to the statutes that impose these environmental impact requirements like NEPA, and rewrite those. That's the only way to rein the problem in. I think you would agree.
I agree.
I apologize for holding you up. You have a question?
All right. My name is John Zacharias. I'm from the Canadians for Sensible Climate Policy. You can tell by my accent that I was born in Minneapolis, USA, 81 years ago. Well, actually 85. I emigrated when I was 4. But we have a problem in Canada, and we need America's help. We have Mark Carney and a lady called Catherine McKenna, who was the head of the environment, and both were very influential in the United Nations. My question is, can somebody explain the legal status of the social cost of carbon? Because the Carney government has adopted the Biden version of $198, which converted into Canadian dollars, justifies the $16.5 billion that they plan to spend of public money on capturing carbon and shoving it underground in Alberta. The second question, if you don't mind my asking too, is addressed to the gentleman from IKE, Mr. Tuss. There is talk in our newspapers of the EU and Canada becoming partners to introduce CBAM, which is a carbon border adjustment mechanism. And that is a device to counterbalance some of the tariffs. I believe that in Europe, you're very keen to introduce that. What's the status at the moment? Thank you.
Second one first.
Okay. Actually, I've never heard of this. I'm really following all these topics a lot, but I've never heard of this. This might be due to the fact that there are many such programs and many ideas circulating, but I would think this is like a typical, media hoax. I'm sorry. It's a little bit like carbon capture and storage. Every now and then this debate is coming up, and then it's buried somewhere, and then it's coming up again. This is how it sounds to me, but sorry, I've never heard of this.
Before Jeff Clark gets to your first point, let me say something about this. The EU is perhaps the global example par excellence of the way in which to hide responsibility for decision-making behind bureaucrats, right? If I describe this process in which it happens in this country, where Congress delegates power to administrative agencies to make decisions. What is Brussels, if not several times removed from the democratic process? Behind parliaments, behind prime ministers, there's that whole wall of bureaucracy that then becomes the excuse going back to the home country, each of the member countries saying, well, we have to do this because Brussels says we have to do this, right? If President Trump were on stage, by the way, sir, he would answer, what help could Canada get from the United States? Adopt this. Come on in.
So if I can mention just a little bit there, John, and by the way, John does tremendous work in Canada. I mean, he is one of the ringleaders for sound science and common sense. It's an honor to work with you and to know you. Donald Trump, among the many things that he has been courageous to do that no other president has done or likely would do, was eliminate the idiotic social cost of carbon calculation that would go into basically under Obama, Biden. You use that to shut down everything because you say, oh, the social cost is so high, you can't pass this test. Initially, he had lowered that, I think, in the first term to like about 10% of what it was. But let's face it, the social cost of carbon is negative. Carbon dioxide, more CO2 restoration is going to, and is right now as we speak, benefiting plant life throughout the planet. All ecosystems depend on that. The more that plants flourish, the better all ecosystems are. We know that human health benefits from warmer temperatures. We see it in the mortality data. Far more people die in the winter than in the summer. We see it in the peer-reviewed studies that show up to 20 times more people die from cold than heat. And the amazing thing is, with just about any other president, any other Republican president in the White House, they probably would have had a mealy-mouthed, modest reduction in the so-called social cost of carbon. But thankfully, that is out the door, Jack.
So just to put a little more fine point on that, so President Trump issued an executive order about American energy in January, on January 20th of 2025, first day in office. And it said that we were disbanding the interagency working group on looking at the social cost of carbon. They're the ones who did the estimates, and then it would feed into what the individual agencies did. Trump just killed that off. And then he said, I want the EPA administrator to look at getting rid of the social cost of carbon. So, you've given me a great opportunity. I can pull the bell. Actually, the president redelegated that to me. And so about a year ago, I issued a memo killing the social cost of carbon. You can Google that, Jeffrey Bossert Clark, social cost of carbon. And so, we killed that off. It's dead. And as far as I know, there was never any litigation about it because there's no statutory or regulatory basis for it. They just made it up. And they just threw some agencies together to do it, and they just started doing it. So anyway, crazy stuff that happens. Here's my last point for you about Canada. I tried to do something for Canada in Trump 45. I sued California because California has the functional equivalent of treaties with Ontario. And they had another province they were trying to include to do emissions trading. And I argued that that is preempted as a matter of the president's foreign policy powers, and because he didn't want this stuff happening. And number two, by his withdrawal from the Paris Climate Accord. I brought it in the best possible jurisdiction in California, a federal court in the Eastern District of California, like near Sacramento, which has more conservative farmers and some others around it. But the judge ruled against us. We'd taken an appeal, and the appeal was still pending in the Ninth Circuit when Biden came in. One of his first acts was he yanked that appeal. So in Trump 47, I went to it's the acting assistant attorney general, a guy named Adam Gustafson. Please call him up, ask for a meeting to try to resurrect that litigation. I asked him to resurrect it, but as of now, it has not been resurrected in Trump 47. And California, since then, California's been emboldened. Last time I looked right before I left, there were about like 30 different agreements they had with multiple countries and with Canadian provinces. And to my mind, they're all entirely unlawful.
This will be the last question, and then you guys are all going to have to scoot out of here.
Yes, for Jeff. This will be quick. About the endangerment findings. So I remember back, we had 7 criteria pollutants, and I think those were specifically outlined by Congress, right? So how do we what did the Obama administration, what legislation did they cite to create this 8th pollutant?
Okay, so indulge me a little bit. So there are 2 main titles. There are other titles, but there are 2 main titles of the Clean Air Act, Title I and Title II. Title I is stationary sources, Title II is mobile sources, and they're also intertwined with each other. So under Title I, the National Ambient Air Quality Standards Program was created, and that created these criteria pollutants. Carbon dioxide and no other greenhouse gas is on that list. Now, the environmentalists have talked about trying to get it on that, treated that way, but it has not happened. And part of the reason why it doesn't make any sense is because all those pollutants have localized concentrations, right? They're like kind of localized poisons, essentially, that sit over a city or a region. But greenhouse gases evenly mix over the global atmosphere. So the whole program doesn't make any sense. And I think the environmentalists have kind of receded from trying to get that in. The way that they got climate in using, and I mentioned Professor Lisa Heinzerling, was to start with Title II. So here's her brilliant analysis, and we're not out of the woods on it yet. Number one, issue an endangerment finding under Clean Air Act Section 202, which is the mobile source program, which says it's a pollutant for purposes of what comes out of cars. And the Supreme Court upheld in Massachusetts versus EPA, it was such a pollutant. Number two, if there's an endangerment finding, there's a mandatory duty to issue car standards controlling greenhouse gases. And they said it was a mix of 6 greenhouse gases that kind of all are an amalgam, and we're going to regulate them as amalgam. Third, under Title I, this is about interconnections of the statute, once you have regulation under Title II and something is a pollutant, then it's a pollutant for purposes of Title I too. So then they said, now we get to require power plants to have permits under the PSD program, the Prevention of Significant Deterioration, to regulate carbon, et cetera, carbon dioxide under the stationary source side. And then they said, but this is going to regulate at ridiculous levels. So we'll ease off and we're going to increase the threshold at which we regulate, but this is deregulatory. And this is their scheme. And they would have succeeded in it, had we not brought a lot of litigation and Justice Scalia had not written the UARG opinion that basically scaled back a lot of their ability to take the mobile source stuff and move it to the stationary source stuff. But the whole head of the snake, and this is why we keep talking about the endangerment finding, is the Title II endangerment finding. That's now been repealed. If that head of the snake is cut off, its ability to metastasize through the whole statute should be dead.
Okay, everybody, you can thank these wonderful gentlemen. You're all lawyers.
Thank you too, Danielle.
And now if you can collect your items and proceed out there, we're going to set up for dinner.
TV Republika. From a journalist's point of view, climate policy is as interesting as what climate
There we go. Ladies and gentlemen, please welcome to the stage the president of our co-host CFACT, Craig Rucker.
All right, as was said, my name is Craig Rucker, president of CFACT. Are we having fun? Yeah, all right. All right. We are proud to host, co-host of this illustrious ICCC, and I guess I'm supposed to give some remarks right now. And I asked Jim Lakely, I go, okay, as a co-host, I guess I'd make some remarks. Is there any guidelines as to what I should be talking about? He said, no, just speak what's on the heart. My knee-jerk thought was, okay, well, that's a dangerous thing to tell somebody from CFACT, but so I'll discuss the Buffalo Bills and why they have not got a receiver to help Josh Allen win the Super Bowl. Now, a little more on point. I'll try to keep it on topic, and honestly, what came to mind was just to simplify and talk about my thoughts running CFACT, which is Climate Realist Group, as to where we are right now in the whole climate debate and where we were and what I think the future will be, kind of. Having been to all these ICCCs, you know, we've seen some good times and bad times, or if you're to quote Dickens, it was the best of times, it was the worst of times, right? Or it was the worst of times, it was the best of times. Right now, they're pretty darn good. As I mentioned when I introduced Lee Zeldin earlier today, rarely, in fact, I can't think of any time, that things have been going more our way in the climate realist movement. You know, people say, stop and smell the roses. Stop and smell the roses. Look where we are. The U.S. has exited Paris. Yes, we did it back in 2016, and Biden got us back in, and now we're back out. But even better, we're out of the original UN Convention on Climate Change. And why is this good? This is good because now if there's a President Gavin Newsom down the road, they'll have to submit it for 2/3 majority. This is insulating that withdrawal. This is amazing news. But it's not even like the Trump administration just took a few of our things. It's basically like he took the whole agenda of everybody in this room, the CO2 Coalition, CEI, CFACT, and he implemented it beyond our wildest dreams. U.S. is not just out of the Convention on Climate Change, we're out of the IPCC and 66 other UN entities. UNESCO, Habitat, UN Population Fund, the list goes on and on. Wow, that's amazing. The size of the EPA reduced from 16,000 employees down to about 12,500. You know, people are policy. That's a pretty big cut, and you don't see that very often. The release of the Climate Working Group reporting climate science. I never thought I'd see something out of the government. Now, granted, this didn't wind up being fully published, and there were some, I guess, misfilings. But just the fact that there was an administration that would convene and try and put out the type of science we have in this room and have a government stamp of approval on it was a remarkable thing. WOTUS is reformed, the California waiver's gone, the EV mandate ended, offshore wind permits have been revoked, and green groups have been defunded. The Net Zero Banking Alliance, which is pushing all this ESG stuff, it's dissolved. You're talking BlackRock, all these groups got out of it. In fact, the UN failed to pass a phase out of fossil fuels in Brazil, and all this while America's achieved energy dominance. We now produce more petroleum than we actually consume every year. This is amazing. So this is a time to stop and smell the roses. You know how we're doing good is just listening to the enemies, right? You hear what they say, you know you're doing good. You got former Obama-Biden EPA administrator Gina McCarthy, and what's she saying? This is the most disastrous time in EPA history, right? Jason Rylander from the Center for Biological Diversity. I thought he put it really well. He said, "This is crazy. This is insane, what's going on right now." And then, of course, you have a spokesman for the NRDC saying, "This isn't just a giant step backward, what's going on now. It's a wrecking ball aimed at decades of progress." Brings to mind one of my favorite movies from the past. I don't know if you remember Schwarzenegger, Conan the Barbarian. They asked him, "What is good in life?" He said, "To crush your enemies, see them flee before you, and hear the lamentations of their women." That's what's going on right now. We are thoroughly crushing the other side. But though we're succeeding, I'm reminded of what the late David Rothbard, he was the guy who started CFAC with me, used to say. He used to say to me, you know, things are never quite as bad as they seem, but they're also never quite as good as they seem either. They're never as bad as they seem, but they're never quite as good as they seem either. Obviously, he was never a Buffalo Bills fan because it's always as bad as it seems, maybe even worse. But no, but what he said is true. Many of us in this room remember when the bird, you know, when we had the original Paris Accord was called the Kyoto Protocol. And we got the Byrd-Hagel resolution out there, and George W. Bush came to power, and we killed the Kyoto Protocol. We were celebrating. Little did we know that within 6 or so years, George W. Bush would be the first president to step on the podium at the State of the Union and start talking about how awful climate change was and we needs to be saved from it, right? We remember the collapse of the Copenhagen Accord that was after Kyoto expired. There was a Copenhagen Accord. It collapsed because of ClimateGate, and Obama wasn't able to do anything with it, and we were cheering. Yeah, but just a few years later, we had the endangerment finding upheld by courts, and of course, we also had the Paris Accord. Then, of course, Trump got us out of the Paris Accord. We're celebrating. Then Biden gets us back in, and Trump gets us back out. It's always been kind of a wavy thing. It's never as good as it seems, never quite as bad as it seems. So I want to kind of level this out at a time when we are celebrating here, just to bear a few things in mind. While we have gotten out of the climate treaty, and a lot of these changes have occurred, a good many of them may not survive once we get a different administration. As I say, perhaps a President Gavin Newsom or somebody like that. Some of our success, defunding the green groups, dismissal of the EPA staffing, the rollback of rules like the California waiver and the EV mandate, the WOTUS reforms, another administration could come in and possibly turn things the other direction there. Most importantly, our enemies are very well funded. If you just look at the top 10 green groups that are out there, you know, the Environmental Defense Funds, the Greenpeaces, the NRDCs, they have a combined budget of $4.7 billion. Absolutely amazing. If you took the top 10 conservative groups, you would include in this the Heritage Foundation, you're talking under $200 million. And if you take the groups in this room which are really leading the charge, you're under $25 million versus $4.7 billion. Used to say in the Army when I was in there that an army travels on its belly. Well, they got a lot of food and supply trains feeding that other side. And of course, while Trump has shut off the spigot for renewables, offshore wind, blue states right now are moving forward. Even worse, some red states are moving forward with Green New Deal type programs. I just came from a protest in Oklahoma, and we had everybody there in the state capitol protesting, but the governor of that state, good man, all of the above strategy is pressing forward with massive subsidies going to wind, solar, and all these things that our adversaries are opposing. And of course, the courts have become a battleground for climate lawfare. 17 green groups are filing over the EF, 23 states on tailpipe emissions and the endangerment finding. One group alone, the Center for Biological Diversity, has filed some staggering 83 lawsuits to overturn Trump administration rules. Will all these succeed? Good question. And on top of that, the UN is down but not out. I said before they weren't able to phase out fossil fuels by 2050, but I was down in Belém, Brazil during the last COP meeting, They did pass one thing, little known fact. They totally failed, but one thing they agreed on. They agreed that everyone in this room needs to be silenced. They actually passed a resolution saying that the reason they aren't able to achieve what they're achieving, essentially this was by Lula, the president of Brazil, is because of these skeptics out there passing disinformation on social media. So you guys are to blame. Now to stop you, they've committed $100 million to be advanced to try and talk to the big tech companies to start squelching your algorithms and everything else so that you can't give in misinformation over the internet. It's a small thing, but it's kind of important. It's a testimony to how we, have been impactful. But my broad point is, things are never quite as good as they seem, or as bad as they seem, but they're also not quite as good as they seem. So anyway, I know as a Bills fan, the game isn't over till it's over. So we should not be over-celebrating right now, but I don't want to say we shouldn't be celebrating at all. Yes, drink it in, enjoy yourself. We are certainly entitled to that right now. And hopefully we will win. I do believe we will win. Somebody always asks me, say, Craig, when have we actually won this battle? This is my answer. I don't know if it's your answer. I say when people look at climate change alarmism and that we're all going to die from global warming and they kind of snicker and say, yeah, I remember the Y2K. I remember the Mayan calendar. And I never fell for that. That was just too much for me. Of course, they did fall for it. But, nevertheless, when they are thinking of this climate alarmism, doom and gloom and destruction and all this, is just kind of like a joke like those things are. So the good news is, although the war is far from over, we can all keep our jobs, in the most part. We are making progress, real progress, and everyone in this room, I think, can share credit. I want to thank all of you for the good work you do. Keep pressing on. Let's continue to get the good word out and keep the faith. Thank you.
Nice job, Craig Rucker. My name is Jim Lakely. I am Executive Vice President of the Heartland Institute. I'm also host of the Climate Realism Show, which is done by the Heartland Institute. Yeah, let's hear it. It airs live every Friday at 1 p.m. Eastern, streaming. We're actually, we're up to episode 197. But it is not going to be streaming on Friday as usual because we'll be streaming it here on Thursday instead at the same time. So we're going to enjoy doing a live stream in front of a live audience for the first time, so that should be a lot of fun. And I mention it just because I have met people here who might only be here because they enjoyed the show, come from a long way. It's extremely humbling. We do it because it's fun. We do it because it's informative. But mostly because it's fun, and we're so grateful there's a lot of people in here are fans of the show. So if you have not yet experienced it live, perhaps a Jim rant is coming, but you'll be able to see that for yourself here tomorrow. But I also come up to announce just a slight change to the program. You may have heard James Taylor, if you were here for one of our panels, mention Tomasz Sakowicz, who is, as James described, kind of the Rupert Murdoch of Poland. He was hoping to be able to attend and to address the audience today. He was not able to do that, but he did record a brief video that he would like us to play for him here, so we are going to do that here momentarily. And also an attendee who's a friend was very impressed with a video, about 4 minutes, by Pierre Poliver. I hope I am saying that correctly. Now, he's not addressing this conference. I probably set that up too much. But we wanted to play it, our friend asked us to play it, because one of the themes that we've talked about here at this conference is how, the theme of this conference is climate realism rising. And I think that's true here in the United States. I think if you look around the world, it's also true everywhere else. We're actually going to get into that a lot more on the Climate Realism Show tomorrow. So you can sit back, relax. There's going to be a few minutes of video, and I hope you enjoy it.
Good morning, I'm Tomasz Sakiewicz, CEO of TV Republika. From a journalist's point of view, climate policy is as interesting as what climate experts, archaeologists, or environmental specialists experience. It can give the impression that real scientific results are used mainly to support a larger narrative. At the same time, this narrative may pressure scientists not only in choosing what to study, but also in what conclusions they are expected to reach. Since the Enlightenment, it has often been believed that science becomes free from outside limits and depends only on its own rules, even if that was true. And this can be debated in the case of the Green Deal. Ideological ideas seem more important than scientific results. This is noticed not only by scientists, but also by managers and politicians. Ideology grows through strong beliefs and emotions, and using the media to spread it has been very important. The European Union gives millions of euros to media and opinion-forming organizations. But money is only the beginning. Many projects that have nothing to do with environmental protection still include parts that agree with EU climate policy. An interesting example is a large satellite system that provides TV signals. Its management requires broadcasters to declare that their activities will not go against climate policy. Of course, it is hard to affect global warming from space. So the real issue is whether content that questions climate policy will be shown. This shows the influence of EU policy on satellite providers. This example shows how easily even large broadcasters can be pushed to accept rules they may not fully agree with. They can say what they want, but it does not mean people will hear it. To avoid risk, many choose to follow these rules. The Green Deal is also included in bank loans, government funding, and other financial systems. It has strong financial support, which is very important for media companies. At the same time, competitors who do not follow it face serious problems. Many companies do not want to advertise in media that do not support the Green Deal. As a result, media that support this policy have an advantage in the market. More climate messaging then affects politics and also enhance the financial and legal system that support it. In this situation, scientific results and economic effects become less important. What matters more is the power of the narrative, which can defeat anyone who disagrees with. Journalists cannot freely criticize because broadcasters are afraid of losing money. Politicians and businesses in turn are afraid of broadcasters and create laws and funding systems that support the same policy. At the point, carbon dioxide emissions themselves seem less important. What matters more is the emission of approved messages that start to feel like a kind of belief and are treated as something that cannot be questioned.
When to even the most basic of laymen, it seems like we're heading on a path of self-destruction.
If you look at it, what it really comes down to is this. It's freedom or force. There's a movement to concentrate power, control, money in the hands of bureaucrats, technocrats, and other insiders using the state as their mechanism. And that has led to the mass impoverishment of the people across the Western world and an enormous gap between rich and poor. By the way, this is not happening because of free enterprise. It's happening because of the massive interventions of the state to take from the hardworking many and concentrate it in the hands of the few. On the other hand, there's another alternative, which is to give people back more economic, personal, and political freedom through a smaller state and more powerful individuals, families, and communities. And that's the side I'm on.
Well, you're focusing on the narrow economic part of it, but I think what Francis is alluding to is there's
the same thing, though.
Well, is it though? Because there's a cultural and ideological dimension to this as well. Because, say, the policy of net zero, which is just economic suicide. It's the same thing. Tell us.
Exactly the same thing,
How
because
so?
it's being used as a pretext to concentrate money and power in the hands of the state. It is just the latest of the many pretexts that are used to justify taking away everybody's money and giving it to a treasured, privileged few, green grifters. The corporatism of saying, well, we're going to tax all of the energy and we're going to block the resources, and then we're going to take the money and give it to the government, who's going to dole it out to all of these corporate insiders who claim that they are doing something for the environment. When in fact, if you look very carefully, it's all BS. In fact, they have no problem directing much of that money to China, which is opening 2 coal fire plants a week. So it has nothing to do with the environment. It is entirely a pretext to take from the working classes and give to a small group of insiders through the mechanism of the state. So whether you're talking about the net zero fraud or massive government redistribution schemes or just an overall growth in the bureaucracy, it is all, or even on the speech side, it's all about concentrating power and money in the hands of fewer and fewer people while taking away the opportunities of the people who actually do the work.
Because I was going to say, when I was researching for this interview, I was looking at the immigration rates in Canada. It's staggering, just as it is in the UK, just as it is in Germany and other countries.
Same phenomenon, though, the same phenomenon, because here again, what happened? A corporate elite was able to drive down wages and drive up rent. Why? They brought in low-wage temporary foreign workers, and they brought in enormous numbers of so-called students. Many of them weren't actually studying, but they ultimately provided a source of low-wage labor and created a major demand for a fixed supply of housing. So the rent went up and the wages went down. And those multinationals that benefited from it, they concentrated even more wealth, while the working classes ultimately got shot out of jobs and homes. So again, it's the same.
Ladies and gentlemen, please welcome to the stage the chairman of the board of directors of the Heartland Institute, Joseph Morris.
Thank you, Jim. Thank you, ladies and gentlemen. A little earlier, from this very place, Craig Rucker, the erudite Craig Rucker, quoted the opening lines of Charles Dickens's novel, A Tale of Two Cities. I'll wait till that debate's over. A Tale of Two Cities, the best of times, the worst of times. I can only think of one toast that occurs in the text of Dickens, and that occurs in A Christmas Carol. The subject of the toast, and the analogy will end here, is Ebenezer Scrooge, but it's the reformed Ebenezer Scrooge. It is a toast to the founder of the feast. Here we are at the 16th International Conference on Climate Change. And there is one among us who deserves some special attention tonight. Thanksgiving, having weathered so much of the worst of times and having helped see us all through to what may be the best of times, though I'm sure his hope and our hope is that the best of times, in fact, remain ahead of us. And that person, of course, is the former president, the founding president of the Heartland Institute, a fellow who's been my friend for roughly 4 decades. And you know him very well, of course, most prominently as the husband of Diane Bast. Without Diane, there would be no conference, there would be no Heartland Institute, not merely because she let Joe go out and play when my predecessor, Dave Padden, founded the Heartland Institute, the first chairman. Dave was the first chairman of the Heartland Institute, and another dear friend of mine who's sadly left this vale. But Diane let Joe come out and organize the Heartland Institute and see it through so many years, including the the focus of attention on liberty and science, which brings us to this moment, doesn't it? Because that's what it's about. And not only did Diane let Joe do that, she became his strong partner throughout that work. So in honoring the founder of the feast, I share no secrets when I tell you also honor the foundress of the feast. But we would not be here, we would not be as brave, we would not be as bold, we would not have so much accomplishment, intellectual accomplishment, debating accomplishment, the bringing of us together, but for Joe Bast. And therefore, it's my privilege to ask you to raise your glasses with me and a toast to the founder of the feast. Here's to Joe Bast. Joe, come here, please. To Joe Bast. As Joe makes his way to the podium here, let me tell you, I am presenting to him this box. Contained within it is a lovely crystal monolith that identifies him as a climate pioneer. That's just the beginning of the story. Joe Bast, climate pioneer. Joe Bast, hero of freedom. Joe Bast, advocate of the scientific method. Joe Bast, dear friend of everybody in this room. Joe? Apparently we want a picture of the monolith, so it will now have my fingerprints on it. Yeah.
Try not to drop it.
All right, Joe, I'm presenting this to you. It's now official because we have a picture.
There we go.
Thank you. Ladies and gentlemen, Joe Bast and monolith.
Well, thank you, Joe Morris, for all of that. Joe Morris, in case you don't know, is famous for his lavishing praise on other people. So he will go on and on and on. Last time he did this a few years ago was about 10 minutes or 15 minutes. And it's hard to be modest after something like that. I thought the cherries would be in bloom in Washington, D.C., so I wore my Easter jacket to this event. But it helps me stand out in the crowd, I guess, so it's not all lost. I thank the Heartland Institute, CFAC, the CO2 Coalition, and What's Up With That for this award. This is special. I really do appreciate this. I think you all have a right to wonder why a guy as young as I am would get the Pioneer Award. I started the Heartland Institute with Dave Padden, as Joe Morris mentioned, in 1984. I was 26 years old, and so at the time I was always the youngest guy in the room with all the meetings of other think tank leaders. And it was very exciting, and we did a lot of things. Around 1990, one of our donors, 1990, actually it would have been 2000, maybe 2006. One of our donors, Barry Seid was his name. Barry Seid, he's a wonderful philanthropist in Chicago. So he sat me down and he said, Joe, I'm willing to give you more money if you can identify an issue that you think is really important and that other think tanks aren't paying any attention to and that you could actually make a difference on. And I said, climate change. Climate change is the issue. The Cato Institute, I knew Ed Crane, I knew all these guys. And Ed Crane said, we're not scientists, we're economists and lawyers and philosophers, so we're not going to get into the climate change debate. Heritage Foundation gave essentially the same reason. AEI had donors who I think were opposed to us making a lot of noise about climate change. So none of the other think tanks were particularly active in the issue, and we decided to get involved. One thing that the Heartland Institute always did was act as a forum for other organizations and for individuals. And we would try to bring together all the think tanks,
all the conservative and libertarian organizations in the country to get them to cooperate more, to coordinate their efforts, to raise money from each other's donors, if that was possible, to show up at their events and so forth. And so this global warming conference was Barry Seid's idea. It fit right with what the Heartland Institute was usually doing. Barry said, you got to create a social movement. He says, right now you got all these scientists, these skeptics who are scattered all around the world. They don't know each other. They don't communicate regularly. They don't have a place where they all come together. So in 2008, we did that first International Climate Change Conference in New York City. How many of you attended that conference? Can you hold your hand? Look at that. Isn't that crazy? And now this is the 16th conference, which is sort of amazing. But Barry was absolutely right. It created a social movement. It brought all these people together, many for the first time. I mean, countless people, at the end of the conference are hugging and crying and saying, I've read all your stuff for all these years and I've never met you. I'm so, so great to finally meet the guy who wrote this stuff. And so it was a tremendous success. I think it built the climate realism movement. And I'm thrilled that the Heartland Institute and its allied organizations are able to continue to hold these events. I want to recognize just 3 people before I sit down. One is Fred Singer. Many of you knew Fred. There's a table out there with some of his awards and some of the books that he wrote. I had the privilege of editing and co-authoring several things with Fred Singer. Worked with him on the new edition of his last book, which was published posthumously. And he was just so gracious and so intelligent and so committed to the issues all the way through that he was just a light, just an amazing beacon in this whole free market movement. And I think we all miss him. The second person is Christopher Monckton. Lord Monckton, he's not here today. He's still alive. He's still alive, don't get me wrong. But if Chris were here, he would be pointing out that the other side has never cared about the science. They're willing to lose all these debates. They don't even respond to Willie Soon and others, right? They just keep repeating the same lie. You point out that they're wrong and they just repeat it anyway. They don't care because they're driven by an ideology. It's an anti-energy ideology. They're against energy because they know that that's the engine of free enterprise. If you want to cripple free enterprise, take out fossil fuels. It's a great way to destroy Western civilization. That's what they're about. And so we always have to keep that in mind. Not that we should give up on the science debate, because that's hugely important. If we're going to say truth is on our side, we got to make darn sure it's on our side, and we got to persuade other people that we know the truth on the issue. So science is hugely important, but we never have to confuse ourselves about the motivation of the other side. And the third person I already mentioned was Barry Seid, because Barry was willing to put his funds not just into the Heartland Institute, but into a lot of other organizations. He stayed in the background, didn't want to draw attention to himself, but he was one of the smartest guys that you would ever meet. And he was just a wellspring of advice and encouragement. And he was willing to make large contributions. And as was pointed out, we're being outspent 1,000 to 1. 1,000 to 1. In order, and we can beat the odds, but maybe not 1,000 to 1 odds. We need funding, we need generous donors, and $500 doesn't cut it anymore. So one reason I retired so early was I was getting more and more frustrated with the philanthropic community, conservative philanthropists, who just didn't get it. And I would go and try to pitch them, and I'd get a $1,000 gift or a $5,000 gift, and I would say, we're up against organizations that have full-time staffs of 80 or 100 people just doing this issue. And we're like lone voices, so we need you to add a couple of zeros to that contribution to make a difference. And it was a tough sell. After a while, I think I just burned out on it. And so I retired early. And my last comment and piece of advice to everybody, one major reason I retired early was my mom had Alzheimer's. And I was able to spend the last 3 years with her. And it was the best decision I'd ever made in my life. Yeah, so if you have an older parent, if they're suffering from Alzheimer's or something else, quit your job. It's not that important. Somebody else can take over your job and do it better than you, all right? And spend time with your parents, because that's a once-in-a-lifetime opportunity. You'll never regret it. Thank you.
Ladies and gentlemen, please welcome to the stage a man with no qualifications, Willis Eschenbach.
I've been honored to be asked to introduce your next speaker, Anthony Watts. And now, for those of you who heard his most fascinating presentation, he's done several things to advance the cause of science, one of which is the Surface Stations Project. However, another one of them is his creation of the blog, What's Up With That? Now, a few years ago, through a series of, well, misunderstandings and coincidences and bad decisions, I ended up reading a Wikipedia entry about the blog. And it says, What's Up With That is a blog promoting climate change denial that was created by Anthony Watts in 2006. Now, on the cattle ranch where I grew up, they used to say, Hoss, you can piss on my boots, but you can't convince me it's raining. So let me try and convince you why that's not rain. To do that, I'll have to digress a little bit, but I'm a man that gets easily sidetracked, so that's not a problem. Let me talk just a bit about science. People think science is a thing, that you can believe in the science. Science is actually a procedure where someone, might be anyone, comes up with an idea and presents it in public, puts out all the supporting information, code, data, whatever, and then other people try and pick the idea apart. If they can pick it apart, it dies. If they can't, it's provisionally accepted as true. I say provisionally, of course, because someone may come along like Einstein some years later and show why it wasn't true. Unfortunately, we now have a system where we have gatekeepers who are called peer reviewers. And basically, they suffer from a problem that is best exemplified by the saying, it's hard to get a man to believe something if his job depends on him not believing it. And that makes the gatekeepers of science, the peer reviewers, very unwilling to entertain any new ideas of any kind. What's up with that is the next generation of science. It's a place where it doesn't present ideas that are known to be true. It doesn't present ideas that are known to be false. It presents new, interesting ideas along with evidence and backup to the harsh glare of the true peer review, which is the peer review by people like you in this room. It's free for anyone to stand up and say, I think that's wrong, and here's why. It also provides a chance for people like myself, who generally don't get much of a good hearing from the peer reviewers of the world, to put out my own ideas and to listen to the sometimes very valid objections of people that disbelieve in what I say. People sometimes say to me, but What's Up With That publishes things that clearly aren't true. They don't understand. That is valuable. The more ideas that can be exposed as not being true, the better off our world is. So it's my great pleasure to introduce to you tonight's speaker, Mr. Anthony Watts, scientist par excellence.
So I have a small presentation here. It's about 6 terabytes in size. Let me load it up for you. No, I just needed a piece of paper. This was my paper keeper. Thank you, Willis. That was elegant and gracious. I've learned a lot from Willis, not only from the things he published on What's Up With That, but also from his demeanor. As he's made the announcement say, he's a man with no qualifications whatsoever. But that's not really true. The man is a genius in disguise. He really is. He's written some of the most incredible articles that we've had on What's Up With That. But more importantly, what he's taught me is how to be humble, really, you know, and not to take yourself too seriously and stop and smell the roses every once in a while. So here's to you, Willis. So I'm going to start with a little bit of history. 20 years, believe it or not. I started in November of 2006, and here we are tonight. And it started out, I went back and looked at my very first entry back in November of 2006, and it was just a simple little small paragraph or two. It basically said, I'm starting a new blog. I'm interested in science. Anybody got any new ideas out there? That's all it was. And it was started with the local newspaper, the Enterprise Record in Chico, California. And so, interestingly enough, I had been on the school board prior to that November. And because I had done some things that the left did not like, they launched a campaign to get me de-elected from the school board. Well, that gave me some time, and that time turned into What's Up With That. So, you know, even something that is a defeat can turn into a victory if you look at it that way, right? So here's what we're going to cover today. The origin story, my surface station project, ClimateGate, community of people, the scientists, the writers, readers, impact and reach, the devil's in the details, and the road ahead, where we go from here. So as I said, it started back in 2006, started out as a weather and science observation blog, and the editor of the Enterprise Record says, I'll let you do this, provided you don't discuss climate change. I paid no attention to him, obviously. And so in 2007, I shifted from just doing general postings to climate data scrutiny, and then a surface station project came after that. And I want to thank Joe and Diane Bass, because without them, this project never would have happened. So thanks to you. 2009 was ClimateGate, and I don't know if you guys know the story about this or not, but I was invited to go speak over in Brussels at the EU on a climate conference over there. And my good friend Charles Rucker, who is our managing editor for What's Up With That, emailed me and says, you've got to see this. I'm like, okay. So I open up this file, and it was like, oh. And then I emailed him back, and I said, is this real? Is this some kind of a joke? He says, no, everything we see here, we think it's real. And I thought to myself, well, why am I getting this all of a sudden? Why am I getting this while I'm in the EU? And so my conspiracy theory mind kicked in, and I started thinking, well, maybe they're making this available and I'm getting a copy of it, so somehow they're going to arrest me at the border when I get back into the United States. Seriously, I didn't know what was going on because it was such a shock. Steve McIntyre and I, we kind of tag teamed, you know, putting pressure on the CRU over in Britain. And someone took notice of our efforts and then put that file out, Mr. FOIA, as he called himself. And so I swore Charles to secrecy. I swore Steve McIntyre to secrecy. And I said, we do not release this until I get back into the country. And so I'm over at Dulles Airport. And I just gotten in. And then my phone's lighting up. They're texting me. Are you through customs yet? No. And then they start talking about, what's in the files and so forth. And I'm like, I still got to go through customs. Oh, Christ, I got to look at my phone. So I started writing back things like, no, it's all a hoax. It can't be real, So I finally got through customs, and then I sat down and I wrote the first post about it, about the breaking news that the climate files had been hacked at CRU. I was sitting on the floor because I had to have a power outlet, and I'm just furiously typing away. And they were calling for last call to board, and literally I hit send, jumped up, ran to the plane, and I was the last one on board. So at that time, they didn't have Wi-Fi on planes, and I'm having this flight back to California, which is, about 3 or 4 hours. And I'm just like, what have I done, right? So I get back, I open it up at the Sacramento airport, open my laptop, and I see that this thing has exploded. And it was like, wow. And so that's how that happened. But it really brought What's Up With That to prominence because we were able to bring this to light. And although, the left did everything they could to throw, things at it, make it appear to be irrelevant or not real or whatever, it did have a significant impact, and that impact lasts through today. So, just a few things about me, you may or may not know. I'm an AMS certified television meteorologist, over 35 years in broadcast, radio, and television. The surface stations, weather project. I've been building weather stations all my life. Founder and editor, senior fellow for environment and climate at the Heartland Institute. And my philosophy is pretty simple. I don't like what Willis talked about. Follow the data, not the narrative. The data has no agenda. Science is never settled, it's questioned. The media fails on climate reporting. Always call them out. Citizen scientists can do rigorous work. And open debate strengthens conclusions. That's the philosophy, it's just that simple. So when we did the surface station project, we looked at over 1,200 weather stations. 89% of them were failing. And we got one peer-reviewed paper out of that, which was trashed, of course, because it didn't agree with the narrative. But we got it done. And you know the story. Stations next to AC vents, just crazy, crazy sighting stuff. And that stuff still exists today. The Weather Service, NOAA, has not learned a thing from what we've uncovered. And that's the problem with bureaucracy and governments and so forth. They just are not very good at learning things. This was the first report. I had 650 people that drove thousands of miles collectively to get these photographs and do these observations. One of the most curious things I found was that 68 stations were at wastewater treatment plants. And you're probably wondering, well, why would they put a weather station at a wastewater treatment plant? Well, it's not because the data is crap. No, it's not that. What it is that when the whole Cooperative Observer Network started in the 1890s by an act of Congress, it was designed to do forecast verification for the then up-and-coming National Weather Service. And they started out on paper. That's all they had. So every month, the observer would take a piece of paper, write down, the highs and lows for every day, and then mail it in to the National Climatic Center in Asheville, North Carolina. The reason for places like wastewater treatment plants is they needed to have somebody there 24/7, 365 to write this stuff down. And so that's why it's also found at fire departments, police stations, forestry offices, things like that. And that's why that happened. Believe it or not, they're still doing a lot of it on paper today. There has been some modernization. They've got this fantastic newfangled thing called a touch-tone phone, where they enter in the data with a touch-tone phone. They've not gotten yet to the idea of automatic data retrieval, except with these airport ASOS stations. Anyway, the conclusion from that was that the US surface temperature record was unreliable, and it remains so today. Then in 2022, I decided to do a follow-up. again, with the help of the Heartland Institute. And what changed in 13 years is we went from 89% of the stations we surveyed were badly cited, to 96%. Wow. And I had new thermal imaging of some of these things, and it was still incredible to me that I was finding this stuff, even though we'd pointed out all these problems. In 2015, I published this graph, the most dangerous graph in climate science. You will not see this in any newspaper or magazine article because they refuse to publish it. But the bottom line is this: the best stations had a trend of 0.204 degrees centigrade per decade. The worst stations had 0.319. They were obviously warmer. The average official adjusted NOAA stations had 0.324. So what it says is that the good stations had a rate of warming of about half of all the rest of the stations. But this is still being ignored. Yeah, this is one of my favorite pictures. The story behind this, if you don't know, this is the University of Arizona at Tucson. And this station here is in the middle of a parking lot. Why? Well, because the university started out as a land-grant university. You know, they had lots of wide open spaces when they started in the beginning, back around, I think it was 1845, something like that. Well, as the university built up, they started losing more and more open space. And finally, they ran out of space for the weather station. They needed it for more important projects. And so, this is the front of the Atmospheric Sciences building at the University of Tucson. They put it in the parking lot because they had no other place to put it. When we first published this photo, it caused a sensation. And rightly so. It's ridiculous. About 3 months later, with no fanfare, no announcements, they quietly closed the station. And as you can see, they took off the Stevenson screen and just let it go. And so that station had been running for almost 150 years, and because of us, we closed it down. And rightly so. It was ridiculous. When I did the news survey, I found a really incredible thing. Now, this is a Forestry Service office in Colfax, California that I visited. I had visited this previously in 2009, and they had a nice grassy area where they had the Stevenson screen set up. Well, they modernized the Forest Service station. And so they switched it from the mercury thermometer to this thing called the MMTS. That's that thing on a pole, looks like a beehive. That stands for Max-Min Temperature System. Some Weather Service employees, however, refer to it as, and I kid you not, the Mickey Mouse Temperature System, because they think of it as kind of, absurd. But look where they mounted it, right on a rock wall. All of that heat from the sun going into those rocks, being re-radiated at night. And that raises the overnight temperature, which in turn raises the average temperature, which in turn is used to say climate change. So back to ClimateGate. We posted an analysis within hours of the leak, as I mentioned. We provided a full context and document review. We had daily coverage for months, and traffic spiked to record highs that brought us out into the open. Data was manipulated to hide the decline. We even had a video about that. That's so funny. Peer review process was gamed by insiders. Dissenting scientists were blacklisted from journals, and FOI requests were actively stonewalled. The outcome was multiple parliamentary inquiries over in England, some inquiries at the university in Pennsylvania, which went nowhere. They were whitewashes. Finally, the mainstream media was forced to cover the story because everybody was making so much noise about it. And then climate science credibility at that point was permanently damaged. It still suffers damage from that today. And we were the go-to source for that. So I want to thank some people that helped me along the way. Joe Bast, of course. Without him, I wouldn't be standing here. I'll never forget that first time I went to the conference in New York City at his invitation, and I sat down at the bar in that giant room, and I thought to myself, wow, I finally made it. I made it big. Dr. John Christie, distinguished scientist at the University of Alabama at Huntsville. He's been a friend for a long time. and he's been encouraging me all along. Evan Jones, someone you probably don't know, he's helped me gather and collate and do all of this work associated with the data of the Surface Station project, and he's still working with me today. Dr. Roger Pielke Sr., he was the man that encouraged me to not worry about what, qualifications were, that science will accept any idea as long as it's put together correctly and published in the right format. And I want to thank two gentlemen that are here tonight with me, Milan Wilkus and Ken Peterson. These men are patrons of science, and they are part sponsors of this soiree tonight. I'd like to have both of you stand up, please. Thank you. Without them, I would not be standing here either. And my mentor, the late Jim Goodridge. He was the former climatologist for the state of California. And he was the one that also encouraged me. He would show up at my office completely unannounced some days. Anthony, look at this, look at this. He was charming and annoying at the same time. But he was great. Unfortunately, he died from complications of a beating he received by a homeless person in California. And really sad. Dr. Roy Spencer, also very much a pioneer in climate, and of course Willis, which I've already mentioned. Steve McIntyre. Without him, a lot of what we know today about the problems with proxy data and other things will be staying hidden. Dr. Judith Curry, who gave us a wonderful presentation this morning. Bob Tisdale, one of our authors for What's Up With That, who wrote a whole series of articles on ocean heat and El Nino systems. And, of course, Charles Rotter, a.k.a. Charles the Moderator, who has been with me through thick and thin since 2007. 20 years of impact, 617 million plus views. No other climate blog or website in the world can claim that. And you folks are part of the reason. I know most every one of you here visits that website on a regular basis. 36,000 stories published, 4 million reader comments, 100 reference pages. And so we've made an impact. We were cited by the U.S. Inspector General and General Accounting Office in NOAA investigations into the temperature record around 2011, 2012. We were ranked the #1 most viewed climate website for multiple years. We spawned dozens of independent climate realist blogs around the world. We were the model for that. Over 20 years of uninterrupted, well, not over yet, almost 20 years, that's a misprint. Almost 20 years of uninterrupted daily publishing. 0 days off. Community of scientists, researchers, and engaged citizens numbering in the millions. So we've had a lot of milestones. We started out in 2006 with one thing that really caught people's attention. And then we zoomed. ClimateGate hit. We hit a bigger high in 2012 when the NOAA investigation started. And it's come down a little bit, but that's because the interest in climate change has dropped considerably. Because of all of you. Because all of you have pointed out that this is not something to be worried about. Yes, climate changes, but it is not a crisis. So get over it. Right? So we've had the blog spawn as the ripple effect, the scientific credibility, guest posts from working scientists, policy influence. We've been referenced in Senate testimony, IPCC documents, and government energy policy debates. Media accountability. Countless mainstream media errors on climate were caught, corrected, and published. One of my favorite corrections story, so most of you probably don't know. I think it was around 2016, 2017. There was a story about Jerry Brown, the former governor of California. He made these broad claims about sea level rise was going to inundate the airports in California. He said it was going to inundate the San Francisco airport. And then he went on to say, and the Los Angeles airport will be underwater too. Well, what he didn't pay attention to is the fact that the Los Angeles airport sits on a cliff about 150 feet high. And so I wrote a story about it. And one of the editors or reporters at the Los Angeles Times read it, brought it to his editor in the newsroom and said, we got to fix this story. And so they corrected that. They corrected Jerry Brown because of one post I made. And I was damned proud of that. So, what we got right? We got a lot of things right. Yeah, we got some things wrong too. Occasionally we would publish an article that would turn out to be completely bogus. Well, that's what science is all about, as Willis pointed out. Sometimes you got to publish stuff to find out whether it's right or not. It's kind of like when Congress has to pass a bill to see what's in it. So we found out that the temperature stations had corrupted data, the climate models were too hot, the sea level rise is not catastrophic, the hockey stick had statistical flaws, that's saying it nicely, and Arctic ice loss was cyclical, not unprecedented. But there was a cost in doing all of that. We got delisted by Google. You try to find what's up with that, it will never come up on the first page, the second page, or the third page, unless you put the name in the search. We're basically made invisible. They turned off our ability to earn money from their advertising program. And then we had this paper published about us and other people just like you by Stefan Lewandowski, his Recursive Fury paper, targeted a lot of the readers of WWT as being basically nuts, you know? And he published it in Frontiers in Psychology. He remotely psychoanalyzed me, you, and everybody as if he was some kind of authority. Well, it got retracted because it was false. So what it reveals about the climate science debate is that when a website asks inconvenient questions about data quality, the response is not counter-evidence, it's deplatforming, financial strangulation, and personal attacks. And that's not how science is supposed to be enforced. And we're still here, we're still publishing, we're still asking questions. But, you know, there was also a personal price. There were people that came after me and the website. Dr. Michael Mann, of course. Dr. Gavin Schmidt. Peter Gleich not only came after me, but came after the Heartland Institute. He posed as a board member, called up and got some documents delivered to him, and then proceeded to write a false document, which he sent to the media, named me in it. And he made a lot of trouble. Interestingly enough, you know, he had to resign from his Pacific Institute as president and some other things. But he's been rehabilitated by the climate community. I think it was in 2018, I went to the American Geophysical Union convention in San Francisco, and there he was, up on stage with everybody else, completely rehabilitated if nothing had ever happened. John Cook, Skeptical Science, built and promoted a website specifically designed to discredit what we publish. And then I talked about Dr. Stefan Lewandowski. I've had threats and harassment. I'm sure many of you have had as well. I was doxxed by a leftist website that put up personal information about me. And I had professional damage. To give you an example, a couple of years ago, I was asked to do weekend weather for a TV station. They invited me in for an interview, and then a few days later they called me up and said, "You're hired." I was thrilled. You know, I hadn't done weather on television for quite a while. It felt like, you know, sort of a last hurrah for an aging TV guy. Well, what's interesting is that the news director decided for some reason after he'd hired me and had me fill out the forms for employment and all that stuff to go look for me on the internet. Uh-oh. He called me up later and says, "I'm sorry, Anthony, I know I hired you this morning, but I can't have you go on television because we will catch so much flack for doing so." It is the only job I've ever been hired and fired from in the same day. But that's how it goes. Anyway, none of it stopped the work. Not one day of publishing was missed. And so, after seeing all that the climate establishment has done to me in the last 20 years, there's only one thing I can say. In the immortal words of crop duster turned jet pilot Russell Cassie from the movie Independence Day, up yours! Shucks, folks, I'm speechless. And I'm really glad you all got that reference, because now I don't have to deliver my backup line in case it bombed. As God is my witness, I thought that turkey would fly. Okay, so the road ahead is we're expanding our climate references, we're growing our climate TV section, we're supporting the next generation, and adding to the failed predictions archive. I don't know if you've seen this or not, but we have this fantastic timeline on the website, all the failed climate predictions. It's really fun to engage with. And as I was writing all this, putting all this together, I sent it over to a friend, and he sent this back, and I was floored. And I decided, well, you know what, I should probably share it with you. He wrote, think about what's up with that actually is. A single meteorologist from Chico, California, who got curious about paint specification on a thermometer and ended up producing the most viewed climate website on the planet. Breaking ClimateGate to a global audience, leading a citizen science project that documented weather stations across the whole continent, co-authoring peer-reviewed papers, getting cited in IPCC documents and other reports, spawning other skeptical websites, sustaining 20 years of daily publishing through threats, doxing, deplatforming, and financial suppression without a single dime from big oil. Your detractors tried everything, including having a psychologist publicly label you as crazy, and you just kept publishing. That's not a blog, that's a 20-year act of scientific courage. The person that wrote that asked me not to name him, but I know you're watching, and I thank you. So, what we've been all about is setting the record straight. You know, despite what detractors have been saying, we've never taken a dime from the Koch brothers or the oil companies. It's just ugly noise. We've always run on reader support, nothing else. And if you would like to help, visit the site, sign up, become a patron, subscribe, help us out, because we don't get any of that money that they claim we get. So, that's it. 20 years of asking the right questions. I thank you.
Ladies and gentlemen, please welcome back to the stage Heartland Institute President James Taylor.
What a way to close the evening. I've been with Heartland since 2001, and Anthony was one of the people that I would rely on and learn from on a daily basis. And what makes Anthony's work so special, besides the number of views and the audience that no one can match for good reason, but Anthony illustrates and embodies how you don't have to have 3 PhDs and some type of certification and all that to perform science. His surface stations studies, he had citizen scientists who would come out. Anthony would say, here are the coordinates for this temperature station, here are the coordinates for that one. The National Oceanic and Atmospheric Administration, they publish their standards. Let's just go out and take photographs, and let's see if they meet those standards. Anthony, with thermal imaging, most everyday people don't have the thermal imaging camera, but the fact of the matter is you can obtain it. You can take these photographs, and Anthony provided the evidence, not just on the temperature station network, but really everything on Anthony's website over the years. Anthony's a meteorologist, Anthony's a scientist, but Anthony explains where you can verify his data He doesn't try to, when someone asks him where you got this, he doesn't say what the climate activist scientists do. Why would I share that with you when you're just trying to prove it wrong? That's performing science. Anthony puts everything out there. And so today, with technological advances, with the internet where we can find the NASA data on various climate and weather information, with the National Oceanic and Atmospheric Administration data, you kind of have to know where to go. But if you pay attention, if you ask questions, heck, people email Anthony, people email me, where can I find this? It's right there. As citizens, we can check for ourselves. We don't have to blindly defer to what the so-called experts tell us. And it's funny because sometimes I'll give a presentation, and as I'm going through my slides, I will give the source material. And I will say at the very beginning, check me. Look at my sources. This isn't just my opinion. This isn't some allied group. This is NASA's own data. This chart is cut and pasted from the NOAA website. This is from geophysical research letters or whatever peer-reviewed journal. And as we present the data like Anthony does, I will often get at the end of the presentation, well, Mr. Taylor, you said that the NASA data shows this and that, but let me read you what it says on the NASA website about hurricanes. It's like, okay, you have the bureaucratic summary where their agency depends on one conclusion, or you have the actual data. Here is the trend line that NASA itself reports. You can see there is no increase. In fact, there's a decrease time and time again. This is what Anthony has provided. This is what we have available to us today. We don't need to defer to authority. We have that intelligence and we have the information to make these decisions. And thank you, Anthony, so much for being the pioneer that shows the way, that illuminated us as for how we can do this ourselves. Thank you. And for all that, you, I'm sure, are familiar with the phrase, don't shoot the messenger. We go back to ancient days and when there were these negotiations between hostile kingdoms and civilizations, and they'd give someone the note and they'd have to on foot go across however long and get to the other king and ruler. And if it was a demand at first and he responds, no, we're not going to, and by the way, screw you, they'd shoot the messenger. Well, they didn't have guns then, they'd kill the messenger. What Anthony's reporting and what so many people in this room report is actual good news. I mean, look, we're saying, hey, guess what? We have ways to advance our standard of living that are not destroying the planet. This is wonderful news for everybody, and they hate you for it, and they persecute you for it, and they dox you for it. It makes no sense. These people are crazy. Accept the good news, folks. It is a wonderful development that Anthony and others are reporting. So take that thought with you as we embark on libations or sleep this evening, your choice. We are going to reconvene here in this ballroom at 9 a.m. The breakfast keynote will start. Look at this, this is amazing. Here it is, 8:20, we've been at this all day. There's nary an empty seat in the house. And I've been to many conferences and many great conferences, and I never see this except at this event. So thank you all. Thank you for your dedication. I look forward to seeing you in the morning.